Hello and welcome. My name is Stephen Greider, and I'm really excited to teach you everything I know about TypeScript. But before we get started, I just want you to know how you can get help if you ever get stuck inside this course. So if you ever run into some trouble and you're having a little bit of difficulty with troubleshooting, make sure you check out these different sources for getting help. The first place to check is the Udemy QA discussion boards that are here inside this course. You can also reach out to me via direct message on Udemy as well. And finally, if you need some really fast response, you can also get a hold of me on Twitter, but just be aware that if you message me on Twitter, it's sometimes a little bit challenging to communicate on there. So in general, best to ask questions on the discussion boards or via direct message. Just so you know, I usually check messages on all these different channels once a time, once per day, on Monday through Friday, around 9 or 10 or 11 Mountain Standard Time. So that's usually when you're going to get a response from me. Okay, so let's take a quick pause right here and start discussing TypeScript in the next video. Now that we've gotten through some administrative stuff, we're now going to dive into our first technical topic and start to discuss exactly what TypeScript is. So, what is TypeScript? What are we doing here? Well, at the end of the day, I want you to imagine that when we write TypeScript code, we are really just writing JavaScript. That's what's really happening here. We're still writing JavaScript. All the knowledge you have around JavaScript, like arrays, objects, functions, and even ES 2015 syntax like destructuring and arrow functions and classes, all that knowledge still applies to the world of TypeScript as well. The only thing that we're really doing with TypeScript is adding in a little bit additional syntax to our code to handle something called the type system. This is what TypeScript is all about, as you might guess, and it's what we're going to spend the vast majority of this course learning about. So let's get a quick overview on the type system and understand what's going on with it. The goal of the type system is to help us catch errors during development. In other words, when we're actually writing our code in our code editor. Think about how we catch errors right now with JavaScript code. Let's imagine that you're writing out some amount of JavaScript inside of your editor, and maybe there's a bug inside of it. How would you find that bug? Well, really, with JavaScript, the only way to do that is to actually execute your code and see that error appear. And that's not super efficient. So as an improvement to the development workflow, we use the type system to help us catch errors during development. While you and I are writing our code, TypeScript is going to be constantly analyzing it and looking for bugs. If it finds any possible bug, it's then going to pop open an error message inside of your code editor and tell you, hey, something might be wrong here. And that's going to essentially be a signal to you as the developer that you might need to fix up your code. Now, to do this error checking, the TypeScript compiler is going to use something called type annotations to analyze our codebase. You and I are going to be responsible for adding in these type annotations. You can kind of think of these type annotations as being like little comments to describe the purpose of our code or the information that is flowing through our program. The type system is only active during development. So in other words, once we go to deploy our application or even run it inside of our browser in a development environment, the entire type system falls away. Your browser has no idea what TypeScript is, and Node.js likewise. Node.js has no idea what TypeScript is either. So all this extra syntax that we're going to add into our code never makes it into the browser, it never makes it into Node.js. We're going to first compile our TypeScript, and we're going to get some JavaScript out of that. And that JavaScript is what we're going to actually execute. Finally, this is something I want to point out just because it's a little bit different than other languages that are strongly typed. The TypeScript compiler does not do any performance optimization whatsoever. Now, this is very different than many other languages. In many other languages, the type system can be used to optimize some code that you write using the compiler. But that is not the case here with TypeScript. All right, so to kind of help you understand this process here, let's run through the common scenario of how we're going to actually write some code and run it inside the browser or with Node.js. So you and I are going to write some TypeScript code inside of our editor. And remember, we can think of TypeScript as really just being plain JavaScript, but with these type annotation things added in. Then once we want to actually run our code, we're going to feed that code into the TypeScript compiler. This is a command line tool that's going to read our code, check it for any possible errors, and then convert it into plain JavaScript. You and I are then going to take that JavaScript code and feed it into the browser or into Node.js and finally execute it. So again, we do not execute TypeScript. We always are executing JavaScript. And so when I say that you and I are still writing technically JavaScript code here, it is because the code we're writing, it is going to end up as JavaScript. Just it has these extra little type annotation things in it. All right, so to give you a really practical example of this, I want to show you a quick little web page here. This is a in-browser TypeScript compiler. So I'm going to open up this link inside of a new browser tab. Now on the left-hand side, you're going to see a little bit of TypeScript code. And I know this is kind of cut off right there, but I just want to give you the impression that this TypeScript right here has a bunch of additional syntax in it, all right? Just take a look at this code. We don't need to understand what it does. You can tell at just a glance that there's a lot of extra stuff in here, and it does not look like normal JavaScript. So on the left-hand side, we've got the TypeScript. This page is going to compile that code and then print out the equivalent JavaScript on the right-hand side. So this is the output from the TypeScript compiler. And looking at that, yep, it sure looks like plain JavaScript. So I can't say it enough. Like I said, I'm going to repeat it many times throughout this course. We're still writing JavaScript code. We're just adding in little extra pieces of syntax here and there. And these extra pieces of syntax are meant to help the TypeScript compiler understand what we're trying to do with our code base so it can help us catch errors. That's it. That's the entire TypeScript world. All right, let's do a quick wrap up on what we learned in this video. So first off, when we write TypeScript, we're still writing JavaScript. We're just adding in these extra little type annotation things. Secondly, TypeScript has no effect on how our code actually gets executed. In other words, there is no performance optimization or anything like that. Now finally, the best way to think of TypeScript, in my opinion, or kind of an effective analogy, is to think of TypeScript as being like a friend who is sitting behind you while you are writing code. And maybe that friend is looking at every line of code you're writing and helping you catch errors. That's what TypeScript is really doing for us. It is a helper to help us catch errors. It doesn't actually have any impact on the final code that we output or the actual code that we run inside the browser. It's just there during development. Okay, so now we've got a better idea of TypeScript. Let's take a quick pause right here, and we're going to do a little bit of environment setup in the next video. In this video, we're going to do a little bit of environment setup. Once we set up our local machine to work with TypeScript, we'll then begin working on our first project. So let's get to it. The first thing we'll do is to install the TypeScript compiler. To install it, we're going to use npm. Now, if you're here in this course, I'm going to assume that you've got a basic understanding of both Node and npm. So I'm going to assume, in particular, that you've already got Node and npm installed on your local system. If you don't, you'll want to do a quick Google search on how to install Node on your local machine. Again, I'm really assuming that you've got that knowledge ahead of time. So we're going to use npm to install TypeScript as a global module. We're also going to install a second module called tsNode. tsNode is a little command line tool that allows us to compile and execute TypeScript with one command at our terminal. We're going to use it in the first half of this course just for running some TypeScript very quickly without having to set up a full tooling installation kind of deal. So let's get to it. I'm going to open up my terminal. Once over here, I'm going to run npm install -g, and I'll get TypeScript and ts-node like so. All right, so that's going to take just a moment or two to install rather quickly. Once it is installed, I can then make sure that it is successfully installed, and then I can run the compiler by running tsc --help, like so. So we installed a package called TypeScript. It gives us access to a command called tsc, which is short for, as you might guess, TypeScript compiler. This is what we're going to use to actually compile our TypeScript code into plain JavaScript. So if I run this command, I should see a bunch of help messages appear on the screen like so. If you see any error, that means that your npm installation probably has a little issue and you'll need to do a little bit of troubleshooting. Okay, so that's pretty much it for the actual TypeScript setup. Now we're going to walk through a little additional setup here for setting up Visual Studio Code. Now this is a code editor. If you've already got Visual Studio Code installed, I encourage you to still watch this video because I'm going to show you some settings that are important for you to have. If you want to use another code editor inside this course, that's totally fine. I've tried out many other code editors, and personally, I think that Visual Studio Code is one of the best ones out there for working with TypeScript. So if you've never used it, I would recommend at least try it one time. So I'm going to go through the installation process here really quickly. I'll first go to that link inside of a new browser tab, and I'll find the green download button on the left-hand side. Once I download this zip file, I'll then open it up. That's going to extract it. Here's the Visual Studio Code application. And if you're on Mac, all you have to do is drag and drop that into the Applications folder. If you're on Windows, you're going to instead see a little installer. All you have to do is go through the installation process. It's just a couple clicks. Now that we've got VS Code installed, we're going to do just a couple steps of configuration. So this is what we're going to go through. I'm mostly showing you these configuration steps just so you understand the exact settings that I'm running locally. Now, just to be clear, I just did a fresh installation of VS Code, like I completely deleted my previous installation. So when I go through these settings, you're going to see a fresh installation being set up here. So I don't have any previous setup whatsoever. All right, so let's get to it. The first thing I'm going to do is open up Visual Studio Code. And it's going to take just a moment this first time that it boots up to actually open. So I'm just going to let it do its thing. All right, there we go. All right, so once I've got Visual Studio Code open, we're going to go through each of these different setup steps right here. So the first thing I'm going to do is set up code in my path variable. Now what this essentially does is allow me to launch my code editor from the terminal, which I'm going to be doing quite a bit throughout this course. So to do so, I'm going to go over to the editor, and then I'll go up to View, and then find Command Palette. And then once here, I'm going to search for add path. Actually, not add path. I think it's install path. Yeah, there we go. So install code command in path. All we have to do is click that, and that's pretty much it. We'll see a little notification down here. If I now flip on over to my terminal, I can open up a new window. Make sure you open up a new window. If you try to run this command in an existing window, it's probably going to fail. And then once over here, you can open up your code editor in any directory by running code and then dot, like so. Now, as you'll see, it'll pop open my code editor right away. All right, so let's keep going through these installation steps. The other ones are going to be pretty quick. So the next one is going to be to install the Prettier extension. Prettier is a code formatter. It's going to take a look at your code every time you save a file and automatically format it in some fixed fashion. So I usually use Prettier just to have some very consistent looking code. And I highly recommend you try it out as well. To install this extension, I'll go back over to my editor. I'll find View. I'll then look for Extensions. And then on the left-hand side, I'll search for Prettier. And it's going to be the first one right here by Esben Peterson. So I'll hit Install. And that's pretty much it. Now we're going to do a little bit of configuration on Prettier. We're going to make sure first that it formats every file when we save it. So to do so, I'll go back over. I'm going to again go to my View menu. And then I'm going to look for, not View, I'm looking for Preferences, or excuse me, Code Preferences Settings. There it is. And then once I've got the Settings tab up right here, I'll do a search for Format on Save. And I'll see a setting right here called Format on Save. So we just have to check that, and that's pretty much it. Next up, I'm going to configure Prettier to use single quotes. Now this is entirely personal. If you want to use double quotes, totally fine. You can use either single quotes or double quotes safely with TypeScript. I just prefer single quotes. So to set up Prettier to format my code in that fashion, I'll go back over to my settings page. I'll look for single quotes. And I'll scroll down just a little bit right here, and I'll see a setting called Prettier single quote, and check it. All right, next one is I'm going to make sure that I use 2 spaces for indentation as opposed to tabs. Again, this is very personal. You can go either way. I personally like to use 2 spaces for indentation. So to do so, I'm going to delete the search term up here, and then scroll down on the default settings here just a little bit, and I should see tab size right here, and I'll just change it to 2, like so. All right, so last thing, I'm going to set my theme to be solarized light. So that's just going to change the coloring of my editor a little bit. So to do so, I'm going to go back over once again. I'll look for theme. I'll find color theme right here. Right now the default is dark, and I'm going to change it to solarized light instead. And that's it. Okay, now one last little thing I'm going to do here. I am going to hide this bar on the left-hand side. I can find that setting by looking up activity bar. So workbench, activity bar visible, and I'm just going to deselect that so that little bar on the side goes away. All right, so that's it. That's all the configuration I do to my editor. So if you went through these steps, you now have an editor that's set up identically to mine. So now that we've got everything set up for our local environment, let's take a quick pause right here, and we're going to start writing some code in the next video. In the last video, we did a little bit of environment setup, and now we're ready to start working on our first project. So let's talk about what we're going to make. All right, so we're going to start off with a very simple first little application. We're going to make a little tiny application that's just going to make a network request to some outside API, fetch some data, and then we're going to try to print that data inside of our terminal. And that's it. Now with this first application, I'm not trying to teach you any specific syntax or anything like that. I just want to show you why we use TypeScript in general. So as we write this program, we're going to accidentally, quote unquote, kind of accidentally, introduce one or two bugs into our application. And then we're going to very quickly see that TypeScript has the ability to help us catch those bugs while we are writing our code, as opposed to when we execute our code. So again, the point of this application is just to show you the typical workflow of TypeScript. That's it. All right, so with that in mind, let's talk about the flow that we're going to go through to actually build this application. So step one, we're going to take a look at the API that we're going to use to fetch some data. After that, we're going to create a new project directory. We're going to create a package.json file inside there, and then install Axios as an NPM module. Axios is a little module that we're going to use just to make a network request. If you've never worked with this module before, totally fine. Axios doesn't really have anything to do with TypeScript. We're just going to use it to make a network request. That's it. So once we do all that setup, then we'll start to write out some code. All right, so on to step number one. Let's take a look at the API that we're going to use to fetch some data. So here's a link to the API right here on the screen. Now this is a fake API. In other words, it serves up fake data that we can use just for like testing or learning purposes. In other words, it's perfect for what we are trying to do right now. So I'm going to pull up that documentation inside of a new tab, and then scroll on down to a section called Resources. All right, so here's Resources right here. So these are all the different types of records that we can make a request to or attempt to fetch from this API. We're going to attempt to fetch this list of to-dos right here. So I'm going to click on that /to-dos link. As soon as I do so, you're going to see a ton of information appear on the screen. You'll notice that on my screen, it appears to be very nicely formatted. If it looks like a big blob of text on your screen, that's totally fine. I've got a little Chrome extension to automatically format JSON data for me. So if we make a network request to this URL right here, we're going to get back a big list of fake to-do items. Now we don't really need this whole list. I just want to try to fetch like one individual item. So to fetch just this first item off the list, or the to-do with an ID of 1, we can modify the URL up here slightly. So at the very end of the URL, I'll add on /1, like so. Once I visit that link, I'll then see a single to-do appear on the screen. So this is the exact data that we want to fetch. I want to fetch this data inside of our application, and then just try to print out some information from this to-do to our terminal. Like I said, that's it. All right, so now that we understand the API we're going to work with, we'll now flip on over to our terminal and create a new project directory. So over inside of my terminal, I'm inside of a workspace directory of sorts. You can place this folder anywhere on your machine that you want to. I'll make a new project folder inside of here, and I'm going to call it fetch.json. I'll then change into that directory, and then I'm going to generate a new package.json file inside of here. Remember, package.json files are used to record all the different dependencies that we install into a project. Normally that's the case for JavaScript projects, but it's the same thing for TypeScript as well. We record dependencies inside of a package.json file. So to generate that file, I'll run npm init-y. That's going to generate that file, and now I can safely install that Axios module. Remember, Axios is going to be used just to make that network request. So to do so, I'll run npm install Axios, like so. Now Axios is really small, so this should install rather quickly. Once it's all done, I'll then open up my code editor inside this folder, and we'll start to work on our project. All right, so here we go. I should see inside of here the package.json file, and the node modules directory, which has that Axios project or module that we just installed. So now that we've got everything set up, let's take a quick pause right here, and we'll start to write some code in the next video. Now that we've got our project all set up and ready to go, we can start to actually write out some code. So to get started, I'm going to create a new file inside my project directory called index.ts. Notice the file extension on here is .ts. That's short for, as you might guess, TypeScript. We're always going to place all of our TypeScript code into .ts files. So now inside this file, we can start to actually write out some code to implement our program. And just as a quick reminder, our goal here is to fetch some JSON data and print the result. For this first program, we're going to speed through the implementation very quickly. It's not going to have a lot of TypeScript-specific syntax in it just yet. Remember, the goal of this first application is not to learn a bunch of different TypeScript syntax. Instead, I just want to show you why TypeScript is handy. So to get started, we're going to first import that Axios module that we just installed. At the top of the file, I will write out import Axios from Axios like so. After that, I'm going to flip back over to my browser, go to that JSON placeholder endpoint right here, and copy the URL that's going to give me just the first to do. So I'll copy that URL, then go back over to my editor. I'm going to create a variable called URL and assign that URL to it, like so. So now that we've got the URL in here, we can use Axios to make a network request to this URL. To do so, I'll write out axios.get, and then I'll pass in that URL. So that's going to make a HTTP GET request to that URL and attempt to fetch that JSON data. That entire operation is async, so by calling axios.get, we're going to receive a promise in return. So to get a notification on when the request is complete, we can chain on a .then statement that will be called with the response once we get a response from that API. So then inside of here, remember the goal here was to just console log out the JSON data we get back. So I'm going to console log response.data, which should be the actual to-do that we received back from that API. All right, so let's save this. That's the entire program right here. We are going to make a couple changes to it in just a moment, but let's just try to figure out how to run this code now. Remember, we cannot run TypeScript code directly inside the browser or with Node.js. We have to first compile this file into plain JavaScript, and then we can execute the resulting JavaScript code. So to compile this file right here, we will flip back over to our terminal. Inside of my terminal, I'm going to use the TypeScript compiler that we just installed 2 videos ago. We can access that compiler by writing out TSC. Remember, that stands for TypeScript Compiler. And then I'll feed in the name of the file that I want to compile. I'll run that command, and then I'll get kicked back over to my terminal almost instantly. So it seems like nothing happened, but the compilation did occur. If you flip back over to your code editor and look at the file explorer on the left-hand side, you'll see that we've got a new file inside of here called index.js. So that is the compiled version of our TypeScript code. You can open up that file, and you'll see what TypeScript did to our code base. All right, so now to run this, we can use the node command line tool, and we'll run node index.js, and that will execute the compiled JavaScript file that we just created. So back at my terminal, I'll run node index.js. Notice the extension on here, we are running the JavaScript file. So if I run that command, I'll then see the to-do printed out on the screen. Perfect. All right, so as you might guess, having to always run tsc index.ts and then and then run that resulting file gets really old really quickly. So to combine these 2 commands into just one, we also installed a little module 2 videos ago called ts-node. ts-node is going to combine these 2 commands into one. So it's going to automatically compile a given file and then automatically execute the resulting JavaScript. So it's just saving us from having to run that one extra command. So we can run ts-node and then the name of the TypeScript file that we want to execute. So index.ts. So I'll then run that command. And then I should see my JSON printed out. Yep, there we go. A little bit of a pause there. I guess my internet connection is a little bit spotty right now, but I saw the printout right there. So in one step, we compiled and then executed the resulting JavaScript. Okay, so that's how we put together a very basic TypeScript program and then execute it at the terminal. But I still haven't really shown you anything around, why TypeScript is handy here. So let's take a quick pause, and when we come back in the next video, we're going to start making a couple changes to this program, and then we'll very quickly see why making use of TypeScript is really, really handy. So quick pause, and I'll see you in just a minute. In the last video, we were able to write out some code to fetch a single to-do and print it out at the terminal. Now everything works pretty well, but this console log right here is kind of ugly and it's hard to understand in this kind of object format. So in this video, I want to pull off the ID, title, and completed flags and print them out in a nicer format, kind of like a little report of sorts. So let's try making some changes to our code base. I'm going to flip back over to my editor, and to get started, I'm going to first get a direct reference to the to-do, which is that data property right there. So I'm going to essentially pull off that data property and assign it to a separate variable, again, just to make it easier to work with. So I'll say const to-do is response.data. So now that we've got the to-do, we can pull off the ID, the title, and completed properties. I'll assign them to some temporary variables, and then we can insert them all into a single string and console log that string to essentially put together our report. So I'm going to pull off those three properties that we just took a look at. So I'll say const ID is todo.id. I'll get title as todo.title. And I'll say finished is todo.finished, like so. Now, if you're looking at these three lines of code and thinking, hey, Steven, you just messed something up right here, that's totally fine. Just bear with me for a second. If you're looking at this code and you don't see anything wrong, that's totally fine as well. Again, just bear with me for a moment. So now underneath that, we can start to print out a nice little report here. So I'll do a console log. To print out this as a nice little report, I want to use a multi-line string that is capable of using string templating. So I want to kind of inject some variables into the string. To do so, we can use a template string, just as you might be familiar with from ES 2015. So inside of here, I'm going to put a set of backticks. Remember, these are backticks. It's the character to the left of the 1 on your keyboard. They are not single quotes. I'm going to turn this into a multi-line string. And I'll say something like the to-do with ID a colon, and then I'll print out the ID. And I'll just print out the title underneath. I'll say has a title of $title. And I'll print out whether or not it is finished. So I'll say something like, is it finished? And I'll print in the finished variable, like so. All right, so that's a little bit nicer to read report right there than the plain console log that we had before. So let's save this file and then attempt to run it at our terminal. So I'm going to flip back over to my terminal, and I'll run the file in one step using tsnode once again. So I'll say tsnode index.ts. Remember, we are feeding in the TypeScript file here. We're not making use of the plain JavaScript file anymore. So I'll run this command, and sure enough, I end up seeing undefined, undefined, undefined. Well, what's up with that? That's kind of unexpected. We just saw all that data appear correctly a moment ago when we did the console log. So that means that we must have made a mistake somewhere in here. So what is going wrong? Well, let's take a quick pause right here. When we come back in the next video, we're going to make sure it's really clear what's wrong with this program, and then we're going to start to discuss how we can easily use TypeScript to avoid making the error that we just made inside of here. So quick pause, and I'll see you in just a minute. In the last video, we updated our program so we print out a nice report about a single to-do. However, when we then ran that program, we saw 3 undefineds inside of our terminal. So let's figure out what's going wrong. I want you to take a look at these 3 variable declarations right here. In every case, we tried to pull some property off of that to-do object. So we tried to pull off the property capital ID, capital T title, and finished. So that's where we made our mistakes. Take a look at those property names right there. And then I'm going to flip back over to my browser and take a look at the actual property names that belong to that title, or excuse me, that to-do object. The actual property names are lowercase ID, lowercase title, and it's not finished, it's completed. So what's the lesson here? Well, the lesson is we wrote out some code that had a very nasty bug inside of it. But we were not made aware of that bug. We didn't even know it existed until we actually executed our program. So this right here is exactly what TypeScript is made to prevent. TypeScript is going to help us catch errors like these simple typos we just made right here while we are still writing code inside of our code editor, as opposed to when we actually execute our code. So let's start to now make a couple changes to this file. We're going to add in a little bit of basic TypeScript syntax that's going to help us very easily catch the errors that we just made. Now remember, as we start to write out this TypeScript stuff, we're not really focused on TypeScript just yet. So like the syntax, don't worry about it too much just yet. We're going to go over all the syntax in great detail over time. For right now, I just want you to see how TypeScript can help us fix the errors that we just made. So I want to focus on this response.data object right here. You know what would have been really nice? It would have been great if we had a comment somewhere in here, like maybe right above. Maybe if we had a comment that said response.data has properties of, and then we just like listed the property names out and said like ID and title and completed. If we had some comment like this right here, then it probably would have been way less likely that we would have made those typos because we would have seen some information about that data object or the to-do right there on the screen right above. So this comment right here is essentially what we're going to add in, but in TypeScript form. So I'm going to delete that comment, and right above my Axios call, I'm going to write out our first little bit of TypeScript. So I'm going to say interface to-do. I'm going to put down a set of curly braces, and then I'm going to write out the 3 different properties that the to-do has. And I'm going to also label the type of data that each of those properties reference. So I'm going to say ID is a number, and I'll put a semicolon at the end of the line. I'll say title, a colon, and then string and a semicolon, and then completed, which was a Boolean, like so. All right, so this is, like I said, our first little bit of TypeScript. This defines something called an interface. Interfaces in TypeScript are used to define the structure of an object. So as you might guess, we are saying that inside of our application, there's going to be some kind of object called a to-do. And every to-do is going to have 3 distinct properties. It's going to have one property called ID, it's going to have a title, and it's going to have a completed property as well. The ID is going to be a number, title is going to be a string, and completed is going to be a Boolean, so either true or false. I did not make these property names up, or excuse me, these types right here up on the fly. If you actually go back over to that JSON printout right here, you'll see that ID was in fact a number, title was a string, and completed was a Boolean. So I created that interface to tell TypeScript about what type of information we're going to expect to receive back from this API. Now you'll notice that at this point in time, I'm completely ignoring this user ID property, and that's totally fine. Inside of an interface, we can freely ignore properties if we want to. We'll go into more detail on that later on. So now that I've told TypeScript about this type of object that's going to exist inside of my application, I'm going to now go ahead and tell TypeScript that this response.data thing right here is going to be one of those to-dos. So right after response.data, I'm going to say as to-do, like so. And then as soon as I do so, I'm going to get 3 errors right here light up inside of my editor. So this right here, this is what it is all about. TypeScript has analyzed our code using the type annotations or type labeling that we've added into this program. And it has found that we might have a possible error. So it has now underlined these 3 properties to tell us, hey, developer, you might be doing something wrong here. You need to take a look at this and figure out if this is correct or incorrect. So in this case, we would hover over each of these little errors, and we'll see a little message right here that tells us that exactly what might be going wrong. So in this case, it says property ID does not exist on a to-do. Did you mean lowercase ID? And that right there, that is the perfect amount of help that we need to somehow fix up this code. So instead of capital ID, I'll change that to lowercase ID, and then that error message goes away. Now, just to be totally complete, I'm going to also change the name of the variable to lowercase ID as well, just to be consistent. And I'll update the console log down here to lowercase ID as well. So now we would repeat the same process with title. I'll mouse over, and it says, did you mean lowercase t title? Well, in fact, yep, I did. And then finally with finished, I'll mouse over, and in this case, it just says, hey, that property just does not exist here. You probably meant to reference something else. And so once again, this would be my signal as a developer that I probably did something wrong here and I need to fix this up. So I could go and take a look at my definition of what a to-do is once again, and I'll see, oh, the property name is completed, not finished. And so I'd go back down and update this to be completed. And once again, I'll change the variable name as well, even though technically I don't have to. And completed down here as well. All right, so now if we save this program again, we can flip back over to our terminal and attempt to run this once more. So I'll do a ts node index.ts. And then once I do so, I'll see the correct output at my console. All right, perfect. So what's the lesson here? Well, like I've said several times so far, the goal of TypeScript is to help us catch errors during development. Notice how we didn't see an error during the compilation phase. We didn't see an error with our program when we actually ran our code. We saw an error as soon as we defined this interface thing and then told TypeScript that this object right here was going to have the same structure as what is described by a to-do. As soon as we added that in, we got some feedback while we were writing our code. And that was the key. That was the signal to you and I as a developer that we had to fix something up. And once again, that is what TypeScript is all about. All right, so now that we've got a little fix in here and everything's looking a lot better, I want to make one more change to this program. So let's take a quick pause right here and we'll continue in the next video. In this video, I want to make one additional change to our program. I want to take this console log statement and extract it into a separate helper function. So that will allow us to leave this promise body right here a little bit more compact than it currently is. So to get started, I'm going to define a new function at the bottom of the file. I'm going to call it log to do. I'm going to set this up as an arrow function, and I'm going to say that when we call this function, we should take in the arguments ID, title, and completed. Now, if you see a little nasty underline right here, like a yellow or even a red underline, that's totally fine. Just stick with it for a moment. Once I define that function, I'm then going to cut and paste the console log inside there, like so. So now we can call that function from up here, and that will do our console log for us. So I'm going to call log to do, and I'll pass in the ID, that completed flag, and the title like so. Now, once again, if you're looking at this and you're thinking, Steven, you just made an error there, that's totally fine. Once again, just bear with me for a moment. So I'm not going to save this file, and I'm going to flip back over to my terminal, and let's try to run this once more. So I'll do a ts node index.ts, and my program runs, but if you look carefully, the console log is not quite right. So it says, has a title of false. Is it finished? Delectus aut autumn? Something's definitely off here. So what did we do wrong? Well, if I flip back over and look very carefully, you'll notice on my log to do function, I was expecting arguments in the order of ID, and then the title, and then completed. However, when I called the function, I passed in ID, then completed, and then title. So I clearly mixed up the order of arguments into the function. And once again, I got absolutely no information about the error that I just made until I actually executed my code at the terminal. So once again, here's the lesson about TypeScript. If we're not using TypeScript correctly, or if we're just writing out plain JavaScript, we don't find errors until we run our code, which is pretty inefficient from a developer perspective. So if we used TypeScript appropriately, we could have gotten a warning about this or some error inside of our editor before we ran our code, and that would have been a signal to you and me that we had to fix up something. So how are we going to fix this up? Well, I'm going to find my log to do function right here, and on each of these arguments, I'm going to add in a type annotation. So we've used that term several times so far. Remember, we're going to really clarify all these TypeScript topics in just a moment. So for right now, just bear with me. We're going to add in a little bit of TypeScript syntax here. So I'm going to say that this ID variable, whatever we pass in here, it has to be a number. And then our title, it has to be a string. Remember, that makes sense. Our title is going to be a string. And that completed flag, it has to be a Boolean, either true or false. So we've now written out ID, number, and then the same thing for the other two arguments as well. Now this is not creating an object or anything like that. Instead, we are trying to describe the type of variable that ID is going to be, the type of variable that title is going to be, and the same thing for completed as well. Now, as soon as I add that in, I can then see a red underline under the completed flag right here. And if I hover over it, it will tell me argument of type Boolean is not assignable to parameter of type string. So what this is telling me is that completed is supposed to be a Boolean, right? That's what this is. Completed is a Boolean. It is a true or false value. And I tried to pass it in as the second argument to the log_to_do function. But log_to_do says the second argument has to be a string. A Boolean is not a string, and that's why we are seeing this error. So once again, this is a notice to you and I as the developers that we're doing something incorrectly and we have to fix this up. So in this case, I would probably analyze this and say, oh, yeah, I just made a mistake in the order of arguments here. So I would flip the order around, like so, and then the error message goes away. And now I can save this file. I can flip back over to my terminal again, run the file once more, and now I'll see the correct result. All right, so that's it. 2 quick examples of why we like to use TypeScript. We just saw 2 examples of extremely common errors, like people making typos on object properties that happens every day, probably thousands or even tens of thousands of times a day across the world with JavaScript. And we also saw an example of calling a function with the incorrect order of arguments, also an extremely common error. In both cases, we would have had to run our code to find these errors. But by using a tiny amount of TypeScript, we found these errors during development and we saved ourselves a lot of time. So we've now seen some very basic examples of why we like to use TypeScript. So let's take a quick pause right here. We're going to start working on our next application in the next video. Now that we finished up our first application, I want to give you a quick overview on how this course is structured. Now, as soon as I say that, you might be looking for the skip button and trying to skip over to the next video. But I beg you, please stick around, just watch this video. I'm going to make it as short as I possibly can. It's really important you watch this video because it's going to really frame how you approach and learn TypeScript. So let me just dive right in so I don't waste any time. All right, so when we think about learning the TypeScript language, there's really 2 distinct categories of knowledge that we need. On the one hand, we need to understand the syntax and features of the language. So for example, we need to understand what an interface is. Where do we use an interface? How do we use it? And we also need to understand the syntax for defining an interface as well. So that's kind of like one category of knowledge we have to pick up. The other category of knowledge we have to pick up is design patterns using TypeScript. So it's not enough to just know what an interface is. I want you to understand how to use an interface to actually write some amount of reusable code. This is the big focus of this course. This is what I really want to focus the entire course on. I want you to understand design patterns. At the end of the day, the official documentation is actually pretty strong for TypeScript, and you could understand some basic syntax and features pretty darn well by reading that documentation. So because of that, that's why I want to focus on design patterns. So why am I telling you this? Well, to be honest, the course you're watching right now, I've been working on for about 6 weeks. Like 6 weeks of full-time work, I've been working on this course. And I've recorded about a total of 20 hours of content for this course up to this point, like in the last 6 weeks, and I've thrown it all away. Why is that? Well, I tried to initially design this course to focus 100% on design patterns and just pick up some syntax and features along the way. And it turns out, after all these 6 weeks of time working on this, it just doesn't work to pick up TypeScript in that fashion. Honestly, the most effective way to pick up TypeScript correctly or very quickly is to first focus on the syntax and features with some kind of like dry, boring lectures, and then start to focus on the design patterns. So here's what we're going to do. We're going to focus on the basic syntax and features, and then start to move on to some projects where we're going to focus on understanding design patterns. Now, the reason I'm showing you this, and I'm telling you all this stuff, is that in the coming videos, as we start to focus on syntax and features, some of them are going to be honestly kind of boring. I'm going to make it as interesting as I can, but when we are just talking about plain syntax, we have to work with like tiny little toy examples that just don't reflect the real world a lot of the time. So I would love to skip over this stuff. I would love to just ignore syntax and features, but we have to do it. Just unequivocally, you have to understand the syntax. So we're going to blaze through the stuff as quickly as we can, and then we're going to move on to the design patterns, where we're going to be working on a bunch of projects that will really show you how to leverage TypeScript to write reusable code. All right, so having said all that, as we're going through these early sections around syntax and whatnot, if you're getting bored, totally fine. Just skip ahead and go take a look at some of the projects. If you start working on a project and you realize, oh my gosh, I've got no idea what's going on here, you can always go back and take a look at the lectures on features and syntax and whatnot. Okay, so thank you for sticking around. If you did, let's take a pause right now. When we come back in the next video, we're going to dive into our first kind of features and syntax style lecture. So I'll see you in just a minute. In this video, we're going to start to cover our first big topic, which is basic types in TypeScript. For every topic that we go through, here's the game plan we're going to try to follow. First off, we're going to get a plain definition and overview of the subject. We're then going to talk about why we care about each feature. In some cases, we're going to discuss features in TypeScript that I really don't think you're going to use that often. And so I want to kind of make that clear. I want you to understand, why do we care about these features, and like how often will you actually use them? After that, we'll then take a look at some different examples inside of our code editor by actually writing out some code. And then finally, we'll close every topic out with a discussion of when to use it. Sometimes when to use it is going to be a little bit quick, and will really be in some of the applications we put together that you're going to discover when we use some of these different features. Okay, so that's the flow we're going to go through. Like I said, our first topic is going to be basic types, so let's get to it. Let's begin with a plain definition, or as plain as I can make it. Now, I'm sure if you open up a dictionary, you're going to find a very academic definition of what a type is, but if I had to use my own words to describe what a type is, here's what I would say. I would say that in TypeScript, a type is an easy way to refer to the different properties and functions that a value has. And there's a lot of meaning in this statement right here, so let's kind of break it apart piece by piece. First off, what is a value? Well, a value in JavaScript and TypeScript is anything that we can assign to a variable. So what can we assign to variables? Well, we can assign strings, numbers, booleans, null, undefined, objects, functions, classes, arrays, and so on. So all of those different things have types. An array has a type. An object has a type. A function has a type. A class has a type, and so on. So let's now break down the first part of the statement. What do I mean by an easy way to refer to the different properties and functions? Well, to answer that, maybe it would be easier to take a look at a quick diagram. All right, so in this diagram right here, I want you to take a look at this box right here, and I want you to answer a question for me. Here's the question. What is inside that box? Like, what is in there? I think you can probably give me two answers. Maybe one would be to simply say it is a string. Alternatively, if you wanted to give me a more detailed answer, you might say it is a value that has all the properties and methods that we assume that a string has. So to really understand that part, I think we would really need to understand what different properties and methods a string has. Here's a short list of just some of the functions that belong to a string in JavaScript. So every string in JavaScript has access to the character@ function, and concat, and includes, and index of, and so on. If I had to tell you what this thing is right here by listing out all the different functions that belong to it, that would be really inconvenient. In other words, if I asked you what is inside this box and you responded to me, oh yeah, Steven, that is a value that has the function character@ and concat and includes and index of and so on, that would be super inconvenient. So instead, as a shortcut to describe what properties and function this thing has, you summarize it in a single word. You tell me this is a string. So when we refer to the type of a value, it is a shortcut to refer to the different methods and properties that that value has. Every value that we create has a type assigned to it. In some cases, that type is going to be really obvious, like in the case of this string right here. However, in some other cases, we're going to learn that types exist that are tied to values that you kind of wouldn't expect. So for example, let's take a quick glance at that application we just worked on a moment ago. Remember, inside of here, we created an interface called to-do. When we created this interface, we created a new type inside of our application, and that type's name was to-do. So there are two ways that I could have referred to this response.data thing right here. I could have either told you, oh yes, response.data is an object that has an ID property, a title property, and a completed property. But if I had to repeat that statement every single time you asked me what this variable was, it would be just really inconvenient. So instead, we formed a shortcut. Instead, I can say response.data is a to-do, and instantly you understand what response.data is. It is an object that has an ID, title, and completed property. Okay, so to sum up here, the big takeaway is that when we start to discuss types in TypeScript, these are just shortcuts. They are labels for describing the different properties and methods that a single value has. And then the secondary statement to that is that every value in TypeScript has a type, every single one of them. Okay, so let's take a quick pause right here. We're going to come back in the next video and start to expand on types just a little bit more. Now that we've got a better understanding of what a type is, let's dive a little bit deeper into the subject and then discuss why we care about types at all. All right, so first off, a couple examples of some very basic types. So anytime that we are working with a value that has a type of string, we would expect to see a value that look like these right here. So if I have a value that looks like hi there, that is a string. If I see a value that looks like a string with no characters, that is also a string. And something that says today is Monday, yep, that's a string as well. Likewise, if I've got some really small decimal number, that's a number. A negative number is a number, and a really large number is a number as well. And the reason I break out number right here is that in some other languages, there are actually subtypes of numbers. So for example, in other languages, you might have a type to represent numbers that have a decimal, or you might have another type to represent a number that is only an integer and therefore doesn't have a decimal. In JavaScript, or excuse me, in TypeScript, we have nothing like that. A number is a number regardless of whether it is positive, negative, has a decimal, doesn't have a decimal, they're all numbers. If we have a value of true or false, we would say that its type is Boolean. And then remember, we are not only restricted to these basic types right here. Every value in TypeScript has a type. So for example, if we made a new date object, the resulting object from that would have a type of date. And then if we had an object that had an ID, a completed flag, a title flag, we would say that that is an object that has type to do. And this one only applies if we were working in a code base that had defined this interface right here. Remember, this interface defined a new type. Okay, so now that we've seen some examples of different types, let's talk about how all these types kind of relate to each other. So in the world of TypeScript, we have two different categories of types. We have primitive types and object types. Primitive types are all the very basic types that you might guess. So like numbers, strings, Boolean, null, undefined, and then symbol and void are two others we'll talk about later on. The other category we have access to are something called object types. And these are essentially any types that you and I create or any other types that are built into the language itself. So for example, all the different functions that you and I create are going to have their own type. And those are an object type. Any class you and I create is going to have its own type. Same thing with arrays and objects as well. Now, why is there the divide here? Like, why are there two categories, one called primitive types and one called object types? Well, the true answer to this we won't quite see until later on, but just as a quick preview, we say that there's a separate category called object types right here, essentially because you and I can write some code that will essentially trick TypeScript into believing that one value is a different type. I know that sounds really confusing right now, but essentially we can kind of sometimes trick the TypeScript compiler in a very good way. We can do that with object types only. We cannot do that with primitive types. So that's why we have these two separate categories. Again, I know that's confusing to hear right now. I just want you to understand why you will sometimes see these broken out into the two separate categories. Okay, so now that we understand a little bit more about types, on to the last big question here. Why do we care about types at all? If I had to answer that, I would say that there are two big reasons. The first one is that types are used by the TypeScript compiler to analyze our code for errors. So think about the definition that we just gave for types. We just said that types are an easy way to refer to the different properties and functions that a value has. Okay, just keep that in mind for a second. While you keep that in mind, I'm going to flip back over to my code editor and take a look at the code that we just wrote a little bit ago. So inside of here, we defined a new type. We said that we had a new type inside of our application called to-do. And a to-do is only ever going to have the properties ID, title, and completed. Then down here on line 12, we said that the variable to-do was going to refer to an object of type to-do. So that means that the object that this variable refers to is only ever going to have these properties. The TypeScript compiler can use that information. So if we start to refer to some property on that to-do variable, that doesn't exist, TypeScript is going to throw an error at us. TypeScript knows that this variable refers to an object that has these properties and nothing else. So if we try to reference some other property, there must be something wrong with our code, and TypeScript can discover that and tell us that in the form of an error. So that's why we generally care about types. The other big reason that we care about types, back over here, one more, is that it allows other engineers to understand what values are flowing around in our code base. If you've ever worked on a large JavaScript project before, you might have ran into the scenario where you open up some file and you see some function in there with some really unclear argument name, like maybe a function with an argument name of like the letter A and nothing else. In that case, on a large project, it might be really hard for you to understand what that function is doing. If we instead try to annotate the type of arguments being passed into a function by labeling the types, then that at least gives other engineers some idea of what type of data is flowing around inside of our application. And ultimately, it will make it slightly easier for other engineers to understand what our code is doing. So that's why we care about types. Let's now take a quick pause right here. When we come back in the next video, we're going to start to take a look at some more code snippets to understand what's really going on. So quick pause, and I'll see you in just a minute. In this video, we're going to write out just a little bit of code to get a better idea of what's going on with these types. Now, this first little bit of code that we're going to write around types is going to be really simple and straightforward, just to kind of hammer home some of the concepts we've been talking about. But on some of the other examples or other topics we're going to discuss very shortly, we're going to write out much more complete code snippets. So anyways, let's get started. I'm going to begin by flipping on over to my code editor. I'm still inside of my fetch.json directory. I'm going to change out into my workspace folder. And then inside of here, I'm going to make a new project directory to hold all these different code snippets we're going to put together as we're going through some basic features of TypeScript. So I'm going to make a new directory here called features. I'll then change into that directory, and then I'll open up my code editor inside there. Once my editor is open, I'm then going to make a new file, and I'm just going to call it types.ts. So like I said, I just want to write out one or two quick snippets of code just to get a better idea of what's going on. So I want you to remember that the entire idea behind this type system is that it is an easy way for us to refer to the different properties and functions that a value has. In addition, every value, everything that we can assign to a variable has a type. So to get started, I'm going to flip back over to my code editor, and I want to just try creating a variable that's going to point to an instance of a date object. So I'll say const today is going to be new date, like so. If I hover over that variable, my editor will then tell me the type of value that this variable is pointing at. So this is saying that the today variable is pointing at an object of type date. TypeScript can now use that information to decide exactly what we can do with that variable. So for example, if I put down today and then a dot, I see my autocomplete pop up right here. This is listing out all the different functions and properties that a date object has. TypeScript only knows to show this information right here because it has an internal definition of exactly what a date is. In other words, TypeScript knows the properties and methods that a date has, so it can print them up in this list right here. And I can easily select one and call it like so. And then as we saw just a moment ago, because TypeScript knows what methods a date has and what properties it has, if we try to reference one that doesn't exist, we will very quickly get an error message. So that's the whole point of types. It is a shortcut to say, here are the different properties and methods that this value right here has. Okay, so that's an example of looking at the type that a date object brings up. Let's now try creating a plain JavaScript object. So I'll say something like const person is going to be an object like so, and I'll give this person, how about like just an age of 20. If I now hover over that person variable, I'll see a person, or const person, excuse me, and then right after that, in this case, I don't get a nice name for the type because I've not actually given this object right here a name, a shortened name. So we can kind of see our definition that of a type kind of holds up here. If we don't have a shortened definition of what this object is, then TypeScript is just going to default to printing out all the different properties and methods that the object has. So in this case, it has just an age that is a number. And once again, if we try to reference some property on that variable that doesn't actually exist, we're going to get an error message. Okay, just one more quick example here. So down here, I'm going to try to create a class. I'll call it color. I'm not going to give it any implementation. Now, even if you don't know what a class is, that's totally fine. We're going to go into great detail on classes later on. I can now use this class to make a new instance of a color. So I'll say const red is new color like so. And now, just as we've seen twice before now, if I hover over red, TypeScript knows that this variable is pointing at an object that is of type color. That means that this variable right here has access to all the properties and all the methods that a color object has. In this case, none, because we haven't actually implemented anything here. And we can see that if we write out a red and then dot like so. There are no properties associated with this class of color, so we don't get any autocomplete whatsoever. And if I try to reference anything, as usual, I'll get a very quick error message here as well. Okay, so that's just a couple quick examples of types. So let's take a quick pause right here. We're going to wrap up this idea of types with a quick discussion, really quick, I promise, on where we're going to use types in a normal project. So quick pause, and I'll see you in just a minute. We've now gotten a definition of types. We've spoken about why we care about them, and we just looked at a couple quick examples. So now the last thing we're going to cover is when to use them. All right, so this one's kind of an easy one in this case. And some of the other topics we're going to look at, well, there's going to be a lot better answer of where we use them. But in the case of types, well, we use them everywhere. And that's just a side effect of using TypeScript. So whether you want to or not, every value you define inside your application is going to have a type associated with it. And TypeScript is going to do its best to check the quality of your code or check for any errors by using those types. So like I said, for this particular feature, well, types are used everywhere, and there's really not that much else to say about it. All right, so let's take a quick pause right here. This is kind of a gimme. Let's take a pause right here, and we're going to move on to our next feature in the next video. In this video, we're going to move on to our next big subject, which is type annotations and type inference. These are technically two different systems inside of TypeScript, but we're going to talk about them in parallel for a very good reason. Just to make things a little bit more complicated as well, these two different features apply slightly differently to variable declarations, functions, and objects. So we're going to first talk about type annotations and inference as applied to variables. Then we'll take a break and talk about them applied to functions and then objects and so on. For each of these different subjects, we're going to once again go through some plain definition and overview. We'll then take a look at some different code examples that we're going to write out together. You'll notice I swapped these two steps right here this time around. So we'll then talk about why we care about this annotation and inference stuff, and then we'll discuss when to use it. So let's get to it. First off, some plain definitions. So type annotations, what is that? A type annotation is some tiny bit of code that you and I are going to write to tell TypeScript what type of value a variable refers to. All right, now before expanding on that definition, let's talk about what type inference is. So with type inference, TypeScript is going to attempt to automatically figure out what type of value a variable refers to. Now you'll notice that the kind of definition of both these are very similar. In both cases, it's what type of value a variable will refer to. So the interesting thing about type annotations and type inference is that they're kind of at odds with each other. In one case, you and I are adding in a little bit of code to tell TypeScript what different types we are working with. With type inference, we are relying upon TypeScript to do that work for us. So these two features are a question of, are you and I going to do everything manually, or are we going to leave it up to TypeScript? That's what the big question here is. And that's what is going to be the big focus of our discussion about why we care about these features and when to use them. Now let's take a quick pause right here. We're going to come back in the next video and start taking a look at a couple of different code samples. So quick pause, and I'll see you in just a minute. In this video, we're going to write out a couple of code examples to understand how type annotations work specifically with variables. Remember, a type annotation is going to be a little bit of code that we write to help TypeScript along. The type annotation system is kind of at odds with type inference. So we're going to first focus on type annotations and then come along and understand how type inference comes into play. All right, so I'm going to change on over to my editor. And inside my project directory, I'm going to make a new folder called annotations. We're going to eventually create separate files inside this directory that are all related to type annotations, so we're going to organize them all inside of here. Inside this folder, I'm going to make a new file called variables.ts. And then inside this file, I'm going to write out my first variable declaration that has a type annotation. So I'm going to write out const apples is going to be a number, I'm going to set that to 5 like so. So the colon and the word number right after it is our type annotation. You're going to see syntax that looks exactly like this in the vast majority of TypeScript code that you work with. This type annotation is trying to tell TypeScript that we are only ever going to assign a value of type number to the variable of apples. If I ever try to assign some other type of value besides a number, I'll very quickly see an error message. So for example, if I update the 5 right here to true, which is a Boolean, I'll see an error right away. And it tells me that the type of true is not assignable to a type of number. Now this is also going to work if I try to update the value assigned to that variable as well. So if I update the const keyword to let, which will allow me to reassign apples, I can then reassign apples down here a value of 10 without any issue. However, if I try to assign it some other type of value, like a string, once again, I'll very quickly see an error. And once again, I see a message that says, essentially, you have a string and you're trying to assign it to a variable that's supposed to be a number. Now, for the rest of this file, I want to show you some reassignments all over the place, so I'm going to continue using the let keyword. Even though in just about all the declarations we're going to add here, usually I would be making use of the const keyword instead. Type annotations like this right here can be used with any type of value. Remember, we just spoke about some of the different types of values inside of TypeScript. So we've got number, strings, booleans, null, void, null, undefined, and functions, arrays, and so on. So with every one of these different types of values, we can use a type annotation. Let's write out a couple of examples just to understand how type annotation works with each of these different types. All right, so in every case, we'll write out let, and then a variable name. In this case, I'm going to call my variable speed, then a colon, then the type of value. In this case, I'm going to say it's going to be a string, and I'm going to assign it a value of fast, like so. Once again, if I try to assign this a value that is not a string, so in this case maybe a number, I'll see an error. And that's pretty much it. We're going to see that same pattern repeating every time we try to assign it a different type of value. Let's take a look at a Boolean as well. So let's say maybe let has name is going to be a Boolean of true. How about null? I'll make a variable called nothing much. And I'll make that null, and that's going to be assigned a value of null. Now this is kind of interesting right here. It's our first example of where we have a value that has a name identical to its type. We're actually going to see that a couple times in TypeScript, and it's something that's a little bit difficult to grasp once you start getting into some more complicated topics. So we're going to have several lectures later on to understand when we're working with something that's a value and when we're working with something that is a type. We could also try a new variable called something like, say, nothing, and make it undefined, like so. Now we can also use type annotation with every other type of value as well, like we just said. So I can use this with an instance of a class, or with a built-in object, or just about anything you can imagine. So let's say that we're working with maybe a date object. I'll put a little section header here, and I'll say built-in objects. So I can make a new variable called now. I'll say that's going to be of type date, and then I'll make a new date and assign it on the other side. So in this case, we're once again doing the same thing we're doing up here. We're saying that we're going to have a variable called now, and we can only assign it a value of type date. And then on the other side, we're going to assign it an instance of a date object. All right, so now that we're kind of getting the idea here, let's take a quick pause. When we come back in the next section, we'll take a look at some of the more complicated syntax that comes up when we start working with objects, arrays, and functions. So quick pause, and I'll see you in just a minute. In the last video, we started to explore type annotations around simple types like number, string, Boolean, and some built-in objects as well. We're now going to write out a couple of examples that use some more complicated syntax. So we'll first start off with trying to add in a type annotation for an array. In this example, I'm going to try to make a new variable called colors, and I want to try to assign it an array of strings. And maybe these strings will be like red, green, and blue because, hey, we're calling this thing colors. So to indicate that, I'll add on an annotation of string and then square brackets like so. So this tells TypeScript that we're going to assign an array indicated by the square brackets that's going to contain nothing but strings inside of it. So I can then place my equal sign and then place the real array and say red, green, and blue. So the important thing here to understand is that the annotation, and specifically this bracket right here, is not creating an array. This is saying we're going to have something assigned to colors that is of type array that contains strings. One of the more complicated things in the world of TypeScript, I think, is kind of separating all this new type annotation syntax and understanding when we are actually creating an array, like as we are here on the right-hand side, and when we are trying to indicate a type of array, as we're doing here on the left-hand side. Now we're going to go into great examples, or much more detail with arrays in just a couple of videos. So for right now, let's just kind of sit on this example right here and say, if we ever want to create a type annotation for an array of strings, that's how we would do it. We can do the same thing with, say, maybe an array of numbers as well. So let's say, how about let my numbers, for lack of a better name, and I'll put down the type of value that I'm going to have inside of the array, which in this case will be a number, then empty square brackets, an equal sign, and then my real array like so. And the same thing with Booleans as well. So I could say, let, I don't know, truths. How about that? That'll work. That's going to be a Boolean or an array of Booleans. And I'll set it equal to true, true, false, like so. Like I said, we're going to go into greater detail with arrays in just a moment, so we'll just hang it right there. So for our next example, let's take a look at how we would deal with classes with type annotations. So I'll put down another section here called classes, and I'll create a class called car. I'm just going to make it an empty class like so. Classes are another thing that we're going to go into great detail in this course. Again, for right now, I just want you to understand how we can add in a type annotation with an instance of class car. So I could create a new variable down here and call it, say, lowercase car. I'll then put the colon and then the type of the variable, or the type of value that we're going to assign to car. In this case, I want to make an instance of class car. So I'm going to say that my type is capital C car. And this is where things start to get really crazy. If you've never worked a lot with classes before, traditionally we create classes with capitalized names. So whenever you see a capital name like this, like capital car, that means we are referring to the type of class car. And then usually, whenever we have a fully lowercase name, as you see right here, we have a variable that's referring to an instance of a car. So we're saying the variable car is only ever going to refer to an instance of a car. We can then place our equal sign and then make a new car, and that's what creates our instance. All right, so now two more quick examples here. We'll take a look at how we add in a type annotation for an object literal. Now this is where the syntax starts to go a little bit more challenging, but functions are even a little bit worse, so hey, let's just hang in there for right now. I want to try creating an object and adding in a type annotation for it. I'm going to first create the object, and then we'll discuss how we can add in the annotation. So I'll make a new variable called point, and I'm going to assign that to an object with an x value of 10 and a y value of, how about 20, like so. So how would we add in a type annotation for this? Well, just like before, we'll add in a colon, and then we'll add in some syntax right here to describe what type of value we're going to assign to point. Now, the only difference this time around is that the syntax is going to look a little bit nasty. So to indicate that we're going to assign an object that has an x property, that's a number, and a y property to number to the variable point, we're going to put the colon and then a set of curly braces, and then we'll list out all the different property names with their respective types right inside of that set of curly braces. So I'm going to say that the object that we're going to assign to point is going to have an x property, that's a number. I'll then put in a semicolon, and then I'll say that it's going to also have a y property, that's a number as well. I only have to put in a semicolon when I'm separating different types inside of here, or different property names. So I do not technically have to put in a colon after the y property, although I can if I want to. So like I said, this is where things start to get a little bit crazy. Once again, we are declaring a variable called point. We are assigning it an object that has an x property and a y property. And then we are simultaneously adding in a type annotation for point as well. And we're saying we can only ever assign an object to point that has an x property that's a number and a y property that's a number as well. So just as we saw a moment ago, back up here at the top, we saw very simply if we assign a bad value on the right-hand side that doesn't agree with the type on the left-hand side, we very quickly see an error message. So that same rules applies with an object as well. For example, if I make the X property right here a string instead, I'll see an error message. And it says that I have the property called X, but I'm trying to provide a value that is a string instead of the number that I said I was going to provide. So I'll change that back over to 10, and now the error goes away. Likewise, if I do not provide all the required property values, like for example, instead of Y, I instead do something like A, I'll see an error message as well. And the error says, hey, you're trying to give something that has property A, but we were expecting to see something that has Y instead. So the same rule applies. The syntax is just a little bit nastier. All right, so let's do one more quick pause. And in the next video, we'll take a look at the syntax around functions, and we'll talk about why we care about all these type annotations. So quick pause, and I'll see you in just a minute. We've now gotten an example of type annotations with arrays, classes, and object literals. Once again, I just want to remind you that we're going to have a separate section on arrays, classes, and object literals as well. So all I'm trying to do right now is kind of give you a sample of some of the syntax that we're going to need to understand to get through some of the more complicated stuff. The last example I want to give you down here of a type annotation is for a function. Oh, function, there we go. So unfortunately, the annotation for a function is kind of the nastiest syntax, but you're going to see so many examples of it that you're going to understand it really quickly inside this course. So I'm going to first declare a function, and it's going to look like a normal function, and then we'll come back to it and add in the type annotation. So I'm going to make a new function called log number. This is going to be an arrow function, and I'm going to call it with a number that I'll call I, and then inside the function, I'm going to add in a console log for I. Now you'll notice that I've got a little underline right here. Just to get the underline to go away, I'm going to add on I colon number like so. We don't need to worry about this syntax just yet. That is not the annotation we are worried about here. So let's just kind of ignore that for a second. Once again, we're going to have a separate section for functions just as we are for these other types of values as well. Right now, all I want to figure out is how we can add on a type annotation for log number right here. Remember, we want to use a type annotation to describe what type of value we are assigning to a variable. So I want to add in some code that's going to tell TypeScript some information about this function. Now, in all the other examples we've done so far, the syntax has been sometimes a little bit weird, but more or less understandable. So for example, up here with the arrays, we put down string and then the square brackets to indicate this was going to be an array. In the case of a string, well, that was really easy. We just wrote out the word string. And then we saw with an object literal, we described the different properties and types, or excuse me, the different properties and types of values that the object would have. So in the case of a function, we're going to do something similar. But we first need to think about what properties we really care about with a function. Well, with a function, what you and I really care about as developers is what arguments are going to go into the function and what different types of values we expect the function to return. So that's the information we're going to encode inside this annotation. Inside the annotation that goes right here, we're going to try to tell TypeScript what different arguments the function is going to take and what different values it is going to return. So here's what we're going to write out. We're going to write out inside of here. Right here, I'm going to put down a set of parentheses, and inside there, I'm going to provide an annotation for the different arguments that go into the function. So I'm going to say that this thing is supposed to receive an argument with the name of I. That's going to be a number. Then right after that set of parentheses, I'll put in an arrow. And then right after that, I'm going to list out the different values that I expect this function to return. Now in this case, I expect this function to return nothing. So I'm going to use a very special type called void. All right, so there's the full annotation. Now, I think you can agree with me that this is some really nasty syntax right here. It's really hard to understand where the annotation begins and where the function begins. So everything up to void, like right there, that's the annotation. That is us trying to tell TypeScript what type of value we are going to assign to this variable right here. Everything on the right-hand side of the equals is the actual function. So this is the annotation. That's like a comment of us trying to tell TypeScript what we are doing here. It is not actual code that's going to be invoked. So even though it really, really looks like a function in its own complete right, it is not a function that we're going to run. It is a description of a function. And then on the right-hand side of the equal sign is where we actually provide the implementation. Okay, I know once again the syntax here is a little bit weird, but don't worry, we're going to have that separate section on functions to really break down the syntax right here and really understand what's going on. All right, so we've now gotten an example of a type annotation with a bunch of different basic values. So now that we've seen all these, I want to point out one thing that's really interesting here. Let's take a look at this first declaration we did at the very top. Right now, if you hover over apples, you'll see a little pop-up that says, oh yeah, apples is always going to refer to a number. So here's the interesting thing. I'm going to remove the type annotation. I'm going to delete that and the colon as well. And now if I hover over apples, I'll see the exact same thing I saw before. So somehow it looks like I didn't really have to add in that annotation in the first place. And that is the entire dynamic that we need to understand between these type annotations and these type inferences. We just learned how to add on a ton of code that are all type annotations. Everything we just wrote, all that new syntax were type annotations. But in that file that we just put together, there was not a single type annotation that was actually required. In other words, inside this file, we did not have to add in a single one of these type annotations. We can delete every single one of them, and everything is still going to work just fine. I can delete all of them, and I still see no errors inside my code. And in every case, if I hover over a given variable, you'll see that I still get a little pop-up telling me what type of value each variable is. So it's very clear that there's kind of more going on here than meets the eye. So let's take a quick pause. When we come back in the next video, we're going to start to understand this kind of tension between type annotations and type inference. So quick pause, and I'll see you in just a minute. In the last video, we saw that we could remove all these different type annotations and we did not see any errors. In fact, if we then hovered over these variables, it's clear that TypeScript still understands what type of value we're going to assign to each given variable. So what you're seeing here is the type inference system in action. In this video, we're going to discuss how type inference works and then discuss when we're going to rely on type inference versus adding in an annotation manually. So let's get to it. All right, so first off, the basics of type inference. Anytime you and I make a new variable inside of our application, we're actually undergoing two separate steps. So on the left-hand side of this equals sign, where we say const color, we're doing something called variable declaration. This is where we are telling our program that we're going to have a new variable inside of our application with the given name. And then in the second step of this entire process, on the right-hand side of the equals sign, we are attempting to assign a value to that variable. Assigning a value to a variable for the very first time is referred to as variable initialization. So this entire line of code right here, two separate steps, first variable declaration, and then initialization. Here's the rule around type inference. If we do our declaration and initialization on the same line, or essentially in one single expression, then TypeScript is going to figure out the type of value that we're going to assign to color for us. So in this case, TypeScript would look at the variable or the value that we're usually using for initialization. It would see that this is a string, and it would say, okay, color must be a variable that's going to refer to a value of type string. And that's how we get this kind of pre-done type right here, where we can delete the annotation and TypeScript still sees what's going on for us. If I move this assignment or this initialization onto a separate line, then it's not going to work anymore. So if I say apples equals 5 on the next line down, if I hover over apples, you'll notice that it has a different annotation on here. It says any in this case. We're going to discuss what any means in just a moment, but for right now, I think you can agree with me that TypeScript can no longer figure out what type of value we're going to assign to apples. So again, the rule of thumb here is if we're doing the initialization and declaration on the same line, TypeScript will use type inference for us. Okay, so that's the kind of easy part of type inference. If we do everything on one line, everything's going to work just fine. So now here's the really obvious question. When are we going to add in these type annotations? When are we going to type them out? If we're saying that TypeScript can figure out these different types for us, why would we go through the process of writing out the annotations manually? And that's a great question. Let's take a look at a diagram to understand why we might want to use type inference over annotation, or the opposite. Okay, so in that file that we just put together, we've got a lot of examples of type annotations. So remember, that's where you and I, the developers, are going to tell TypeScript the type that a value or a variable is going to refer to. Now with type inference, that's where TypeScript is going to guess everything for us. So in general, we're going to rely on type inference always. All the time, wherever we can, we will rely on type inference. That means that whenever you and I have a variable that we are declaring and then initializing on the same line, you and I in this course are not going to add in type annotations. So we're going to have a lot of code that looks like this right here. And we will much more rarely have code that looks like this down here, or anything else that you see inside this file. So we are going to rely upon type inference as much as we possibly can. But there are 3 scenarios where we will rely on type annotations. So let's take a quick break right here, and we're going to go through these 3 different examples of where we are going to add in these type annotations to help TypeScript out. So quick pause, and I'll see you in just a minute. Whenever you and I write TypeScript code, we're going to rely upon type inference quite heavily. This is where TypeScript is going to figure out the different types that are flowing around our application for us. However, there are 3 different scenarios that we're going to look at where we're going to have to add in type annotations manually instead. Remember, these type annotations are going to help TypeScript along. The first example we're going to look at is whenever we have a function that returns the any type and we need to clarify it. Now, we haven't really discussed the any type just yet, so we're going to write out first just a little bit of code, then we'll review what the any type really means, and then we'll get a better idea of why we need to use a type annotation in this case. So let's get to it. I'm going to flip back over to my code editor, and I'm going to go down to the very bottom of the file. Down here, we're going to add in our 3 different examples on type annotations. So I'm going to put in a little comment that says when to use annotations. So case number 1 is when we have a function that returns the any type. Okay, so for this example, I want to define a little snippet of JSON as a string, and then we're just going to try to parse that JSON. So I'm going to define a new variable called lowercase json, and I'm going to assign it a JSON string. So I'll put down a string, and then inside of here, we're going to write out just a little bit of JSON. So I'll say curly brace, I'll put down x in double quotes, a colon, and then 10, then y in double quotes, a colon, and 20, and then I'll close off the curly brace like so. So now I could use that string with the json.parse function and turn the string into an actual object. So I'm going to create a new variable called, how about coordinates, and I'll assign it the result of json.parse with that JSON variable. So in theory, if we now ran this code and console logged out coordinates, we would see something like x is 10 and y is 20, like so. Now there's just one little gotcha inside of here. If you mouse over coordinates, you'll notice that it has a type annotation of any. So this means that TypeScript thinks that coordinates is of type any. In addition, if we mouse over parse right here, you'll notice a lot of nasty syntax up here, but at the very end of it is something that says :any. That means that the json.parse function returns the any type. So clearly this any thing is something pretty important. Let's have a quick pause, a little aside here, and discuss what the any type means. And then we'll understand, based on that discussion, why we would need to add in a type annotation here, even though it looks like there's no errors or warnings with our code. All right, so quick aside here. So the first thing I want to review is how the json.parse function works. In this diagram, I've got some different values on the left-hand side. And then we're going to imagine that we feed each of these different values into JSON parse, and then we'll take a guess at what the different types are that will come out of the function. Now, in reality, this diagram is just a little bit misleading right here. In reality, anytime we call json.parse, we get back a value of the any type. So this column over here on the right-hand side, I'm just saying this is what the, maybe the type would be, right? This is like, we know that the type of false, once we parse it, would be a Boolean. That's not what we get with TypeScript. This is just like the ideal world. So if we fed in a string of false to json.parse, we get back a Boolean. Again, that's not what really happens. We get back any, but hey, we're just saying we get back a Boolean. If we pass in a string of 4, we would get back a number. If we pass in something that looks like an object with value and then 5, we would get back a type that is an object with value that is a number. And likewise, if we have an object with name that is pointing at a string, we would get back an object with a name property that is a string. And you can see each of these examples very easily if you open up a JavaScript console really quickly and you call, say, json.parse with a string of 5. We get back a number, right? Makes sense. Now, the kind of common theme here is that we can clearly pass in very different strings into this function, and we can possibly get back very, very different value types. In some cases, we might get a Boolean. In other cases, we might get a number. And then in some other cases, we might get these really complicated objects. So the goal of this diagram right here is just to help you understand that anytime we call json.parse, we get back possibly some very, very different value types. Now the problem here is that TypeScript cannot predict these different types. TypeScript doesn't know what we're going to get out of json.parse because it depends entirely on the string that we put into that function. So when you and I are writing code inside of our code editor and we call json.parse, TypeScript just plain can't predict what we get back from the function because it will be entirely different based upon the string that we put in. And TypeScript is not going to try to read this string and figure out what it would return if we called json.parse. So as a shortcut, TypeScript instead decides to simply say, you know what, I can't guess all these different types, that's too complicated. So I'm going to say if you ever call json.parse, you're going to get back something called the any type. The any type essentially means that TypeScript has no idea what type of value is being returned from json.parse. It has no clue at all. And that's what we see inside of our code editor. So right here, when we mouse over coordinates, TypeScript is saying this is the any type. That means that TypeScript has no idea what type coordinates is. So that's what the any type indicates. Now a couple more notes here on the any type. So any is a type, just as string or Boolean are. Anytime we have to write out a type of a variable, like for example in a type annotation, we could, in theory, put in any just as easily. Anytime we see something that is marked with the any type, that means that TypeScript has no idea what's going on. And in general, that is a very bad thing to have inside of our application. Remember, the entire idea behind TypeScript and all these types and all this kind of stuff is that we're using TypeScript to catch errors inside of our code editor. And we're able to do that because of these types like string and number and Boolean and whatnot. If TypeScript knows the different types inside of our application, it can take a look at any time we say call a function on an object or reference a property on an object. And TypeScript can figure out whether or not we are referencing a property that actually exists or if it's one that we just made a typo on. So anytime we have a value that is the any type, TypeScript cannot do any error checking whatsoever around that value. So for example, right now, if I go back over to my code editor, I can write out coordinates dot blah, 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 like so. This is clearly a property that does not exist. But you'll see that TypeScript does nothing to help me out and tell me that I might have a mistake right here. However, if I go back up to any of these other examples where I'm working with variables that have known type, like let's say, how about speed right here? If I reference speed.blah, blah, blah, TypeScript is going to jump in very quickly and say, hey, that's not a property that exists. It's only going to allow me to call properties that actually exist, like let's say to uppercase, like so. That's fine. And it's only fine because TypeScript knows that speed is a string. So again, anytime we have a variable of type any, it is generally a bad thing because TypeScript can't do its job. All right, so I think that we've gone into enough detail on this any type. So let's have another quick pause right here. We're going to come back in the next video and understand how we can use a type annotation to fix this thing up right here. So quick pause and I'll see you in just a minute. In the last video, we spoke about why the any type is a very bad thing to have inside of our application. Right now, coordinates is of type any, and it's only the case because json.parse returns a value of type any. And that's because TypeScript just can't predict what json.parse is going to return. So to fix this up, one way we could fix it is to add in a type annotation for coordinates. So we need to add in a type annotation for an object. We already saw an example of that right back up here when we defined the object literal of point. So to add in a type annotation for an object, right after the variable name, we'll put in that colon, and then the overall structure of that object. So for us, we're going to add in coordinates right here. I'll put in a colon, then a set of curly braces, and inside there I'm going to say this thing is going to have a property called x, that is a number, and it's going to have a property y, that is a number as well. So now we've given enough information to TypeScript that it can figure out what type of value coordinates is. If I now mouse over it, I see the type annotation on here. And now if I try to reference, say, coordinates.blah, blah, blah, I'll very quickly see an error message that tells me that is not a property on that object. Okay, so that's pretty much it. This is one of the three cases where we are going to add in type annotations anytime we call a function that returns type any. Now, JSON.parse is just one of the functions in JavaScript that returns type any. There are several others as well. So we'll kind of see some of those different functions over time. And in fact, we might eventually have to write our own functions that return type any as well. All right, so let's take a quick pause right here. When we come back in the next video, we'll move on to the next example or the next case where we are going to add in a type annotation willingly. So quick pause and I'll see you in just a minute. In this video, we're going to take a look at another example of when we're going to add in a type annotation manually. So this is going to be whenever we declare a variable on one line and then initialize it later. As a quick reminder, type inference only works when we do variable declaration and initialization on the same line. And so obviously, if we split this into two separate steps or two different lines of code, then type inference doesn't work anymore. All right, so I'm going to flip back over to my editor. I'm again at the very bottom of my variables file. I'm going to set up a second example here. I'm going to say when we declare a variable on one line and initialize it later. Okay, so for this example, I'm going to make an array of strings called words, like so. And I'm going to give this the words red, green, and blue. Then right after that, I'm going to declare a variable called foundWord, like so. So here's what I want to do. I want to write a for loop that's going to iterate through this array right here. And if I ever find a word or a string equal to green, then I want to set foundWord to true. So if you find green inside of words, just set foundWord to true. That's pretty much it. I know this is a silly example, but I just want to give you a very practical example of when we're going to run into this type annotation stuff. So I'm going to write out my for loop. I'm going to say let I equal 0, I less than words.length, I++. And then for every word, we'll say if words at I is equal to green, then we'll set foundWord equal to true, like so. So now in this case, I have an instance where I'm declaring the variable up here, and then I only assign it a value or initialize it down here inside of my for loop. If I now mouse over foundWord, it will very clearly tell me that this is of type any. And in fact, I even have a little underline here that is a warning that tells me that foundWord has an implicit any type. And then the tip here says that I might get a better type if I actually use the variable. Now, when it says inferred from usage, that actually means that like I have to add in the annotation right here or optionally initialize it on the same line. So in this case, to make this warning go away, we have to add in a type annotation. So I can tell TypeScript, all right, this is going to be a Boolean. And now we get around that issue. So whenever type inference doesn't work because we are doing declaration and initialization on separate lines, we're going to add in the type annotation. That's pretty much it. Now, as a quick aside here, obviously the best way to write out this code would have been to do something like this, to initialize foundWord as false, and now TypeScript understands what's going on here. This is way better code than what we had before, but again, I just wanted to give you a quick example of where we might have a declaration on one line and then initialization at some future point. All right, so let's take a quick pause right here. When we come back in the next video, we're going to take a look at our final example of when we are going to prefer to use a type annotation. So quick pause, and I'll see you in just a minute. In this video, we're going to look at the final case in which we will make use of type annotations. So this will be whenever we have a variable where its type cannot be reasonably inferred, even if the declaration and initialization are on the same line. This is really going to be a very big corner case right here. Nonetheless, I just want you to understand when we want to use type annotations. So let's try to get through this example really quickly. I'm going to flip back over to my editor, and at the very bottom, once again, I'm going to add in a new section down here, and I'll say this is the third case. This is when we have a variable whose type cannot be inferred correctly. For this example, we're going to create an array of numbers called numbers. I'm going to give it values like -10, -1, and 12. I'll then declare a variable called number above 0. So here's the idea. I want to iterate through the numbers array. If we find a number that is greater than 0, I want to assign it to number above 0. Otherwise, I want to assign false to number above 0. So that means that we're going to have two different types of values being assigned to this variable. Now, this is some kind of bad code we're writing right here. I really don't recommend taking this approach in general. However, there are scenarios where you might need to do something like this. Doing it with a number and a Boolean doesn't make a lot of sense, but there might be other cases, like maybe you're trying to find a user's favorite piece of media, and maybe possible choices for media are like a blog post or an image or a book or a movie or something like that. So if we had something like, users' favorite media, it would possibly make sense to assign some different type of values to this variable. So this is kind of where this scenario is going to come up. All right, so we're going to say that by default, number above 0 is going to be false. And then if we ever find something above 0 inside this array, we need to assign that number to number above 0. So let's write this code out. So I'll say for let I equals 0, I less than numbers.length, I plus plus, and then if numbers at I is greater than 0, we'll say number above 0 is going to be that number. So that's going to be numbers at I. Now, as soon as we put that in, we're going to see an error message, and I definitely would expect to see this. So type inference already kicked in right here on this line of code. We assigned false to number above 0, so TypeScript very correctly thinks that this is supposed to be of type Boolean. Then on this line of code right here, we're trying to assign something that is definitely a number to that variable. So the error is that we're trying to assign a number to a variable that is supposed to reference a Boolean. So this is one of the downsides of type inference. Type inference kicked in here, it did its job, but it didn't really understand the intent of our code or what we're trying to do. So because type inference is marking this variable as always being a Boolean, our code won't work as is. So to fix this, we could add in a type annotation. So we could add in something that says colon, and then Boolean or number, like so. And this character right here is the pipe. It is not an L, it's not an I. It is a character right above the return key on your keyboard. You can picture this as being like an OR statement. So this is saying that number above 0 is going to be either a Boolean value or it might be a number, one of the two. So anytime that we need to express kind of like an OR statement with our types, we will have to use a type annotation. Type inference won't work correctly. So by using this type annotation, TypeScript now understands that we can assign a value of type Boolean or a value of type number to this variable. And if we mouse over that variable, it'll be reflected right there as well. All right, so like I said, this is kind of a bad code example, but we could kind of easily imagine some other scenarios where we might have to express a single variable that has possibly different types. And we definitely are going to add some code that looks like this in a future project in this course. So we'll see this kind of scenario of where we have to add in a type annotation, but with a kind of more practical approach. All right, so that's pretty much it. So we now have taken a look at the 3 different cases where we definitely will have to use a type annotation. So let's now take a quick pause. We're going to move on in the next video and talk about type annotations and inference around functions and objects as well. Where's that diagram? Right here. Functions and objects. And we're going to get through these other approaches really quickly because we just had to do some like really original work in this variable section. So quick pause and I'll see you in just a minute. In this video, we're going to continue talking about annotations and inference, but rather than focusing on how those features are applied to variables, we're going to instead focus on how these features are applied to functions. So still talking about working with types, but we're now talking about labeling functions as opposed to variables. Now you might be thinking that we already spoke about functions a couple of videos ago, but let's pull open that code snippet that we wrote. Back inside my variables.ts file, we can scroll down a little bit and see where we added in some type annotation around a function. So here's the thing. The annotation that we wrote out right here was an annotation for the variable. We were telling TypeScript, hey, we're going to assign a value to this variable that's going to have this type right here. It's going to be a function, it's going to take some argument and have some return value. Again, it was modifying the variable. So now we're going to be moving on to the right-hand side of that equal sign. We're now going to focus on how we add annotations to the function itself, how we annotate its input arguments and its return values as well. So with that in mind, let's flip back over a quick diagram here. I want to give you a plain definition on what's going on with annotations and inference around functions. All right, here we go. So when we talk about type annotations around functions, we are talking about code that we are adding into our project that's going to help TypeScript along. The goal of these annotations is to tell TypeScript about the type of arguments that a function will receive and the type of value that it will return. So again, we are adding in code here to help TypeScript along, very similar to the type annotations we were already adding in. The big difference here is that we are no longer annotating a variable declaration. Instead, we are annotating the function itself. Now, also with type inference, we still have type inference working around functions as well. Remember, type inference is that kind of automatic system where TypeScript is going to try to figure out what is going on for us. This same system applies to functions as well, but there's one big difference. Type inference only works around the return value from a function. So TypeScript will try to figure out what value or what type of value you are returning from a function, but it will not try to figure out what type of value the arguments are. Now, both these definitions right here, everything I just said, I feel like is kind of confusing. And I think learning all this function stuff is a lot easier to look at some code snippets. So let's flip over to our code editor. We're going to write out a single function and annotate it as best we can. All right, so back inside my code editor, I'll find that annotations directory we had created. I'm going to make a new file in there and call it functions.ts. So inside of here, I want to write out one single function called add. This is going to be a function that's going to take two numbers as arguments, add them together, and return the result. So I'm going to receive those two arguments as names A and B like so. Now, as soon as I add in those arguments, you'll notice I get a little warning. If I hover over them, or just the first one, it says here that A has a any type. So right now, TypeScript has no idea what type of value A is. So to help TypeScript understand what's going on here, we have to add on a type annotation. To do so, right after the argument name, we'll put in a colon, and then the type of value that A will be. So in this case, it's going to be a number. Same thing for B as well. Right after B, I'll put in a colon, and then the type of value that B will be. So we've now defined a function that's going to take two arguments, A and B, and they're both going to be numbers. Now the last thing we'll do is add in an annotation for the type of value that the function is going to return. Remember, we had said that the add function was going to add two numbers and return the result, so it makes sense that this thing will return a number as well. To add in that annotation, right after the argument list, I'll put in a colon, and then the type of value that the function will return. In this case, a number. As soon as I add that in, you'll see that I get an error right here again. This time it's saying that I have a function whose type is neither void or any, and it must return a value. So all this is saying right here is that we just added in an annotation that said our function was going to return a value that is a number. But we don't have any return statement right now. We don't have any code to actually return a number. And so TypeScript is telling us, hey, your function isn't working as expected. So to fix that error, all we have to do is return a number. So inside the function, I will return A plus B like so, and then that error goes away. All right, so this is a very basic example right here, but it highlights some really important ideas around type annotations for functions. So let's take a quick pause. We're going to come back to the next video and dissect this thing just a little bit more. So I'll see you in just a minute. In this video, we're going to dissect the add function just a little bit and get a better idea about how type annotation works with functions. So once again, every time we add in an argument list, we're always going to annotate every single argument. Likewise, right after that argument list, we're going to add an annotation for what the function will return. Now, when we add in the return annotation right there, TypeScript is going to immediately analyze the body of your function. So it's literally going to read the code inside there and decide whether or not you actually are returning a value that is a number. In this case, TypeScript knows that A and B are numbers. It sees that we add them together. It knows that adding two numbers together results in a number, and then it sees that we return that value. So TypeScript can read this line of code right here and understand that we have done exactly what we said we were going to do. If we return some other type of value from the function, like a string like so, we'll very quickly get an error because now TypeScript has read the body of our function again and seen that we are returning a string as opposed to the number we said we were going to do. So if I hover over that, it says specifically, hey, you're trying to return a string, you're supposed to return a number. And so I can revert it back over to A plus B. Now, one really important thing to understand here, and this is kind of getting into one of the more interesting sides of types, although we've declared what type of value we are going to return, TypeScript is not going to try to make sure we actually have the correct code inside the function. Now, I know that sounds kind of weird, but let me tell you what I mean by that. You and I wrote a function here called add. And so I think any engineer who looks at this function would say, okay, if I call this, it's going to add two numbers together. And then we added in some annotation to say, oh yeah, the function's going to return a number. TypeScript can make sure that we are returning the correct type of value, but it does not actually try to make sure that we have the correct logic inside of our application or inside this function. So in other words, we could very easily return the difference between A and B. So no longer are we adding, we're now subtracting. But TypeScript doesn't care about that. It just says, hey, you're returning a number, works for me. Now this might seem like a really obvious thing, but it's going to have some really big impacts on some later topics we discuss. Remember, the type system is just concerned with types. It doesn't actually vet your actual logic inside the function and make sure you're doing the right thing, so to speak. All right, I am going to restore that to a plus b. Now, the last thing I want to mention here is just a little bit more around annotations and type inference. So quick diagram of this function. All right, here we go. So here's our add function. We have two arguments into it. They are both numbers, and we have a single output that is a number as well. So when we think about the arguments, we have to always use type annotation. In other words, we have to write out colon number right there every single time we define a function. There are some corner cases where we do not, but for right now, we'll just kind of ignore those. We'll discuss them later on. So whenever you and I write a function in this course, we are always going to add in these annotations every time we write out a function. So we do not get any type inference on arguments. We're always going to add in those annotations. However, on the other side over here, for the output from the function, we do get the benefit of type inference, but we're not going to use it. And so let me clarify what's going on there. Back over inside my function, I'm going to find the return value annotation right here and delete it. If I now hover over add, I'll see an annotation on the variable itself that says that add is referring to a function that takes two numbers and returns a number. So that's type inference in play. We did not add in a type return annotation, but TypeScript read the body of our function and it knows that we are going to return a number. So just like we saw with inference before with variable declarations, we have type inference around only the return value from a function. So we don't have to add in that return annotation if we don't want to. However, like I said, you and I always will. And here's why. Let's imagine that we've got another function here called subtract. And this is also going to take two arguments, a and b. They're both going to be numbers, and I'm going to leave off the annotation. So then inside of here, we'll just subtract the two numbers like so. And yeah, okay, I think that's it. We're good to go. So do you notice anything missing here? Well, I didn't put on a return statement. So if I hover over subtract right now, you'll see that we get an annotation on here that says that we have two arguments as inputs, a and b, and then we have a return value of void, which means that we are not returning anything at all. So TypeScript has used type inference here to say, hey, since you're not returning anything from the function, I guess you don't mean to return anything from the function. We made a mistake. We did not return a value, and TypeScript has not done anything to tell us that we made a mistake inside of this function. So if we instead add in an annotation for the return type right here of number, like so, we'll very quickly see an error message. That would be our signal that, hey, we probably made a mistake inside the function, and we should add on a return like so. So that's why you and I are always going to use return annotations. It's because we could very easily make a mistake inside of a function and forget to return a value, or even return an incorrect type. If we do so, TypeScript is not going to give us an error. It's just going to think, oh, that's what the developer meant to do. The only way that we're going to get an error is if we add on that annotation right there. So like I said, although we get inference on the output from my function, we are not going to use it. We're always going to add that annotation in. All right, so that's functions in a nutshell. One or two quick more topics, so quick pause, and I'll see you in just a minute. In this video, we're going to take a look at some alternate forms of syntax around annotations for functions. So underneath my two functions I already have, I'm going to define another one called divide. And you'll notice I'm going to use the keyword function right here. So how do we use these annotations with the function defined with the function keyword? Well, basically the exact same way. So we'll have two arguments, a and b, and we need to annotate both of them. So we'll say a is going to be a number, and b is going to be a number as well. Then to annotate the return type of this, again, right after the argument list, we'll put in a colon, and then the type of value we expect to return. then we can return A divided by B like so. Now this syntax is going to also work for anonymous functions assigned to variables too. So I could say const multiply will be a function. This will take two arguments of A and B, once again, both numbers. And again, right after that argument list, we can annotate the return type as well. And so then inside the function, A times B like so, and that's pretty much it. So anytime that we need to define a function using an arrow, a named function, or an anonymous function assigned to a variable, we're always going to see a near identical form of syntax. It's always going to be the arguments with a colon and then the expected type. And then immediately after the closing parenthesis, we'll do another colon and the expected type of the return value from the function. And that's pretty much it. Okay, quick pause here, and we'll talk about one last thing in the next video. In this video, there's one last quick thing I want to mention, and that is one very special type that we haven't really discussed too much, except in kind of passing. So at the bottom of this file, I want to define one more function. I'm going to define a function called logger. This thing is going to take some message that is a string. And then inside the function, I want to just console log that message, like so. So the only goal of this function is to call console log, and it does not actually return any value. So there's no return statement inside of here. To annotate this fact, as a return type, we'll put on :void, like so. So void right here means that we have a function that's going to not return anything. Technically, a function that returns void can return null, and it can also return undefined. But effectively, we use void right here to say there will be no return value from this function. If we ever accidentally return something, like so, we'll very quickly get an error message that says, hey, you can't return anything at all. Now there's one other very special type associated with function return values as well. So I'm going to make one more function in here called throw_err. And throw_err will also take a message that is a string. And then anytime we call this, I'm going to immediately throw a new error with that message like so. Now just so you know, anytime you throw an error, the function will technically not actually return anything. So to indicate that, we could put on a colon right here that says never. And that means that we are never going to actually reach the end of this function. So we're never going to execute the function completely. At some point in time inside of here, we're going to throw an error and exit the function early without returning any value. Now this is a really big corner case. It's actually pretty darn rare that we're going to want to intentionally throw an error like this. It's much more common for us to have some actual return value in here. Like let's say if there is no message for some reason, then we will throw an error. And then otherwise we will return I don't know, maybe just the message like so. And so in this case, we would still annotate this as returning a string even though it throws an error. So we only annotate a function with the type never when we really truly never expect a function to return anything ever. If we at least expect it to return something eventually and only possibly throw an error, that's totally fine. We're still going to annotate it with whatever we expect it to eventually return. And that does include the case where we return nothing like so. So in this case, we would still do a fallback to void because we are technically not returning anything, and there's just a chance of us never reaching the end of the function. Okay, so that's pretty much it. Let's take a quick pause right here and move on to our next subject. There's one last quick thing I want to mention around functions. So down here at the very bottom, we're going to add in one last example here. Let's imagine for a second that we have some object that describes today's weather. So maybe we call it forecast like so, and maybe it's got a date to indicate today's date, and the current weather outside. So maybe that will be a string that we'll call sunny, like so. Now let's try creating a function that's going to take that forecast and just log out the weather. So to do so, we could say something like const log weather, and then we're going to get some forecast object. And we need to annotate the return type, or the argument type right here. So to do so, we would put in an object literal, just like we saw previously with our variable annotation, like what we saw right here. So we would put in a colon, and then curly braces, and list out all the different properties that we would expect this forecast object to have. So maybe it will be a date that has a date type, and a weather that has a string type. I'm going to zoom out for just a second so you can see that whole line. Then after the list right there, I'm only going to try to log out the current weather, so there's not going to be anything I'm going to return. So I'll mark the return type as void, and then put down my arrow for the function like so. Okay, I'm going to zoom back in. So now if we wanted to, we could do a quick console log of forecast.date and a console log of, say, forecast.weather, like so. And then just as a quick example down here, we could try calling log weather with the forecast object. Now just to make the variables in here a little bit more clear, maybe rather than calling this forecast, it should be like today's weather. Maybe that makes a little bit more sense. That's better. All right, now one little optimization we could do here would be to use a little bit of ES 2015 syntax and attempt to destructure the date and weather properties out of the forecast variable right there. So in other words, rather than having to refer to forecast.date and forecast.weather, I want to just pull those two properties directly off inside the argument list. If we were using normal ES 2015 syntax, I'll put a quick example right here, we would write out something like this. We would say const log weather. And then inside the argument list, we would put a set of curly braces and list the two properties we wanted to access. So in this case, date and weather, like so. And then we could do a simple console log of date and of weather. So how do we use this kind of syntax right here with a TypeScript annotation? All right, I'm going to remove the ES 2015, and we're going to adjust the syntax in here just a little bit. So if we ever want to use destructuring along with an annotation, all we have to do is replace the variable itself with the actual destructuring statement. So instead of forecast right there, I'm going to replace it with a set of curly braces, and I'll list out the different properties I want to pull out of that object. So it'll be date and weather, like so. And then I can adjust the body of the function to be just date and weather. So notice that we did not try to stick the annotation types along with the destructuring. The destructuring portion and the annotation are always going to be two separate statements separated by that colon right there. So we're first going to do our destructuring, and then we'll try to do the actual annotation right after it. All right, so now we've seen that. Another quick pause right here, and we'll move on to our last subject around annotations and inference. I know we spent a lot of time talking about annotations and inference, but we've got just one last little subtopic to discuss, which is objects. Now, this discussion is going to go a lot more quickly because all we're really discussing here is how we do stuff like object destructuring, which we kind of saw an example of in argument list just a second ago. So let's just flip directly back over to our code editor and talk about how to work with objects around this annotation stuff. So inside my annotations directory, I'm going to make another file called objects.ts. And then inside of here, I want to declare a new object called profile. And this will be a profile for a person. So maybe they have a name like Alex, maybe they have an age like 20, and we'll say that this person also has some coordinates, like their physical location in the world. So I'm going to abbreviate that as simply coords, and then I'll give them a latitude and a longitude property inside there. So we've got a nested object right here. We've got the latitude and longitude representing this person's physical location in the world. Now, last thing I want to add to this object is a method that will change the age of this person. So obviously we could do something like, profile.age equals 20, but let's make a separate function just to have a nice function to call. All right, so one more property we'll add in here is setAge. And rather than defining this as like a function like so, I want to try using the ES 2015 syntax for defining a method inside of an object. So instead I'll say setAge, I'll put my argument list in, and then the function body. So let's try adding in some annotation for this function right here, using the same rules that we just learned. So I'm going to put in a age as an argument, and then the type of this argument, which will be a number. If we're just updating this person's age, I don't really expect to return anything from this function, so I'm going to annotate the return type as being void like so. So then we can write out our implementation inside the function. We can say this.age is age. All right, so that's an example of a function being defined inside of an object with the function annotation on it. So let's now try doing a little bit of ES 2015 destructuring and pulling some different properties out of this profile object. So for example, let's try destructuring out the age property right here and figure out what the exact syntax for that would be. So of course we could do something like const age is profile.age, but like I said, we want to use destructuring instead. So instead, I'm going to write out just profile, and we can do normal destructuring like so. Now, if we really wanted to put a type annotation on here for some reason, like maybe we fall into one of those three categories that we discussed earlier, right here, if we really wanted to put on some annotation directly onto the variable right here, we could do so by writing out a colon and then the structure of the profile object. So we would not just say, oh, this thing is going to have like age that is a number. Instead, we have to list out the structure of profile and the different properties that we want it to have. So in this case, we would put down curly braces, age, and number like so. So notice how this seems to kind of like violate the rules of annotations. Previously, when we were talking about variable annotations, we had said, oh yeah, we just put the type of the variable or the type of value that we're going to assign to this variable. So we're creating a variable right here called age. And so you might think that we only have to label it with the type that age is going to refer to, which would be number. But that's not the case. If we want to use destructuring, we have to write out the expected structure of profile over here on the right-hand side. So I expect this value right here to have a structure that is an object with an age property that is a number. So now to make things just a little bit more complicated, let's try also destructuring out our latitude and longitude as well. So this is going to be some nasty stuff, but it'll be some pretty good practice. So we would write out one set of curly braces. We would say, look at the chords property, and then try to pull out latitude and longitude out of there. And we want to get all that from the profile object like so. Okay, so if we were just doing plain destruction without an annotation, that is what it would look like. So it'd be just identical to the normal ES 2015 syntax. But once again, if we fell into one of these conditions where we had to put in an annotation, all we would have to do is once again kind of mirror the object structure that we expect profile to be. So it's going to be a little bit nasty here. Right after the destructuring, we can put in a colon. Then we'll start to describe the structure of the profile object. So I'll put a set of curly braces. I'm going to say that this thing is going to have a property chords. That's going to be an object. And inside of that inner object, we've got a lat property that is a number. And an LNG property that is a number as well. Now this is a really long line, so I'm going to save the file really quickly just to get it to reformat so you can see the whole line in total. So once again, kind of unexpectedly, we do not just list out the expected type of lat and long. And I think this example right here will give you a better idea of why that is. If we consider back up here, if we had only put number, well, what would happen if we wanted to destructure multiple properties and also pull out, say, this person's name as well, which was a string? If this was the case, is number referring to the type of age or name? So this is why we have to kind of double up on the structure whenever we are doing the destructuring. So age is a number and name would be a string. We have to label the type of all the different properties coming out of that object. Now in this case, you'll notice I've got a little error here around name. That's totally fine. It's just because of the way my project is structured. Chances are you see an error here as well that says something like name was also declared. If you see that, totally fine, you can ignore it. All right, so that's it around objects. Like I said, I just wanted to very quickly talk about destructuring around objects and what annotations for them look like, and also how we tuck in function declarations inside of there as well with some annotations. Okay, so that's pretty much it on type annotations and type inference. So we've gone over several plain definitions, went over some examples. We spoke about why we care about these. Remember, it's because we want to make sure TypeScript is aware of the type of all the variables we work with. And we also discussed when we're going to use annotations and when we're going to fall back to inference. Whenever we're working with functions, we're going to rely upon annotations 100% of the time for both arguments and return types. When we're working with variables, we're going to rely upon type inference as much as we possibly can, unless we are relying upon or in one of these three scenarios right here. All right, so now that we've got through a lot of this kind of boring stuff, let's take a quick pause right here and continue on our next subject in the next video. In this video, we're going to start to discuss arrays in TypeScript. As usual, we'll start off with a plain definition, then walk through some examples, and then talk about why we care about these things and when to use them. So let's get to it. First, a quick definition. When we work with arrays in TypeScript, we are essentially working with plain JavaScript arrays. So we still have all the features that you are already used to. We can push elements into an array or pop elements out. We can map over an array, write a for each loop, use a for loop, all that kind of good stuff. The one big difference with arrays in TypeScript is that generally we only stick elements with a very consistent type into the array. So for example, if we make an array that is supposed to contain strings, we will only put strings inside there. And if we try to put a number in or a Boolean, we're going to very quickly get an error message. So in general, when we work with arrays in TypeScript, we're making use of one specific type of element inside that array. We can technically put different types of values inside of an array, but if we want to do so, we have to be very explicit about it and add in a special little type annotation. And we are going to look at a quick example of how to do that as well. All right, so as you might guess, pretty critical to look at some code samples here. So that's the only definition we're going to get. Let's flip on over to our code editor and start writing out a little bit of code. So back inside my editor, I'm going to make a new file inside of my root project directory called arrays.ts. Then inside of here, I'm going to declare an array and just assign it to a variable. So I'll say const car makers is going to be an array of strings that has strings like Ford, Toyota, and Chevy, like so. If I now hover over that array right there, you'll notice that I have an added on annotation that says that car makers is going to be an array of strings. So this is type inference in action. TypeScript took a look at the value inside this array right here, and it said, okay, looks like those are all strings, so I guess car makers is always going to point at an array that only contains strings. Now that's type inference doing that for us automatically. Remember, if we wanted to be really explicit about this, we could always put on a colon, string, and then square brackets like so. So that's a type annotation that says that this variable is always going to point at an array that contains nothing but strings. We will sometimes want to add in type annotations when we are working with arrays. So the case in which we would want to do that is if we initialize the array as an empty array, like so. In this case, if we did not have the annotation on here, TypeScript would not have enough information to understand what type of value was going to be inside that array. So for example, if I now hover over car makers, it says any array, and that means we can put any type of value inside there. Remember, we want to avoid the any type as much as possible. So if we ever have to initialize an array as an empty array, we will add on our annotation. So I'll put in string like so. Otherwise, if we're going to initialize our array with some contents already inside of it, then we don't need that annotation. All right, now we're not limited to just putting basic values inside of arrays. We can also put complex objects inside as well. So for example, let's try creating a new array here called dates. And I'm going to be creating an array and assigning it a variety of new date object instances. If I now hover over dates, once again, it'll tell me that this is going to be an array that contains instances of dates. Next up, we can also write out two-dimensional arrays inside of TypeScript very easily. To do so, we're just going to double up on the syntax around that annotation we put together. So for example, let's say we've got an array called cars by make, and I want to have like a 2D array of strings inside of here. So inside of the first element of the outer array, I'm going to put a new array inside of here, and then I'll put in like some actual model of car made by, say, Ford. So maybe an F-150. And then at the second index, I'll put in a car by Toyota, which is a Corolla. And then finally, something by Chevy. How about a Camaro? Like so. So if we now hover over cars by make once again, we'll see the type annotation for a two-dimensional array. In order to indicate a two-dimensional array, we'll write out the type of value that goes inside the inner array, then one square bracket and a second square bracket. So that means that we're going to have an array that contains arrays of strings. Right there, that's the inner array of string indication right there. Once again, we don't have to add in that annotation if we don't want to. The only time we would is if we didn't have any contents in the array when we initialized it. So in this case, we would write out string, square bracket like so. Now, like I said, when we type an array, we're putting on a restriction on what type of value we can put into it. So let's have a quick pause right here. When we come back in the next video, we'll see a very quick example of that. Now that we've seen a couple of examples of arrays, I want to walk through some kind of corner cases around them. So essentially, I want to discuss why we care about these arrays. Like, what's so big a deal about arrays in TypeScript that we're making this into a separate topic? Well, here's why. When we work with arrays in TypeScript, we got a couple of different advantages and a couple of different downsides as well. So first off, TypeScript can help us when we make a typed array by helping us do type inference whenever we are pulling a value out of an array. Let's see a quick example of that. So back over inside my code editor, I'm going to put a little comment down right here, and I'll say help with inference when extracting values. So in other words, if we look at our CarMakers array right here, we know that it is an array of strings. TypeScript knows that as well through type inference. So that means that if we ever pull an element out of this array, either by using, say, the pop method or by direct index access, TypeScript will know that we are going to be pulling out a string and help us with type inference with the new variable that we're assigning this value to. So let's take a look at an example of that. Let's say that I'm making a new variable right here, and I'm going to call it something like car. If I then take car makers and do an index access to it, I can now hover over car, and you'll see that type inference has come into play, and TypeScript knows that this variable is going to be a string. It knows this because it knows that car makers is an array of strings, and we just pulled one value out of it. Likewise, this also works if we try a pop method. So let's say we've got my car, and we do like car makers dot pop, like so, to remove the last element in the array. Once again, TypeScript knows that car makers has an array of strings, so when we call pop, it's going to return an instance of a string. So we can once again hover over my car, and we see, yep, TypeScript has correctly inferred that my car is going to be a string. All right, so that's one benefit of making use of arrays in TypeScript. Secondly, TypeScript can help us prevent us from adding in incompatible values into an array if we have correctly typed the array. So for example, back over here, once again, we can say prevent incompatible values. So once again, if we take our car makers array right here that only contains strings, and we try to add in some element that is not a string, like let's say a number, we'll very quickly see an error message. TypeScript is telling us here, hey, you're trying to put in a number to a collection that is only supposed to contain strings. So that's going to help us from putting in dissimilar elements into one single array. Now, once again, if we want to have multiple different types in an array, we definitely can do that, but we have to use some special syntax to do so. We'll take a look at an example of that in just a moment. All right, third, anytime we declare an array, we get a lot of help with built-in functions like map, for each, reduce, and so on, whenever we are iterating over a collection of elements. So for example, if we flip back over once again, we get help with map or for each and reduce. So for example, if we do car makers dot map, we can add in a function right here that will be called with every element in the array. So I'm going to receive each car as a string, and from this, I'm going to return, say, a string as well. We'll just do a straight pass through here. So I'll take the car and return it immediately. So TypeScript is going to make sure that the value that we are putting into this function right here will be a string. And so because of that, because TypeScript knows that car is going to be a string, we get access to a lot of different autocomplete on the variable that comes in here. So for example, if I put in a dot right after car, I can then see the autocomplete appear with all the different methods that belong to strings. So for example, I can do a to upper case, like so. So anytime we start working with map, for each, reduce, or any similar helpers, TypeScript is going to give us autocomplete on the variable being passed into this function right here, which is a nice little benefit. All right, now the last item we're going to talk about right here is that we can in fact put different types of elements inside of an array. Let's take a quick pause though, because there's a couple different corner cases around this and some interesting syntax we need to understand at the same time. So quick pause, and I'll see you in just a minute. In this video, I want to show you how we can still use arrays with multiple different types of values inside them. So let's flip back over to our code editor and once again write out a quick example. So I'm going to put in a new comment down here that says flexible types. And then I'm going to declare a new array called important dates, like so. So this is going to be an array that contains some different important date values. Maybe some of them are going to be instances of date objects, and maybe some of them are going to be strings that contain like a date inside them. So in other words, I want to have two different types inside this array. Some are going to be instances of date objects, some are going to be strings. So to do so, I could simply write out new date, and then like an actual string in here. So 20, 30 maybe, 10, 10, like so. If I now hover over important dates, I'll see an updated little type annotation here. So in this case, notice that little pipe operator right there. We've spoken about that very briefly before. That's kind of like an OR statement for types. So this can be read as saying this is going to be an array that contains elements that are a string or a date. So everything inside this array can be treated as a string or a date object. Now, it is important to understand this annotation right here. If you ever happen to, say, only initialize the array with date objects, and we hover over this once again, TypeScript now thinks that this array will only contain dates. So if we wanted to specifically say that this array can contain multiple different types, we would once again have to add in a manual annotation here. So I could put in a colon, and then just like that syntax we saw in that tooltip, we would say date or string, and then the square brackets right after. And so now once again, if I hover over important dates, we've overridden type inference and said specifically this array can contain either type of value. So now, right after that, we could do important dates.push and add in a string. Well, let's do a real string here. So 20, 30, 10, 10. And important dates.push new date like so. And as you might guess, if we now try to put in a new value that is just like a plain number, we will see an error because that is neither a string nor a date object. Now, as we mentioned before, you will want to put in this annotation if you ever do not initialize the array with a date literal and a string literal. Alternatively, if you initialize it with an empty array, you will want to have the annotation on there as well. If we don't put on that annotation with an empty array, we're always going to end up with an array of the any type, which we always want to avoid as much as possible. All right, so that's how we put in multiple different types of values into one single array. Now let's take a quick pause right here and talk about where we are going to actually make use of these typed arrays. And as you might guess, it's probably going to be everywhere. So quick pause, and I'll see you in just a minute. In this video, we're going to do a quick wrap up on arrays and discuss when we're going to use them. Well, pretty simple and straightforward. As you might guess, we're going to use an array in TypeScript anytime we want to represent a collection of records, usually with some very similar type about them. Now, this might seem like a silly lecture to put in here, like I'm sure you've got a good idea of when to use arrays, but it turns out that there is another very similar data structure in TypeScript, very similar to arrays, called tuples or tuples. So we're going to talk about tuples in just a second, and they're going to look very similar to arrays, but with some distinct little differences about them. So for right now, I just want you to understand that we're going to continue to use arrays anytime we want to represent a collection of different records. All right, so let's take a pause right here. When we come back to the next section, we're going to start discussing tuples and how they're just slightly different from arrays. So quick pause, and I'll see you in just a minute. In this video, we're going to follow up on arrays by discussing a very similar data structure called a tuple. Now, you'll sometimes also hear this pronounced as tuple. Totally up to you, either tuple or tuple, either way you want to do it. So as usual, definition, examples, and so on. All right, so first off, quick definition. So when we are working with a tuple or a tuple, we have something that looks very similar to an array. Very, very similar. But the big difference here is that we are going to have every element inside of this array-looking thing represent one specific property about some record. So whereas an array tells us a bunch of different records or organizes a collection of different records, a tuple usually contains multiple different properties to describe one single thing. And as a follow-up to that, usually inside of a tuple, we will mix and match many different types of data inside there. So let's take a look at a quick example. All right, I want you to imagine that we've got some object like the one you see right here. And the goal of this object is to represent a drink, like in this case, soda or pop, whatever you want to refer to it as. So maybe inside this object, we have a color property that is a string of brown, carbonated that is a boolean of true, and sugar that is meant to represent the sugar content of the soda in grams. So that will be a number here. So as you might guess, this would represent maybe like Coca-Cola or Pepsi or something like that. So representing a drink or a soda with an object like this, I think makes a lot of sense if you're coming particularly from a JavaScript background. We've got one object to represent one drink, and this object has some properties that describe what is going on with this singular drink. Now, just for fun, I want to take this object right here, and I just want to try to represent it with a slightly different data structure. Let's try to represent this object with an array instead. So how can we do that? Well, maybe we would say that we would take each of these values, so like brown, true, and then 40, and stick them into this array like so. So now we have a slightly different looking data structure that still represents a drink. In turning this into this array right here, we have lost a little bit of information. In other words, you and I as developers can very easily look at an object declaration like this right here and very quickly understand, okay, the color is brown, carbonated is true, and sugar is 40. When we start to represent this object as an array, we've lost those different property labels on here. And so you and I as developers would have to memorize the fact that the first element inside this array is supposed to be a string representing the color. The second element is supposed to be a Boolean representing whether or not the drink is carbonated. And then the third element inside there is a number representing the sugar content. So the big difference between representing this as an object and something that looks like an array is really just that loss of information in these labels. No longer is our code really self-labeling. Instead, we have to kind of memorize the order of properties inside of here. So this is exactly what a tuple is. We have what looks like an array, and we put in our property values into that array in a very specific order. So the ordering part is really critical. If we start to arbitrarily swap around elements inside of here, we are no longer going to understand which different value represents which property. So if you and I have memorized, like as developers, that this array is always supposed to tell us the color, then the carbonation, and then the sugar content, and we swap some elements inside of here, and we don't have those labels, now this is kind of a meaningless record because we're now trying to indicate that our color is 40, carbonation is true, and sugar content is brown. So when we work with a tuple, we have a fixed series of elements, or a fixed order, I should say. All right, now let's take a quick pause right here. We're going to come back to the next section, get some more examples around tuples, and start to write out some code around them. So quick pause, and I'll see you in just a minute. Now that we've got a basic understanding of what a tuple is, let's try writing out a little bit of code to understand how we work with them in TypeScript. So back inside my editor, I'm going to make another new file inside my project directory called tuples.ts. Then inside of here, to get started, I'm going to write out an object that looks like that drink object that we just put together, or was inside that diagram. So I'll say const drink is going to be an object with a color of brown, carbonated is true, and sugar is 40, like so. So a object works perfectly here, right? You and I can read this and very easily understand what's going on. However, we have access to tuples as well. So we could alternatively try to represent this with a tuple. To do so, we could write out, let's say, some new drink here, like maybe Pepsi. And then I'm going to write out what looks like an array. And I'm basically just going to take the different values out of this object and put them into this array in a very specific order. So I'll put in brown to represent the color, then true to say that it's carbonated, and then 40 to represent the sugar content. In this case, like 40 grams, say. Now here's the only issue. What we just defined right here is an array. So if you hover over Pepsi right here, take a look at that type annotation. This is saying that Pepsi is going to be a string or a number or a Boolean array. So the issue right now is that we could freely swap the order of elements inside of here. And in general, we don't want to do that. Because remember, the order inside of a tuple has a very specific meaning to us. You and I, as developers, have to memorize that the first element inside of here represents the color. And then the second element represents carbonation, and the third represents sugar content. So if you and I start to write out some code that's going to swap the order, like let's say Pepsi at 0 is now going to be 40, and Pepsi at 2 is now going to be brown, we have lost information. So you and I, as developers, have an assumption about the order of elements inside of here. And if we start to break that order, our data model completely breaks down. So we're not going to define this thing as a simple looking array in TypeScript. Instead, we're going to add on an annotation to this thing. This annotation is what's going to turn this line, or this array right here, into a tuple. So right after Pepsi, I'm going to put in a colon. And then rather than putting out a type right here and then square brackets, I'm going to instead put in a pair of square brackets And then inside of here, we're going to write out the specific order of types of elements inside of this tuple. So I'm going to write string, then Boolean, then number, like so. So this is what makes this thing into a tuple as opposed to an array. We are saying that this array is going to always have a very consistent ordering of elements inside of it. Always a string, then a Boolean, then a number. So you and I as developers can read this thing right here and understand that there is some meaning to the order of elements inside of this array looking thing, or I should say tuple. If we now try to change the order of elements inside of here and say Pepsi at 0 is now going to be 40, we'll very quickly get an error message. The error message is going to tell us that we're trying to assign a number to an index inside that tuple that is supposed to be a string. So again, by putting on this different looking type annotation right here, we are turning this array into a tuple. An alternate way of writing this thing out right here, rather than putting the type directly in line as an annotation, would be to create something called a type alias. We're going to discuss type aliases at great length later on inside this course, but this is a very good place to use a type alias, so we're just going to cover them very quickly right now as a quick aside. So rather than having to repeat out this definition right here every time we want to create a drink, we can instead, right above, write out type, and then maybe drink with a capital D, and then we'll list out the tuple structure. So it's going to be a string, Boolean, and then number. This does not create an array right here. So no array is being created. Instead, it's creating the idea of a tuple inside of our application. It's a brand new type that we can freely use in any place that we would normally put a type. For example, in a type annotation. So now rather than manually writing out all the different types right here, I could instead say drink like so. And this is 100% equivalent to what we just had a moment before. So now I can very easily reuse this tuple structure and say maybe Sprite is also a type of drink, and it will be clear, it is carbonated, and maybe it also has a lot of sugar. And then maybe we also have tea, that is a drink, and maybe it's also brown, not carbonated, and 0 sugar like so. So we've now abstracted out the idea of what a drink is into a type alias. Now we can freely reuse it throughout our application to indicate that each of these different things are not plain arrays, instead they are a tuple that represents a very specific record inside of our application. All right, now I'm going to be honest with you, we are not going to use tuples very often. So let's take a quick pause right here. We're going to come back in the next video. We're going to discuss why we care about these things and where we're going to use them. And we're going to find out that maybe tuples are not super useful in TypeScript. So quick pause, and I'll see you in just a minute. In this video, we're going to discuss why we care about tuples and when we might use them. Now, I'll be honest with you, I am not a huge fan of tuples, and I don't think you're going to really be using them in a very regular basis with TypeScript. There are a couple exceptions. Most notably, I think that if you're ever working with a CSV file and you want to represent, say, a single row, you might reach out to a tuple. We'll actually work with the CSV file later on inside this course, and so you'll see a great example of that in action. So let me tell you exactly why I don't think you're going to be using tuples that often. At the bottom of this file, I'm going to declare a new variable called car specs, like so. And I'm going to assign it some data that has a real important meaning around a car, like some specifications around a car. So I'm going to assign it a tuple of 400, 3354, like so. And I'll make sure that I annotate the type on here to make sure it's really clear that this is a tuple. So it's a number and a number like so. Okay, so here's the question. What do these numbers mean to you? I mean, looking at this line of code right here in isolation, what do those numbers mean? Clearly it has something to do with these specs around a car, but what is the purpose of these numbers? Well, for us as engineers, I don't think that we can really look at this line of code and understand what is going on here. We know that there are two values, we know that they are numbers, but that's pretty much it. So let's try writing out that same type of data structure right here, but instead as an object. So if I write out a very similar variable right here, maybe I'll call it car stats this time, I'm going to make it an object, and because it's an object this time, I have to add in a key and a value. So for the value 400, I'm going to give a key of horsepower. Horsepower, yeah, there we go. And then for the 3354, I'll put in weight, like so. All right, so what am I trying to illustrate here? Well, if we use a tuple to represent some meaningful data it's really hard for you and I as engineers to look at this value right here and understand what we are trying to say. However, in an object format right here, because we are forced to put in a key, it is immediately obvious what we are working with. I can look at this object right here and understand, oh, horsepower, 400, got it. And then for weight, this is the weight of maybe a car in pounds, 3,354 pounds. So when we make use of an object to model a record, it's really clear what we are working with at one glance. But when we are working with a tuple, much harder to understand exactly what is going on at a glance. So honestly, I think that in general, anytime we want to model a record or record it in our application somehow, we're going to stick with a JavaScript convention of reaching for an object as opposed to a tuple. Now, like I said, there are some corner cases where we might want to use this in some types of applications, and we will see an example of it later on inside this course, actually with one of the first 2 or 3 applications we're going to work on. All right, so I'm sorry to teach you about tuples and then say, hey, we're never going to use them, but nonetheless, it is a feature of TypeScript that is very prominently kind of featured in the official documentation. So I just wanted to make sure you have at least a passing idea of what these tuple things are all about. So let's take a quick pause right here, and we're going to move on to our next topic in the next video. In this video, we're going to start to discuss interfaces in TypeScript. So as usual, we'll get a plain definition, some examples, and so on. As a quick aside here, we're going to spend a pretty good amount of time in TypeScript talking about interfaces. The interplay between interfaces and classes is how we're going to really get very strong code reuse when we are writing TypeScript code. So if you understand interfaces really well, it's going to help you design really excellent applications. As a matter of fact, the entire second half of this course, where we're going to work on a lot of applications, is really going to come down to understanding how we can get interfaces and classes to work together really, really nicely. So if you don't understand this first take through interfaces, totally fine, because we're going to be discussing them quite a bit. All right, so with that in mind, let's take a look at a quick definition here. So when we have interfaces, we are going to write out some amount of code to define a new type inside of our application. The goal of this new type is to describe the different property names and the different property types that that object has. So when we create an interface, we are creating a new type inside of our application just the same way that we have types like string or Boolean or number. We're creating another new type. It's a custom type that you and I are going to define. Now, understanding interfaces is a lot easier when you have some code in front of you. So let's do a quick pause right here, come back in the next video, and start to write out some examples. In this video, we're going to start writing out some code to get a better understanding of how interfaces work. You'll notice I'm back inside my code editor, and inside of my root project directory, I'm going to make a new file called interfaces.ts. All right, so inside of here, we're not going to write out an interface just yet. Instead, I first want to define an object that represents a car. We're then going to write a function that kind of operates on that object, and we'll start to introduce interfaces. So to get started, I'm going to make a variable called oldCivic. Like so. Just so you know, a Civic is a type of car, or like a vehicle of sorts, so it's a Honda Civic. By saying old Civic, I just mean to indicate that we are going to make an object that represents a Civic that was made many years ago. So inside this object, I'm going to add a couple of different properties to describe exactly some things about the Civic. So I'm going to give it a model property. Actually, you know what, let's give it a name instead. That's just a little bit more clear. So this car is going to have a name of Civic. I'll then give it a year that it was built of 2000, and then a broken property to describe whether or not this vehicle still runs. So I'll say it's broken. True. Now that we've put that object together, I want to try creating a function that's going to take in this object and just print out some different properties about it. So I'm going to define a function called printVehicle. Then I'm going to add in a single argument. So we want to call this function with a car. I'm going to refer to this argument as, how about just like vehicle? That makes sense. And then remember, we need to add in a type annotation to describe exactly what properties or what type vehicle is. Right now, if I hover over vehicle, it says that it is of type any. Remember, we want to avoid any types inside of our application. Now we saw how to add in an annotation for an object inside of a function just a moment ago. So we're going to put in the set of curly braces, or excuse me, a colon right there, and then a set of curly braces. And then we'll list out all the different properties that we expect this argument to have, and their different types. So I expect a vehicle to have a name that is a string. And remember, inside this type annotation, to separate different properties, we'll place a set of, or a semicolon like so. I then expect a vehicle to have a year that is a number. I'm going to zoom out for a second so you can see this whole line. And I expect a vehicle to have a broken flag that is going to be a Boolean. Finally, I'm going to add in a type annotation to the return of this function. So right after the argument list, I'll put in a colon. I don't expect this function to return anything, so I'm going to give it a type annotation of void like so. Remember, void means our function returns nothing. All right, I'm going to zoom back in. So now inside of here, we can do our actual implementation. So I'll just do a couple console logs using properties from the vehicle. I'm going to use an ES2015 template string, so I'm going to use some backticks here. And I'll do some things like, let's say, how about name? And I'll do vehicle.name. I'll do another little statement here. I'll do something like year, vehicle.year. And then one more for the broken flag as well. So broken. Oh, typo there. There we go. Vehicle.broken. Cool. So now we should be able to call print vehicle and pass in old Civic. Old Civic structure is a name that is a string, year that is a number, and broken that is a Boolean. And so that meets the type annotation we just put on that argument right there. So we should be able to pass in old Civic and not have any issue. So I'm going to take print vehicle and pass in old Civic, and everything looks good to me. Perfect. All right, now I say perfect, but maybe not quite perfect. There's one little issue inside this file right now. So I bet you can guess what it is. This type annotation right here is really long. It's kind of hard to read. And if we had any more properties on this object, the type annotation would become even harder to read. In addition, if we added in more functions that we expected to call with old Civic, we would then be duplicating this type annotation for each of those different functions. And so we would have this really long annotation right here duplicated several times throughout this file. So as you might imagine, yeah, that's probably not the best. So let's take a quick pause right here. We're going to come back in the next video and figure out how we can improve this file by using an interface. In the last video, we wrote out a little bit of code, but it's got one little issue. We've got a really long type annotation on this function right here. I think you can easily imagine that if we had several other functions inside this file that all expected to be called with old Civic, we would have to repeat this type annotation right here several times over. And that would be a lot of duplicate code. So to fix this, we're going to create an interface inside this file. I'm going to go up to the very top, and I'm going to define an interface by writing out the interface keyword, and then a name for the new type that I am creating. Remember, anytime we create an interface, we are creating a new type. A type in the same way that a number is a type, or a string, or a Boolean, or so on. So I'm going to create an interface called vehicle. Whenever we create an interface, we're always going to use a capital letter on the leading edge of the word. You'll also notice I'm using kind of a generic term right here. So I'm not creating an interface called like Civic, or an interface called Old Civic, or New Civic, or anything like that. Instead, I'm creating a very generic name right here to describe what different properties a vehicle might have. So then inside these curly braces, I'm going to list out the different property names that I expect an object that is a vehicle to have, and their different types. So in order to be a vehicle, you must have a name property that is a string. You must have a year property that is a number, and you must have a broken property that is a Boolean like so. So once again, we have now created a new type inside of our application called vehicle. And in order to be a vehicle, you have to have these properties, and they must have these different types. So we can now think of vehicle right here as being kind of like a variable of sorts that refers to a type. So rather than writing out this really long form type annotation right here, I can delete that full annotation and replace it with just vehicle, like so. So what are we saying here by putting this code in? We are now saying that in order to call the print vehicle function, you must pass in an object that meets the specifications provided by the vehicle interface. In other words, to call this function, you must provide an object that has a name that is a string, a year that is a number, and broken that is a Boolean. The old civic object satisfies each of those requirements. It has a name that's a string, year that's a number, and broken that is a Boolean. So we are allowed to pass in old civic to print vehicle. You'll notice that down here where we actually call print vehicle, there is no error and no warning or anything like that. So as soon as we added in this statement, TypeScript did a little bit of checking for us. A little process went on behind the scenes. TypeScript took a look at the argument we provided, and it said, okay, we need to look at that old civic object and make sure that it satisfies this interface. We need to make sure that old civic has all the appropriate property names and types. And so behind the scenes, TypeScript looped through all these different properties and made sure that old civic had each of those different property names and the appropriate value for each one. If I change any of these types right here and assign a different type, let's say instead of broken, I'm going to put in like just a 1, like so. As soon as I do that, you'll notice we get an error message down here. So TypeScript is telling us that in order to pass in old civic, we have to have a broken property that is a Boolean. But we have a broken property that is a number, and that's why we're seeing an error. So if I change that 1 back to true, everything works again. Likewise, if I misspell any of the property names inside this object, like let's say is broken instead, now our object can no longer be considered to be a vehicle. Remember, to be a vehicle, we have to have a broken property, but I provided a property that is broken. Because those property names are different, TypeScript will not allow me to pass in old civic into the print vehicle function. And if I hover over that error right there, it's going to tell me very plainly, down towards the bottom of this error right here, it says property broken is not present inside the object I provided, but it is required to be a vehicle. So once again, if I change is broken back over to broken, everything works again. Okay, so this right here is some of the very basic interaction or definition of what an interface is. So let's take a quick pause right here. We're going to come back in the next video and start to expand on this example just a little bit more. In this video, I want to add in a couple little notes around syntax of interfaces. So once again, when we define an interface, we're going to list out all the different property names and types that we expect something that is a vehicle to have. We are not only limited to expressing primitive values inside of here. We can instead express any different type we want to inside of an interface. So for example, let's say instead of the year property being a number, we instead want this to be a more complex object, like an instance of a date. To do so, I'm going to replace number with simply date like so. Now, in order for old civic to be considered to be a vehicle, you'll notice that we've got an error down here. We have to update its definition. So instead of year being a simple number, I'm going to instead assign it an instance of a date like so. As soon as I do so, that error down here goes away. So once again, we are not limited to just basic values or primitive values inside of an interface definition. We can assign any type inside there that we want. That also includes functions. So let's say that we want to say that in order for old civic to be considered to be a vehicle, we want it to also have a function called summary. So in other words, I want this object right here to have a property or a function called summary, and if we call it, maybe it should return a string that summarizes some different facts about the vehicle. To express that, I'm going to add in another property on vehicle called summary like so. And then instead of immediately putting in a set or a comma or a colon right there, I'll put in a set of parentheses and then a colon right after it. And I'm going to label what I would expect the summary function to return. So in this case, maybe it's going to return a string that summarizes some different facts about the car. So this right here says that anything that wants to be a vehicle has to have a function called summary that returns a string. If we then go back down to the bottom again, you'll notice we have an error down here as well. So now it says that we do not have a summary property inside of old civic. So to fix this up, we would have to add in a summary function that satisfies this type right here. So it has to be a function with no arguments that returns a string. And so we can add it on like so. So now to return some information about this vehicle, we could return about name is this dot name like so. And again, notice the ES 2015 template string here, so I am using backticks. So now that my object has a summary function that returns a string, it once again qualifies as being a vehicle. So if I go back down to the bottom of the file again, that error has now gone away. And now inside of my print vehicle function, rather than trying to pull off all these different properties one by one, I can instead rely upon that summary function. So I can call something like console.log vehicle.summary, like so. Cool. All right, so again, just two notes here. First off, we can use any type inside of our interface definition we want. We are not limited just to primitive values. Second important note is that inside of our interface definition, we can express functions inside there as well. So let's take a quick pause right here. In the next video, I want to share two more important notes with you around basic syntax of interfaces. So quick pause and I'll see you in just a minute. In this video, I want to go over two more pieces of syntax around interfaces. So to get started, I'm going to go down to the print vehicle function. Inside of here, you'll notice that our implementation now only accesses one property on the vehicle argument. The only thing we are referencing is the summary property. So I got a question for you. We are saying that the argument must be a vehicle. It must satisfy this interface is the terminology we would use. And we've said earlier that the vehicle must have a name, a year, broken, and the summary function. However, our function down here is now only accessing the summary property. So here's the question. Is it important for us to say that a vehicle must have these properties available? I don't think it really is. So what happens if I delete those additional properties? I can delete them, they go away, and now you'll notice I do not see any errors inside my file. Why is that? Well, when I call print vehicle right here, we are saying that in order to be passed into this function, you must satisfy the vehicle interface. So we pass in old Civic, and TypeScript behind the scenes does a quick check for us. It says, does this object right here satisfy the vehicle interface? So TypeScript is going to go back to the vehicle interface definition, and it says, in order to be considered to be a vehicle, you must have a function called summary that returns a string. It then looks at the old Civic object, and it says, okay, does this object have a summary property that is a function that returns a string? Yes, it does. And that's the only question that gets asked. It doesn't matter if we have additional properties on old Civic. It doesn't matter. When TypeScript tries to decide if old Civic is a vehicle or not, it's not going to say, oh, you've got these extra properties. Sorry, you can't be a vehicle. It's only going to check to see if it has this list of properties right here. If it has that list, awesome. It is qualified to be a vehicle. So the code we have here still works, but we've got a much more condensed interface definition. So here's the important thing here. Something I want to point out as like kind of step 2 of this little refactor. Now that our interface only has a single function definition in it, do you think the name vehicle is really appropriate here? Like, is calling an object that has a summary property that is a function that returns a string, does it really seem appropriate to call that a vehicle? I would say maybe it doesn't. Maybe a more appropriate interface or a name for this interface would now be something like, I don't know, reportable or something like that. So now we're saying that in order to be considered the type reportable, you must have a function called summary that returns a string. And so now to fix up our file here, down here inside of print vehicles, there is no more vehicle type, so I'm going to replace that with reportable. Now, just to be clear, the word reportable, I'm kind of meaning to say something that is reportable has a summary function that returns a string. So this is like something that can be reported. All right, so notice how our definition for the interface is now a lot shorter and a little bit more generic than it was before. So now back down inside the print vehicle interface or function down here, I want to just point out one more thing here. Notice how we've got a function called print vehicle. It takes an argument called vehicle and it refers to that function or that argument inside the function. But once again, I got a question for you. Does anything about this function now really seem like it has anything to do with vehicles? I don't think it really does. The only thing that this function really does is take in something that can be reported on and then console log a summary about that thing. So maybe we should update some of the terminology inside this function. Maybe instead of an argument called vehicle, we call this something that's called like, I don't know, report, or how about like item? Maybe that makes sense. And then inside, or rather than calling this thing print vehicle, I want to call it maybe something a little bit more appropriate, like print summary or something like that. And I'm going to update the reference down here as well to be simply print summary. Okay, so all we've really done here is kind of pointed out how our interface no longer really has anything to do specifically with vehicles. And so I just decided to rename it into something a little bit more generic. And I did the same thing with the function down here. So let's take a quick pause right here. We're going to come back in the next video and we're going to discuss why this was a very significant refactor by adding in just a little bit more code. So quick pause and I'll see you in just a minute. In the last video, we refactored our interface to have a little bit more generic name, and we did the same thing with our function down here. So now I want to do something kind of interesting inside this file. Right now we've got an object called Old Civic. I want to define another new object right underneath it. And I'm going to call this something like drink. Remember just a couple of videos ago we did some examples on drinks, and we said that a drink had like a color and carbonated and some other thing like that. Let's try expressing a drink object right here with some of those same properties. So I'm going to maybe give this thing a color that is brown and maybe carbonated, and that'll be a Boolean true. And then maybe it will also have like that sugar content. And that's really supposed to be like number in grams, so like 40 grams of sugar. And then I'm going to give this one more property. I'm going to give it a summary property. Summary is going to be a function. Anytime we call it, it's going to return a string. And so inside of here, I'm going to return something like my drink is, or how about has, and then this dot sugar, grams of sugar. That's reasonable. Once again, notice that I'm using backticks here to form up this string. All right, so here's what gets really interesting. Here's like the entire point of interfaces. If you don't get this quite right away, I'm going to show you a couple diagrams to really help you understand what's going on. But here's what's going on. Notice how our old civic function has a summary function tied to it. Or excuse me, old civic object has a summary function tied to it. Our drink object also has a summary function tied to it. These two objects right here represent very different things inside of our application, but they both have a summary function that returns a string. That means that they are both considered to be reportable types. So because they both have a property called summary that is a function that returns a string, this is of type reportable, and this is of type reportable. Because they are both of type reportable, we can use both Old Civic and drink with the function we defined down here. So I can call print summary with Old Civic. I can also call print summary with drink as well. And it works equally well with both of these very different objects. So what's the big point here? The point is that we can use a single interface to describe the shape or the different properties of very different objects. When we do so, we can have those objects implement different properties or different functions. And by doing so, we can make these very different objects interact with different functions that we create, like print summary right here. So this encourages us to write somewhat generic-looking functions. Notice how this is now print summary. Would it have made sense to have this be like print vehicle and then pass in drink to it? No, I don't think so. That would have not made a lot of sense. So instead, we decided to make a somewhat generic-looking interface that described what we had to do in order to call this function right here. I'm going to change that back to print summary, by the way. So in doing so, we've now got a much more reusable function inside of our application. This function can be used with any type of object that satisfies the reportable interface. And this feature, this right here, is what is going to encourage us to write more reusable code with TypeScript. Now I know this is like a super basic example and it's very contrived, but I just want this to be your first taste of how we're going to use interfaces in general. Now, to make sure everything is super crystal clear here, let's take a quick pause. In the next video, we're going to kind of reiterate what we did and what the entire point of this application was. We're going to take a look at a couple different diagrams to help you understand what's going on. And we'll move on to our next subject, where we're going to very quickly continue to see what the power of interfaces is inside of our applications. So quick pause, and I'll see you in just a minute. In this video, I want to show you a couple different diagrams to help you really understand what is going on inside this file and really understand what the goal of the interface is right here. So let's get to it. All right, on the left-hand side at the very bottom, we've got that print summary function that we just put together. We can kind of think of that interface that we are using to annotate the argument to that function as being like a gatekeeper of sorts. In other words, if we ever have any value inside of our application, like say old Civic or drink over here, and we want to use these values with the print summary function, we have to make sure that those values implement the reportable interface. In other words, these two values have to have a summary function that returns a string. If they don't, then they cannot be used with print summary. This mechanic right here of using an interface for gatekeeping is going to be one of the prime ways that we get some amount of code reuse inside of TypeScript. And you're going to see this strategy used over and over in every application we put together in this course. So the general strategy that we're going to use for code reuse in TypeScript is to create functions that accept arguments that are typed with interfaces. So all the different functions we're going to create are going to accept interfaces as much as possible. Obviously, not every last function we ever put together is always going to require an interface type argument. Sometimes we're going to have something that takes a string or a Boolean, or maybe a plain object in some far off cases. But in general, we're going to try to create functions that accept arguments that are typed with interfaces. And then in order to call those functions, we're going to make sure that we have objects or classes that can decide to implement that interface. So it's essentially this same scenario right over here. We created a function that takes an interface type as an argument. So other values inside of our application can opt into satisfying or implementing that interface to work with that function. This diagram that you're seeing right here, we can kind of generalize into something like this. So we can imagine some like arbitrary interface over here that's going to govern access to some function. And if we want to work with this function, any other object must implement that interface. So we're going to see this exact diagram right here in many other applications we work on. And every single time, it's going to have the exact same meaning. We're going to talk about how we've got some function, and in order to call it, we must have some values that implement the given interface that's acting as the gatekeeper. All right, so at this point, I'm sure this is still a little bit confusing, but like I said earlier, the good news is that the entire course, like every application we put together, is going to be focusing 100% on this mechanic. We're going to be focusing on how to define different interfaces to restrict access to different functions, and then decide how to implement those different interfaces in different objects that we're going to create. So the real code reuse we're going to get here is making essentially this function right here really reusable. As long as a value implements that interface, it can work with this function. All right, so let's take a quick pause right here. We're going to move on to our next topic in the next video. In this section, we're going to start to discuss classes in TypeScript. As usual, we'll get a plain definition, some examples, and then move on to discussing where we're going to actually use classes. This is the last big subject we're going to discuss before we start working on some interesting applications, so let's get to it. All right, so first off, definition. So a class is a blueprint of sorts. We are writing code here, but it's a blueprint or a model of sorts that we're going to use to create an object that has some different fields and methods attached to it. We use these classes to represent different things or objects inside of our application. And whenever I say fields, I'm referring to different values that are going to be attached to an object. And whenever I say methods, we're referring to different functions that will be attached to an object. Now we're going to break covering classes into kind of two separate subjects. We're going to first discuss how classes work with methods or functions, and then come back and add in the idea of fields and values to them. So let's get to it. So I'm going to flip on over to my code editor, and inside of my project directory, I'm going to make a new file called classes.ts. Then inside of here, I want to define a new class that's going to represent a vehicle, very similar to what we did in the last little example we went through. So I'm going to write out a new class definition by using the class keyword, and then the name of the class. We're always going to capitalize the name of a class. Then inside of this class body, we can define different methods. So I might write out a method called drive. I'll annotate it as taking no arguments and maybe a return type of void. And then inside of here, maybe I'll just do a quick console log and say something like chugga chugga. When we create a class, we are creating a blueprint or a definition of what a vehicle should be. We don't actually call the methods attached to this class directly. In some cases we can, but with normal methods we do not. Instead, we're going to use a class to create an instance of a class. To do so, we're going to use the new keyword. So for example, down here we might say const vehicle is new vehicle, like so. Notice the capitalization that we're using here. Traditionally, we're going to name all of our different classes with a capital letter, and then anytime we have an instance of that class, we'll sometimes use the same word, but spell it out with lowercase, like so. So now with this instance of the class, we have access to all the different methods we define inside there. So for example, we could do something like vehicle.drive, like so. Now we've not been running a lot of the different code examples we've put together, but with classes, it's really important to actually execute some code so you get a really good idea of what's going on. So I'm going to very quickly save this file and then flip back over to my terminal to run it. Back inside my project directory, remember we can run some code with ts-node and then the name of the file, in this case classes.ts. And now I can see the console log appear right there. We can attach as many methods as we want to a class. So for example, this class might also have a method called honk. It's not going to return anything. And anytime I call it, maybe we will do a console log of beep, like so. So we can save this file, flip back over once again. Oh, one thing I forgot here, sorry. Down here at the bottom, we want to make sure we also call that method we just added. So we'll do a quick vehicle.honk, like so. Now we'll save the file, flip back over, and then run that file again. And now we can see that beep appear. Now, I'm going to assume if you're in this course, you've probably seen classes before. So I just want to make sure you got a quick reminder of some of the basics around them. So let's take a quick pause right here. When we come back to the next video, we're going to start to discuss how classes in TypeScript are a little bit different than classes in a traditional like ES 2015 JavaScript. So quick pause, and I'll see you in just a minute. In this video, we're going to continue discussing classes in TypeScript by taking a look at the inheritance system. So right underneath my class vehicle, I'm going to get started by creating a second class definition. I'm going to call this thing car, like so. Now I want you to think about the relationship between a car and a vehicle in the real world. I think that we would say that a car is a type of vehicle. And chances are that whatever a car can do, a vehicle should be able to do as well. So for example, a car should be able to drive, and it should probably be able to honk as well. So we would probably want our class car to have essentially all the same methods or functions of class vehicle. To make that happen, we could either copy paste all these methods down here, like so, or alternatively, we could have our class car extend the vehicle class. To do so, I'm going to find class car right here, and then right after I'm going to say extends vehicle, like so. By writing in this little additional syntax right here, we're essentially telling TypeScript that we want it to take all the different methods inside of this class and essentially copy-paste them over to class car. Now, there's not actually a real copy-paste going on here. The actual system is a little bit more complicated, and we're going to go deeper into that system over time. But for right now, we can just imagine that by adding on extends vehicle, we're essentially taking all these methods and copy-pasting them down like so. So now, where we create a new vehicle down here, rather than creating a vehicle, we can delete all that. And instead, let's try creating an instance of a car. So I'm going to say const car is new car, like so. And then on this instance of the class, we can now call all the different methods that we had associated with vehicle. So we can say car.drive and car.honk, like so. Now if I save this file, flip back over to my terminal, and run the file again, we're going to see the same output once again. When we have a class that extends another, we can optionally choose to override different methods. So for example, let's say that we want our car class right here to have a different implementation of drive than the parent class. To do so, we can simply redefine drive inside of car. I'm going to again annotate this with the return type of void, and then maybe inside there for our car, rather than doing a console log of chugga chugga, I instead wanted to do a console log of like vroom, like so. So if we now save this again and flip back over to our terminal, we can rerun the file once more. And no longer are we going to do the chugga chugga, and we'll see vroom instead. So we've successfully overridden a method on the child class. We refer to car as a child class because it is extending vehicle. We would refer to vehicle in this case as the superclass or the parent class. All right, now that we've taken a look at basic inheritance, let's take another quick pause right here. We're going to address a couple more side topics around classes. In the last two videos, we spoke about some basic topics around classes that for the most part are probably going to be at least a little bit familiar if you have covered ES 2015 before. So now we're going to start to discuss some of the differences between ES 2015 classes and classes in TypeScript. So the first thing we're going to cover is the existence of something called modifiers. Modifiers are keywords that we can place on different methods and properties inside of a class. The different options are public, private, and protected. The goal of these different modifiers is to restrict access to different functions or different variables. By default, every different method and property that we add to a class is always going to have the public modifier on it. Now, the reason I say by default is that right now you'll notice that we don't have anything that looks like public, private, or protected inside of our class. So because we did not add anything or any of those modifiers inside of here, it is assumed that these are all currently public. So what does it mean to actually be public? Well, it means that a given method or property, because we can add a modifier on a property as well, but we'll discuss that in a little bit, it means that method can be called anywhere, anytime. It's easiest to understand what public means if we then look first at private and protected. If a method is marked as private, it means that that method can only be called by other methods in the exact same class definition. If a method is marked as protected, it means it can be called by other methods in that class and by other methods in child classes as well. By far, the easiest way to understand all this is to just write out code samples. So let's do that right now. So right now, back inside of my editor, I'm going to add on the public modifier to all three of these different methods you see. So I'm going to say public, public, public. By doing so, I have changed absolutely nothing inside of my code. Again, by default, all these different modifiers are considered to be public. So in general, it's only when we start to add on different modifiers like protected or private that we're going to see any difference. Let's try marking the drive method right here as private to get started. So I'm going to add on the private modifier to that. As soon as I do so, you're going to see an error appear on car.drive. It says property drive is private and only accessible within class car. So that means that we can never call this method from outside of this class. Only methods inside this class can actually call drive. So let's say, for example, that we add a new method to this thing called start driving process. And I'm going to have that with a return type of void. This method right here, because it is inside of class car, can safely call the drive method by referring to this.drive like so. So now down here on car.drive, rather than calling car.drive, we can instead call start driving process. We can safely call start driving process because it does not have the private modifier on it. And start driving process can safely call drive, even though drive is marked as private, because it is inside of the same class. Now you'll notice we've got a little error right here. If you hover over it, we're seeing this error because we have added in a new property, or we've modified a property in class car that is also existing inside of vehicle as well. But in vehicle, our definition up here, drive is marked as public. So the error here is that we've got a child class that has a different modifier than the parent class. If we ever are overriding a method, as we are right here, we cannot change the modifier in the child class. So in this example, if we remove private like so, that error will go away. However, if vehicle did not have that method at all, we are no longer overriding it inside of car, and so now we can successfully add on private like so. Okay, so again, we're going to use private whenever we want to restrict access to a function. Now, here's the really important thing. Like, why do we care about this, right? That's the real important definition. The first thing I want to tell you and make extremely clear is that we do not mark methods as being private over any type of security concern around like being hacked or something like that, or having some malicious user. When you define a method as being private, we are not adding in any layer of application security. The only reason to mark something as private is to restrict the different methods that other developers can call. And the reason we want to do that is if we might have a method that very deeply manipulates a class, and maybe there's some like really complicated special way to use it. And maybe you and I don't trust other developers to call that method safely. If other developers call a given method, they might just inadvertently break something inside of our application. And so if that's the case, if we have some method that we just don't want other developers to call because it's very likely they're going to break something, we will mark it as being private. Okay, so now that we've taken a look at private, let's also discuss what protected does. So protected is just like private. The only difference is that with protected, we can access the given method in child classes as well. So for example, let's go back up to vehicle right here. Rather than saying that honk is going to be public, let's mark it as private really quickly. And then let's say that when we start the driving process, we're not only going to do a drive, but we'll also do a honk. Like so. So when we try to call honk, our class is going to automatically try to call this method. But because this thing is marked as private and is in a parent class, we are not allowed to do so. So honk is only accessible within vehicle. If we still actually really wanted to call honk, even though it's inside of a parent class, we could mark it as protected. So now the child class can access that method, but it cannot be accessed by anywhere outside of that child class. So for example, if we now made an instance of vehicle right here, so const vehicle is new vehicle, we would not be allowed to call honk. If I try to do so, we'll very quickly see an error message once again. Okay, so that's the basics of modifiers. So we've now taken a look at basics of classes, methods, a very tiny bit around inheritance, and modifiers as well. So quick pause right here, and we're going to start to cover fields in the next section. So I'll see you in just a minute. Now that we've seen how methods work inside of classes, we're going to take a look at how we handle data inside them as well. To get started, I'm going to clean up this error right here around vehicle.honk by deleting that line, and I'll do the same thing at the bottom of this file as well. All right, so now back up at the top on vehicle, I want to add in two fields. These are essentially going to be properties or going to reference actual values. Whenever we want to specify a property inside of a class, we'll just write out the name of the property, so maybe color, and then a type annotation for that property. So in our case, maybe color should be a string, like so. Now right now, as soon as you type out this line of code, you might see an error around this line, specifically around color. If you don't see an error and your screen looks like mine, that's totally fine. If you do see an error, it is because traditionally we want to initialize a variable anytime we declare it inside of a class. So right now we have declared the existence of a property or a field attached to class vehicle, but we have not given it an initial value. To do so, right after the class or the property definition, we can write in an equals sign and then some value. In my case, I'll say red like so. So this means that every time we create an instance of class vehicle, the instance will have a color property that is a string, and its starting value will be equal to red. So for example, down here, right underneath const vehicle is new vehicle, we could do a console log of vehicle.color, like so. If we now save this, flip back over to our terminal one more time, and run that file, we'll see a console log of red appear. Now this is just one way to initialize a variable inside of a class. It's also very common to want to initialize a variable using some configuration options that we pass to the class when we create an instance out of it. So for example, it'd be a lot nicer to specify the color right when we create a vehicle, because sometimes a vehicle might have a color of red, other times it might be silver or black or orange or whatever it might be. So to do so, we could pass in the color as an argument to vehicle right here. So maybe I'll do something like orange. If we're going to pass in any arguments to this, we have to define a special function inside of the class definition called the constructor. So I'm going to write out constructor like so. The constructor function is a very special function defined inside of a class. Anytime that we define a constructor, it will be instantly executed right when we create a new instance of the class. So like as soon as we call new vehicle right here, the constructor function is going to run. And the arguments to that function are going to be whatever we pass in when we create the instance. So in this case, it would be a string of orange. So we would probably want to receive that as an argument into the constructor of something like maybe color with an annotation of string like so. And then we'll take that value and do some initial assignment with it inside the constructor. So we would say this.color is equal to color. If we use this method of initializing color by defining the constructor, we do not have to initialize it up here. So it's usually an either or decision. Either you are going to initialize a property on the same line that you define it, or you're going to initialize it inside the constructor, one or the other. In this case, we'll stick with the constructor method. So I'm going to delete the equals red up here. So now if I save this file again, I can run it in my terminal, and I should now see, oh, got a little error here. Let's see, argument for color was not provided, my mistake. Let's see, oh, I know what it is. We created a car down here as well. Let's just comment out all this stuff down here really quickly while we were working on that first class. This actually is a very valuable subject that we're going to have to discuss, like what we do with constructors in extended classes, but let's just hold off on that for right now. So I just commented out everything in the second half of the file. I'm going to save the file and then try to run it again. And there we go. Now I see orange. Perfect. Now, just so you know, there's also a little shortcut to automate this entire process right here. So notice how we kind of have to refer to these repetitive properties multiple times. I see color, color, color all over the place. An equivalent way to write all this out by using a little shortcut would be to delete the implementation inside the constructor, delete the property definition at the top, and then right in front of the color argument, we could add on the word public, like so. Public is one of those modifiers we spoke about. These modifiers can be used not only on methods in a class, but on properties or fields as well. So the syntax you see right here is going to mean that we're going to take whatever comes in as the first argument to that constructor, which in this case is orange, and it will be assigned as an instance variable of color to our vehicle that we are creating. So the code that you see right here is 100% equivalent to this right here. It's just slightly shortened up, so we don't have to refer to the same color, color, color all over the place. So we're going to use this shortcut many times in the code that we write. If we do something like this, we can then shorten up that body of the constructor function as well. Even though it's empty, we still have to put it in. So let's try saving this, flip back over, run the file again, and we will see orange again. All right, now those modifiers we spoke about apply to variables just the same way as they do to methods. So we could alternatively use the private keyword or the private modifier on color. If we do so, we will no longer be able to read that variable outside of our class anymore. Likewise, we could also mark this thing as being protected. We still cannot access it outside the class, but we would be able to access that field from a class that extends vehicle, such as car down here. All right, I'm going to leave that variable as public like so. And I'll save the file. We're going to leave it like this. Let's take a quick pause right here. We're going to come back to the next video and talk about how these fields work when we are using extensions like we are down here. So quick pause, and I'll see you in just a minute. Now that we've got a better idea of how fields work inside of a class, let's discuss how they work when we are dealing with inheritance, as we are with our class car down here. I'm going to uncomment everything in the bottom half of this file right here, and as soon as I do, you'll notice that we get an error around the new car call right here. So here's the issue. Our class car extends vehicle. Anytime we create an instance of something that is a vehicle, we have to provide it a color or a string to use as the color. So the reason we're seeing this error right here is that we have to pass in a string that will serve as the color. So we could fix up this error by putting a string in like red, like so. And as soon as we do that, the error goes away. Now I want to show you something interesting. Right now, our class car does not have a constructor function. That means that whenever we try to create an instance of car, TypeScript is going to automatically call the constructor in the parent function, right here. So even though you don't see any reference to it, whenever we create this car right here, the constructor in the parent is being called for us automatically, and that's why we have to pass in that string. Things are going to be just a little bit different if we define the constructor inside of class car as well. So let's try that right now. I'm going to define the constructor function inside of car, and I'm going to say that this thing is going to have its own property, like let's say public wheels. And this will be maybe like the number of wheels that a car has. So I'm going to annotate with the type of number like so. Now, as soon as I define this constructor, you'll notice a nasty error inside of here. And if I hover over it, it says that the derived class must contain a super call. The word super right here is a reference to the super class, or the parent class of car, which is vehicle. So whenever we call the constructor of a child class, we are required to call the constructor method of the parent as well. To do so, all we have to do is call super, like so. As soon as we do so, we're still going to see an error here. So super right here is a reference to the constructor method in the parent. And once again, the constructor in the parent wants us to pass in a string. So we can make this go away once again by putting in some hard-coded string like so. But chances are we don't want to do that. Chances are we want to have the color still come in as an argument to our car when we create it. So maybe we should take in a second argument to the constructor function that we'll call color, and it's supposed to be a string like so. Notice how I did not put the public keyword on here. I didn't put public on because we do not want to reassign or create a new field in car of color. The field color belongs to vehicle. So that's why I did not put on the modifier of public. So now when we call the parent class constructor through the super call right here, we're not going to pass in a hard-coded red. Instead, we could pass in the color. If we now go back down to the bottom of the file once more, you'll see that we've got an error down here again. So now we are saying that our constructor for car has to be given a number of wheels as the first argument and a second argument of a string. So we can fix up this error by putting in 4 wheels as the first argument. Now the second argument is going to be a string, which is going to pass on through the constructor right here into the parent constructor of vehicle. And that's pretty much it. Now I know we're going through this class stuff really quickly. The reason we're going through it so quickly is that basically all the projects we're going to work on in this course are 100% focused on using classes to represent logic inside of our application. So really, I'm just showing you all this class stuff right now to get you used to some of the very basic syntax. And we're going to really repeat all these different rules that we're going over in great detail throughout all these applications we go through. So hopefully you're just absorbing a little bit of the syntax here. That's really the only expectation I have. Now, having said all that, this is really all we wanted to learn about classes. So we've taken a look at methods, constructors, basic inheritance, super calls, modifiers. That's pretty much it, the whole ballgame. So let's have a quick pause right here. We're going to do a wrap up on classes in the next video, and we'll start working on some really interesting applications. So I'll see you in just a minute. Now that we've seen some basic examples of classes inside of TypeScript, let's have a very quick discussion on why we care about them and where we use them. Well, essentially, why we care about classes and where we're going to use them comes back to the same reason we care about interfaces. Remember, interfaces, which we just spoke about, and classes together are going to be the primary tool that we use inside of TypeScript. Just about everything that you and I are going to do inside this course is going to revolve around classes. So inside of a typical a typical TypeScript application, we're going to use classes very heavily. And in general, we're going to have a collection of different files. Every different file is going to have one single class defined inside of it. And we're going to get these different classes to work together through the use of interfaces. Now, of course, I can tell you all this, but it's not super useful unless we see a good example of it. So we're going to take a pause right here. When we come back in the next section, we're going to start working on our first application. We're going to do a really big focus on helping you understand how we use classes inside of a basic application and how we get some code reuse with them through the use of interfaces. So quick pause, and we'll start on this application in the next video. All right, my friends, many videos ago, I told you that we were going to spend a lot of time learning the basic syntax of TypeScript. We've now gotten through all that basic stuff, and we've got a reasonable understanding of some of the low levels of TypeScript. But I think it's very fair to say that we still don't really understand how to build an application with it. So starting this video, we're going to work on our first application, and throughout the rest of this course, all we're going to focus on is design patterns. We're going to learn how to use TypeScript effectively inside of an application and how to leverage its features to write really reusable code. So let's talk about what we're going to build for our first application. All right, so here it is, mockup. All right, so we're going to make a very basic little web application. So this is going to be something that's going to run inside of your browser. Our application is going to randomly generate 2 different entities. It's going to randomly generate a user and randomly generate a company. Now, when I say randomly generate, all I mean is that we're going to have a user with a randomly generated name and last name and age and stuff like that. And our company will have a random name and a random business and some stuff like that as well. Every user in every company is going to have a location property tied to it as well. So this is going to be like a longitude and latitude. After we generate the user and the company, we're going to use that location to show them as markers on a Google map inside the browser. So this marker right here, I know it's kind of hard to see with these colors, might represent the user, and this over here might represent the company. So the entire goal of this application is to get you more familiar with classes and how to understand how to make use of interfaces really effectively to get some amount of code reuse on the applications you work on. That's the whole goal. And like I said, that's pretty much the whole goal of the entire course, understanding classes and interfaces. All right, so now that we understand what's going on here, we're going to do just a tiny bit of setup inside this video. In order to actually get some TypeScript code running inside the browser very easily, we're going to use a tool called Parcel Bundler. This is a command line tool that we're going to use in place of TS Node. Parcel Bundler is all about getting some TypeScript executed inside the browser very easily. So it's going to automate a lot of tooling for us. We will eventually learn how to set up a TypeScript project manually, but for right now, we're going to start off nice and easy using Parcel. So to set up Parcel, all we have to do is run this command at our terminal. So I'm going to flip over to my terminal right now, and I'll do an npm install -g parcel-bundler, like so. This is going to take a minute or two to install, so I'm going to let it do its thing, and I'll join back up with you in just a minute. Now that we've got Parcel Bundler all set up, we're going to do a little bit of initialization for a new project and figure out how to make use of Parcel. So to get started, I'm going to flip back over to my terminal. You'll notice I'm still in that features directory. So I'm going to go up one folder, back into a workspace directory of sorts. And then inside of here, I'm going to generate a new project folder that I'm going to call Maps. So that's going to be the name of this application, simply Maps. I'm then going to change into that folder and then start up my code editor inside there. All right, so let me tell you exactly how Parcel works. It might be kind of surprising. All right, so we're going to create a single file inside of our project directory to start. The single file is going to be an index.html file. Inside this HTML file, we are going to include a script tag for a file called index.ts. Notice the extension on there is .ts. Remember, we can't have raw TypeScript code running inside the browser. So how does this actually work? Well, we're going to start up that Parcel tool, and we're going to feed the index.html file into it. Parcel is going to see that script tag with a source of index.ts. And as soon as it sees that .ts extension, Parcel is going to say, oh, I see, it is a TypeScript file. I need to parse the code inside there, compile it, and turn it into JavaScript, and then load that into the browser, as opposed to the index.ts file that we requested. So like I said, Parcel is an awesome little tool. It has a lot of magic in it, like this right here, that makes setting up new TypeScript projects really, really easily. So let's get to it. Back inside my editor, I'm going to create a new file called index.html. And then inside of here, we're going to put down some very, very basic HTML. I'm going to put in an HTML tag. I'll put a body inside there. And then inside there, I'll put in a script tag with a source of /src index.ts. And I'll close off that script tag like so. All right, so we are going to create an src directory inside of our root project folder that's going to hold all of our source code. So inside of the maps directory, I'm going to make a new folder called src. And then inside there, we're going to create our index.ts file. So inside of src, I'll make index.ts. And then to get started inside of here, I'll do a quick console log of hi there, like so. Now I'm going to save this file. Okay, so like I said, we're now going to take Parcel at our command line, and we're going to feed in this HTML file. As soon as Parcel sees this src right here, it's going to find our index.ts file. It's going to notice that it is a TypeScript file, and so it's going to convert it into JavaScript for us automatically. After it does that, Parcel is going to automatically update the script tag and change index.ts essentially into index.js for us before we access this HTML document inside of our browser. So let's try that out right now. I'm going to flip back over to my terminal. Inside of my maps directory, I'll run parcel index.html. Now, as soon as I run that, you'll notice very briefly something right there that said installing TypeScript. That means that Parcel saw that we had a script tag that included that .ts file, and it installed a couple dependencies to work with TypeScript for us automatically. Now you'll notice I have a message right here that says my application is at localhost 1234. If you see any error message right now, and you see anything that says like e-adder or error address or something like that, chances are port 1234 on your machine is in use. So you'll want to make sure you don't have anything running on port 1234, because if you do, you will probably see an error message. As a quick aside, if you ever want to stop this running server, you can just hit Control-C, and you can always start it back up very easily by running parcel index.html again. All right, so to test out this application, I'm going to open up my browser and go to localhost 1234. So localhost 1234. Once here, I'm probably going to see a blank page, but if I open up my console, I can see hi there right there. So that's the console log I had put into my src file. So it looks like everything is working as expected. Awesome. One other quick thing you might find interesting, if we go to the Elements tab right here, and then open up Body, you'll notice that our script tag that we had written inside that HTML file did get updated. So rather than referencing a .ts file, Parcel injected this new src tag right here, or the new src property. So that's the JavaScript file that Parcel created for us out of our TypeScript code. All right, so now we've got everything working. Let's take a pause right here, and we'll continue working on our application in the next video. Now that we've got some initial setup of our application complete, we can start to think about writing code for our actual application. So in this video, I want to focus on the overall project structure we're going to use. In general, for all the applications you and I are going to build, we're going to create a collection of different files. Every different file is going to contain one single class, and each of those classes represents one different thing inside of our project. Now, in some cases, I'm going to have you kind of figure out the different schema or the different classes we're going to create, but in this case, we're going to do it together. So when I look at this mockup right here, I really see three different things going on. I see one type of object for our user. So I think we should probably create a single file called user.ts that will hold a user class inside of it. That user class is going to have some methods and properties associated with it that define exactly what it means to be a user. Next up, I see a company thing inside of here as well. So likewise, I think we should create a separate file to house a company class that will also represent what a company is inside of our application. And then finally, the last obvious piece that we have here is the map itself. So I think we should probably create some separate file that's going to hold a class to represent the map, and probably have some methods attached to it to actually get the map to show up on the screen and render some markers on it. So in total, I think we've got three separate classes here. We've got like a map file, a user file, and a company file. Then to actually get all these different classes to work together, we will import them into our root index.ts file. And that's where we're going to actually initialize our project, create a map, create a user, create a company, and have some code to actually show the user and the company on that map. So that's the general idea. So for right now, let's get started on our user.ts. Back inside my code editor, I'm going to find my src folder, and inside there, I'm going to make a new file called user.ts. And one thing I want to point out right away, you'll notice that I called the file index.ts with a lowercase I, but user I labeled with a capital U. So what's with the difference there? Well, by convention, anytime we have a file whose primary purpose is to create and export a class, we're usually going to give it a capital name. So in this case, capital U user, because we're going to create and export a class from this file. However, in index.ts, we're not going to have any classes. We're going to have just some code to import some classes and then use those to actually make something happen. You're going to most commonly see lowercase file names. Anytime you have a file that either serves as something like the index.ts file, so like kind of the root of your application, or a file that exports plain objects, plain functions, or constants. All right, so now we've got the user.ts file. I'm going to get started inside of here by declaring a new class called user like so. And that's where we're going to leave it for right now. So let's take a quick pause with just this inside of here. By the way, if you see any error inside of this file right now when we save this, that's totally fine. We're going to fix it up in just a second. So let's take a quick pause right here, and I'll see you in just a minute. In the last video, we left off having just created class user right here. Once again, if you see a warning around this class definition, that's totally fine. We're going to fix it up in just a second. So in this video, I want to focus on our implementation of a user. Remember, we had said that a user should have a couple of different properties assigned to it. that will be randomly generated. So that should probably be like a user's name and their location as well. To get started, I think that we should define a couple of different fields on our user class. And then we can figure out how to randomly generate those properties. All right, so I'm going to flip back over to my class definition. And inside of here, I'm going to assign two different properties to my user. I'm going to say that every user is going to have a name property that is a string and a location property that's going to be an object that has a latitude, that is a number, and a longitude, that is a number as well. So lat stands for latitude, L and G stands for longitude. Remember, we can use latitudes and longitudes to model a physical location in the world. So we're going to eventually randomly generate a latitude and a longitude, assign it to this user, and use that data to decide where to map a user on our Google Map interface. Okay, so now that we've defined these properties right here, we need to eventually initialize them. Remember, every time we define a property, we need to either initialize it on the same exact line or inside the constructor. Usually we will initialize the property on the same line if it's going to be some hard-coded value. But in this case, we want to randomly generate a name and a latitude and longitude, so we will instead do our initialization inside of a constructor function instead. So I'm going to define my constructor function right here, like so. All right, so we've got our place to initialize the name, latitude, and longitude. All we need now is our randomly generated data. So for that, let's take a look at some documentation for a library that we're going to use to generate that information. All right, so quick link right here. We're going to go to npmjs.com and take a look at the documentation for a package called Faker. The Faker package gives us the ability to randomly generate a bunch of different types of information, which makes it really well suited for the project we are working on right now. So I'm going to go to npmjs.com. Once here, I'm going to search for Faker at the top, and I should see it as one of the first results on here. All right, so here's the documentation. You can scroll down a little bit, and underneath API right here, or excuse me, not API, next section down, here we go, API methods. This is the absolute extent of all the documentation we get. Unfortunately, it's not super detailed. So what this is essentially saying is that the Faker package has a module inside of it called address. And we can use the address module to randomly generate a zip code, a city, a street name, a county, a country, state, latitude, longitude. Well, those look really relevant, and so on. Likewise, there is a company module that we can use to randomly generate a catchphrase or a company name, and so on. If you scroll down a little bit more, you'll also find a section inside of here called name, and we can use this module to generate a first name, last name, and so on. So as you might guess, we're going to use this name module to generate some information for our user. We'll use the company module back up here to generate some random information for the companies we create inside of our app. And finally, for both the user and the company, we'll use the address module to generate a random latitude and longitude. Okay, so it looks like the Faker module is really going to take care of all of our data requirements for our application. So all we have to do is install this thing. So to install this package, I'm going to flip back over to my terminal. Inside of my project directory, I'm going to stop the running parcel server with Control-C, and then I'll do an npm install Faker, like so. And that's pretty much it. Now the package is pretty small, so it should complete installation rather quickly. Once it's all done, we'll start up Parcel once again with parcel index.html. All right, so now we can flip back over to our editor and make use of Faker. To do so, I'm going to go to the top of the file inside my user file, and I'm going to import the Faker module. Import statements inside of TypeScript look identical to import statements in ES 2015. So if you've ever worked on a React or Angular application, you're probably going to be right at home. In other words, to access a module that we install with npm, all we have to do is write out import Faker from Faker, like so. So that's going to reach into our node modules directory right here. It's going to find that Faker module that we just installed, and it's going to give us access to all the code inside there through a variable called Faker. Now there's just one little issue here. If we hover over Faker, we're going to see a little error message right here. It says, could not find a declaration file for module Faker. Now, this is an error or a warning that you're going to see many, many, many times as you start to work on TypeScript projects. So let's take a quick pause right here and talk about why we are seeing this little warning message. In the last video, we installed the Faker module, but we very quickly saw a warning around it. So if I hover over this right here, I see something that says could not find declaration file for module Faker. So let's talk about what that's about. First off, a quick diagram. All right, so just to make sure things are really clear, whenever you and I are writing TypeScript code, we are free to make use of JavaScript, or more precisely, JavaScript libraries as much as we want to. So we can install common JavaScript libraries into any TypeScript project using npm, or we could even reference JavaScript files that you and I write ourselves inside of our project from TypeScript code. But there's one little caveat here. Remember, TypeScript wants to check your code, and it checks your code by the use of types. TypeScript wants to know all the different functions that you have, what different type of arguments they take, and what type of value they return. And in general, it wants to know all the different types of data that are flowing around your application. If TypeScript doesn't have this information, then it cannot completely check your code. So when we start to think about using JavaScript code inside of our project, naturally all JavaScript code we write or make use of is not going to have any type information attached to it. And TypeScript can't really automatically figure out what different types of values are floating around JavaScript code. So to fix this problem, TypeScript has the idea of type definition files. You can think of a type definition file as kind of an adapter between TypeScript code that you and I write and JavaScript libraries that we try to work with. A type definition file is going to tell the TypeScript compiler all the different functions that are available inside this JavaScript library, what type of argument they take, and what type of value those functions return. So once again, you can think of these type definition files as like an adapter layer of sorts. Sometimes type definition files will be installed automatically when you install a JavaScript library. So for example, if you recall that Axios project we worked on at the very start of this course, we never did anything related to type definition files. That's because Axios, by default, includes a type definition file for us. However, right now we are making use of the Faker module, which does not include a type definition file. So we have to install a type definition file manually if it is not included for us. It might sound really challenging to know when a type definition file is included or not included, but basically it's going to be really straightforward. If you ever try to make use of a module and you see that warning we just saw right here, that means you need to install the type declaration file. Once we understand that we need to install that file, it's a really simple process. So here's what's going to happen. All these type definition files are already publicly available for you. I shouldn't say all of them, but the vast majority for popular libraries have already been created. So there is already a type definition file out there that has been created by some random person to work with the Faker library. To install that type definition file, we're going to reach into a project called Definitely Typed. That's the name of the project that includes all these pre-created or pre-generated type definition files. In general, to get any of these type definition files from Definitely Typed, we're always going to install an npm module that generally is going to be named something like @types/ and then the name of the library that we're trying to make use of. So for us, it would be @types/faker. As a quick example, let's try looking up that module on npm right now. So back inside my browser over here at npmjs.com, I can do a search for @types/faker, and I'll see the TypeScript definition file appear for that library. So we can scroll down a little bit, and you'll see some details inside of here where it says very clearly that this file or this project has been generated from the Definitely Typed project. So again, Definitely Typed, anytime you see that term, they're talking about type definition files for JavaScript libraries. All right, so once again, to fix up this whole big issue, all we have to do is install that type definition file for Faker. So I'm going to flip back over to my terminal one more time. I'm going to do an npm install @types/faker. These files are always extremely small because there's just a little bit of code to describe the different types inside that library. So once it is installed, we can then start back up parcel once more with parcel index.html. All right, once that's all done, I can flip back over to my editor, and you'll now notice that that little warning is gone. I still see a warning here saying that Faker is declared, but its value is never read. That's totally fine. more importantly, we got rid of that other error or that other warning around a missing type definition file. Okay, so that's it for type definition files. Again, remember, vast majority of time that you are using a JavaScript project inside of your TypeScript code, you might have to install that type definition file. Some JavaScript libraries include the type definition file by default. Other ones, like less popular libraries in general, are not going to include it automatically, so you will have to install it separately. All right, so let's take a pause right here, and we'll continue in the next video. In the last video, we installed a type definition file for Faker. As a quick side, one of those benefits of type definition files is that we can now hover over Faker right here, and then if you're on Mac, hold down the Command key, or if you're on Windows, hold down Control. You'll notice that Faker turns into a clickable link of sorts. If we now click on that, we'll be taken to the type definition file that we just installed. Notice how the name of this file is index.d.ts. Traditionally, type definition files are named with extensions of d.ts. So anytime you are looking at some TypeScript code and you see a file with that extension, that means you are looking at a type definition file. Inside this file, you're going to find nothing but TypeScript syntax. So the only goal of this file right here is to describe the different types of values, functions, objects, classes that exist inside the Faker library. So there will not actually be any functions that are implemented inside of here. Instead, you will only see a definition of the different types that are available. If you look inside of here, we can actually use this as a source of documentation. So for example, remember at the official documentation we looked at just a moment ago, we saw that address module. So this right here is telling TypeScript that this library has an address object, and inside of it are different functions like zip code, city, city prefix, and so on. We can see the different arguments that each of them take, and the different type of values that they return. So like I said, we can use this file as kind of an alternate forms of documentation to understand how to work with a given library. So in this case, we can take a look at address. If we scroll down, you'll notice that latitude and longitude are two functions inside there. And we're going to use those functions to actually randomly generate our latitude and longitude. As a quick side note, I want you to notice how latitude and longitude return strings, which is actually kind of not very typical. Usually we reflect latitude and longitudes as numbers. So having them being returned here as a string means that might be a little bit unexpected, and we might have to deal with that at some point in time. But we'll just see what happens. All right, so I'm going to close this file. And back inside of my user.ts file, we're now going to do some initialization of our name, latitude, and longitude inside of our constructor. So inside the constructor, as soon as we make an instance of a user, we're going to randomly generate a name and assign it to that name property. So inside of here, I'll say this.name is going to come from Faker. We're going to get the name module. Remember, we saw that in the official documentation. Here's name right here. And then we're going to generate a first name. Once again, we could find the existence of this function either by looking at the official documentation or just command clicking on Faker and then search this thing for like first name. And there it is. So here's the name module. There's the first name method. Even by looking at this documentation right here or this type definition file, you'll notice that we even are told that we can take in a gender argument right here. This actually did not exist in the official documentation. So the type definition file actually gives us more information sometimes than a documentation document actually does. All right, so now we've generated the first name. We can do the same thing for our latitude and longitude as well. Now here's a really quick note for you, something that really gets people hung up when they are getting started with TypeScript. At this point, we have only told TypeScript that our class user is going to be of type or going to have a property called location, and location will have an object with a latitude and longitude property. Here's the important thing. When we create an instance of a user, location does not get automatically set to be an object. So in other words, if we did right here a console log of this.location, we would see undefined or null. That means that if we tried to do direct assignment to latitude and longitude, like this.location.lat equals, some number, we would actually see an error message. And it would say something like, cannot read property lat of undefined. So all we have done up here is said, hey, TypeScript, we're going to have a location property. It will be an object that has these two properties. But we have not done any initialization for that yet. There is no object here when we create our user. So we are responsible for initialization of this object and the properties inside of it. So in other words, that means to initialize latitude and longitude, we have to say this.location is going to be an object with properties lat and lng. So we can try to initialize both lat and lng. We'll do faker.address.latitude. I'll get a comma at the end of that line, and then faker.address.longitude, like so. Even then, I still see an error message. If we mouse over this, you'll notice that it says expected, or right here, type string is not assignable to type number. So remember, when we were looking at the documentation for latitude and longitude, or the type definition file just a second ago, we saw that latitude and longitude were functions that returned strings. But we clearly said that latitude and longitude were going to be numbers. Once again, in my opinion, this is kind of an oversight by the Faker people, and they really should be returning numbers here. However, that's just how they built this library. So we need to take the strings that are returned by latitude and longitude and convert them into numbers. To do so, we have to do an actual conversion process. Like, this is a string right here, so we have to convert that into an actual number. So to do so, we're going to take a very JavaScript style approach. We're going to use the parseFloat function. Just to make sure you are aware, the parseFloat function is built into JavaScript. It takes a string and returns a number that has a decimal value attached to it. So we can call parseFloat on both. And the error goes away because now we are assigning a number to both latitude and longitude. All right, so that's pretty much it. So let's take a quick pause right here. When we come back in the next video, we're going to start to actually make use of our class. So I'll see you in just a minute. Now that we've completed our initial implementation of our user, we can try to actually make use of it inside of our index.ts file. In general, anytime we create a file that houses a single class in TypeScript, we're not going to have any actual code in here that does anything with the class. Instead, we will usually import this class into some other more central location and use it from there. So in order to get access to this class inside of our index.ts file, we first have to export it. So to make the class available somewhere else inside of our project, I'm going to put the export keyword in front of it like so. Then inside of index.ts, at the very top of the file, I'm going to delete that console log really quick. We can write out import, a set of curly braces, and then user from the user file. Now, if you're coming from a background of React.js, chances are the syntax looks really familiar. Once again, we are going to look into the user file. We're going to find something inside there called user and pull it into the index.ts file as a variable called user. Notice how we've got the curly braces on here. I want to have a very quick aside on what those curly braces are doing for us. So anytime that we export something from a file using just the export keyword by itself, we will always receive that in another file by placing that word inside of a set of curly braces. We do this so that we can safely export multiple different variables from this file. So for example, if we had another variable inside of here that we wanted to export, like let's say a variable called red, that was literally just a string red, I can now import this into index.ts by adding it as an additional thing that we want to import from user. Once again, if you're coming from the world of React, this syntax might seem a little bit strange, because in the React world, we typically will export things using the default keyword. The default keyword is available inside of TypeScript as well. If you haven't used the default keyword, totally fine. Let's take a look at how it works really quickly. So right now, we've seen an example of how we can export very specific variables from a given file. However, we can choose to also export something as the default export from a file as well. So I could say export default and then just a single value by itself. So in this case, I did not provide a name for this value I'm trying to export. Previously, I had given it a name of red, which means I could import it into another file as the name red. But this time, it's literally just the string red by itself. So to import this value into another file, I would write out no curly braces and just the name of the thing I want to pull in. So now red would be that string red. This name right here can actually be any variable we want to call it. So I could call it red, or I could call it color, or user color, or whatever we want it to be. If we then did a console log of that, we would see literally just a string red. That's it. In TypeScript, we usually do not use these default statements like the one you see right here. And the reason for that is that when you're first getting started with these modules, like this import statement and this export statement right here, it gets really confusing really quickly when you should use curly braces and when you shouldn't. So convention inside of TypeScript is to never use default export statements. Now, of course, there will be some people out there who disagree and who want to still use default statements. If you work on a project where that is the case and you want to use default statements, totally fine. All I'm saying is that in the TypeScript world, it's a little bit more community convention to not use default exports. And once again, the reason for that is that then we don't have to worry about whether or not we have to include those curly braces. So if I don't have any default exports whatsoever, that means every time I import any code that is mine, I'm always going to put on those curly braces. And so it just makes it really easy for me to remember and avoids simple little typos. Now, of course, that rule does not apply to third-party modules. So NPM modules we use might still have a default export statement, as is the case with Faker right here. And that's totally fine. It is unavoidable. Nonetheless, the rule for us, for code that we write, is that we will avoid default statements if we can. Okay, so that's a lot on default exports and all that kind of good stuff. So last thing, now that we've got the user inside of our index.ts file, let's try to use it to create a new instance of a user. And then just console log out that user, like so. All right, now that I've got that, I'll flip back over to my terminal. I've already got a live reload here, and you'll see that I've got a console log of my user. So they have a name and a location that is an object with a latitude and a longitude property as well. Perfect. All right, so now we've got our user all put together, and we can access them inside of our index.ts file. We're now going to repeat this whole same process for a company as well. So quick pause, and I'll see you in just a minute. Now that we've put our user together, we're going to repeat the same process and create a second file to represent a company inside of our application as well. So to get started, inside of my src directory, I'll make a new file called company.ts. Inside of here, I'm going to once again import the Faker module from Faker, and I'll define a new class and immediately export it called company. So let's think about what different properties we might want a company to have. Well, I think that maybe if we go back over to the documentation for Faker one more time, remember we have that company section. So we've got different properties in here like, say, company name, and we've got catchphrase and some other stuff like that as well. So let's have every company have a company name property that will be a string and a catchphrase property that will be a string as well. In addition, we'll also have a company have a location that will be a latitude and a longitude, and that's going to represent their physical location in the world, so we can eventually represent them as a marker on our map. Okay, so back over here, we'll do a company name that is a string, and then we'll do a catchphrase that is a string. We'll also do a location that is going to be an object with a latitude property that is a number, and a longitude property that is a number as well. Now, one thing I want to mention here is that calling the company name is really not necessary. I think a more ideal property name here would be name, like so, but I just want to give it some differentiation from our user who had a name property as well. So just to make a little bit more stark difference between a company and a user, I'm going to have the company have a property of company name instead. All right, so now once again, we can define our constructor function, which is where we're going to initialize all those different properties. So I'll say this.company name will be faker.company.company name, like so. Let me collapse the sidebar so we can see that whole line. We can then do our catchphrase, which will be faker.company.catchphrase. And then finally, we can also initialize our latitude and longitude as well. Remember, like we just discussed, this right here does not initialize the location property. It just tells TypeScript, here's what location will be. So if we try to assign a value directly to this.location.lat, we'll get an error message because location is undefined inside the constructor. So we have to initialize the location property and everything inside of it. And one easy way to do that is to say this.location is going to be an object with properties lat and lng. So then inside of here, we can once do faker.address.latitude. Make sure you get the comma at the end of the line, and then faker address dot longitude as well. And once again, don't forget the parentheses. All right, we're seeing the same error as before. We are trying to take a string, because that is what we get back from faker, and assign it to a property that is supposed to be a number. So once again, we have to do a parse float and a parse float. And that's it. All right, so I think we're all set here. We already got that export statement. So now we can import this into our index.ts file, create an instance of a company really quickly, and just make sure everything works as expected. So back inside of index.ts, I will import company from company. And then underneath our user, I'll say company is going to be a new company like so. And I'll do a console log of that company. Then as a quick test, I'll flip back over to my browser. My live reload already kicked in, and I can see that console log right here. So I'll expand company, and I'll see that I've got a really great catchphrase, persistent directional function, and my company name is King Group. Once again, really should not be calling that property company name. Just name would be much more appropriate, because we already know that it is a company we're working with. However, once again, we want to just differentiate the company from the user, which had a name property. And once again, I've got a location with a latitude and longitude as well. All right, so that's pretty much it. We've created a class to represent our user and our company. So let's take another quick pause right here. When we come back to the next section, we're going to start working on getting a Google map to display on our screen as well. So I'll see you in just a minute. We've now set up an initial implementation of our user and our company, and we've tested both of them out inside of our index.ts file. Remember, the original goal of our application was to show the location of that user and that company as markers on our map. So in this video, we're going to start putting in support for showing a Google map inside of our application. This is going to be a little bit of, kind of tedious setup, but we'll go through it step by step, and we'll get through it quickly enough. So here's what we need to do. We're going to first go to the Google Developers Console and generate a new Google Developer project. This project is what's going to allow us to get access to the Google Maps API, which is how we're going to actually show a map on the screen. So we're going to first generate that project. We're then going to enable support for Google Maps inside that project. We'll then create an API key, and then use that API key to add in the Google Maps SDK to our HTML file. We're not going to install Google Maps as an NPM module or anything like that. Honestly, it is by far the easiest to include it in a script tag and just use it that way. In addition, doing it that way is going to teach us a little bit more about using global scripts included inside of a TypeScript project, which is just a nice little bonus. Okay, so let's get to it. Step number 1 is going to be to go to this Google Developers Console. As you might guess, you're going to need a Google account to get through this step. I can actually get this link. If you don't have a Google account, you can generate a throwaway account just for this project. There's not going to be any billing or any money or anything like that tied with what we're doing here. Once you go to that address, you're going to either see a welcome screen that's going to ask you to generate a project, or if you've ever created a Google project before, you're going to see a screen a little bit like this one right here. So for what we are doing, I highly recommend you create a new project separate from any one you've done before. You don't have to, so you can reuse an existing project if you want to, but in general, I would recommend you use a new one. To do so, we're going to find the drop down up here on the top left-hand side, click on it, and then find New Project on the top right. Once here, we can create a new project. You can give it a customized name if you wish. I'm not going to do any customization. I'm just going to use the default name. So click on Create. And now once we do that, you'll notice that there's this little spinner on the top right-hand side. When we click on Create, the project is not generated instantly. So I actually got dumped back into the project I was looking at before. We have to wait for that spinner to go away before we can actually access the project we just created. Okay, so it looks like my spinner just finished up. So I can now click on Notifications and then click on the project I just made. So we're now looking at that new project. Now we've got that, we're going to enable Google Maps support inside of it. So by default, Google has a ton of different services that they make available, like tons and tons. And Google Maps is just one of them. So we have to specifically enable Google Maps support inside this project. To do so, I'm going to find the navigation menu on the top left-hand side. I'm going to find APIs and Services, and then click on Library. Then once here, we're going to be looking for a very specific API library. There are many different maps projects or many different maps libraries, like right now, 15 in total. So you're going to see a lot of very similarly named libraries inside of here. We are looking for a very specific one called the Maps API. Oh, 2 words, Maps API. And we're looking for Maps JavaScript API right here. Notice how there are several other similarly named ones, like here's Maps Embed, Maps Static, and so on. We are looking for Maps JavaScript API. So I'm going to find that, I'm going to click on it, and then I'll hit Enable, like so. So that's going to add support for the JavaScript Maps API to our project. Okay, once that's all done, the last thing we're going to do here inside that console is generate an API key, which is really easy to do. So to generate an API key, I'll again go to the navigation menu on the top left-hand side. I'm going to go again to APIs and Services, and then click on Credentials. Once I'm here, I'll then find the Create Credentials button on the very center of the screen. I'll click on that. We get a couple different options here. We want to generate an API key. And there it is. There's our API key. So I'm not going to copy this just yet. I'm going to leave it here for just a moment. We're going to use this API key in just a second, so we'll leave it here on the screen. All right, so here's what we have to do first before we can actually use that API key. We need to add a script tag for the Google Maps SDK to our HTML file. So I'm going to flip on over to my code editor. I'm going to find my index.html file. And then right above the existing script tag, please make sure you put this right above. We're going to add in a new script tag. I'm going to give it an src property. I'm going to put in a set of double quotes in there, and then I'm going to close off the script tag. Okay, so notice how I've got a new script tag with an empty src right above the existing one. So inside of those double quotes right there, we're going to manually type out the address of the SDK that we're looking for. Honestly, it's easiest to just type this out. To actually find the link to it, we would have to do like a lot of searching and whatnot, so easiest to basically just type this out manually. So inside those double quotes, you're going to type exactly this string as you see it. As you type this out, please make sure that you get HTTPS, the colon, and then the 2 slashes. You would not believe the number of people who I hear from who have trouble on projects, and it's all because they make a typo on this first little part right here. So please make sure you get the colon and the 2 forward slashes. Okay, so once you've got this over, so I'm going to copy this myself, and I'm going to put it into those double quotes right there. So I'm going to paste it like so. All right, so now the last thing we need to do, you'll notice at the very end of that link is key equals, and then we got the double quote right after it. We're going to put the API key that we just generated between the equal sign and the double quote sign. So I'm going to go find the API key that I just generated right here. I'm going to copy it. I'm going to flip back over, find key equals right there, and paste the key. And that's it. All right, so we should now be able to save this file, flip back over to our browser, open up our application. We should be able to refresh this page, and then just let it sit on the console for just a moment. If you see anything inside the console that says like API key support not added, or invalid API key, or anything like that appear as a warning or an error inside your console, that means that something went wrong during the initialization. If you see an error that says like 404 not found around that script file, then that means that you probably made a typo on this URL right here, and you'll want to do a double check on it. To make sure that everything works, we can open up the Network tab inside of Chrome Console. We can click on JS right here, and then you should see one of the requests inside of here that says JS key. And then all we're really looking for is trying to see a status of 200 on there. And that's it. Okay, so now we've got Google Maps support added in. Let's take a quick pause right here, and we're going to figure out how to generate a map in the next section. In the last section, we installed Google Maps into our project. As one side note here, just to really make sure everything is set up correctly, you can open up your console inside the browser and just write out Google like so. And you should see an object like that appear. If you don't see that, once again, it means something was not set up correctly. All right, so now we've got everything going, we can start to think about how we're going to add in Google Maps support to our project. So this is kind of an interesting scenario. Usually when we make use of TypeScript, we install dependencies using npm, and we import them with normal import statements like the one you see right here. However, this time around, we have added in a script directly to our HTML file. And so that script is going to be added into our project as a global variable. It means that essentially inside of our console over here, you notice how I just typed out Google by itself? This is a global variable that is available everywhere inside of our project without import statements or anything like that. The only issue is that right now, if we flip back over to our editor and inside of our index.ts file, just write out Google by itself, we'll very quickly see an error message here that says, cannot find any name Google. So the reason we are seeing this is that TypeScript just doesn't understand that there is a global variable available inside of our project. So we need to help TypeScript understand that. We need to help TypeScript understand that there will be a global variable available inside of our project. We need to help it understand the different methods that are available on this Google object. So to do so, we're going to install another type definition file. Remember, we spoke about type definition files just a little bit ago. We installed one for Faker.js. The goal of a type definition file is to help TypeScript understand how a third-party JavaScript library works. We can use these type definition files not only for npm modules, but also for script tags added in directly to our HTML file as well. So let's take a look at the documentation for the type definition file we're going to add. Once again, I'm going to go to npmjs.com. And the only reason I really want to pull up the documentation here is so you can see the name of the package. Remember, the general goal that we use, or the general name that we use to get a type definition file, is @types/ and then the name of the library we are using. So in this case, the technical name, or as it was added to the definitely typed project, was Google Maps, like so. That's what we are really looking for. And so you'll see right here, type definition files for Google Maps JavaScript API, which is exactly what we are using. So we can take a look at the documentation. It's not really going to tell us a whole bunch besides the fact that, yep, this thing exists, and you can use it to have TypeScript understand what is going on inside that library. So let's install this type definition file. This is going to tell TypeScript that there is a global variable called Google and all the different properties and functions that it has. So back inside my terminal, I'll do an npm install @types/Google Maps. Once I've got that added in, I can then flip back over to my editor. And then once again, inside of my index.ts file, I'm going to write out Google like so. And now when I do that, I don't get any error message. In fact, I can actually hover over this. It's going to say something called a namespace, which we're going to learn about later on inside this course. Remember, anytime that we want to inspect a third-party library, or even something that we wrote out as well, just to be technical, we can hold down that command key or control key and then click on that thing like so. So here's the type definition file for the Google Maps JavaScript SDK. Once again, we can use this type definition file to get a better idea of how to work with this library. We can pull up the documentation, or we can just try to read this stuff and figure out what is going on. All right, so now that we've got access to Google Maps like 100% for real this time inside of our project, let's take a quick pause right here and continue in the next video. We're going to finally get a map to appear on the screen. Now that we've got our type definition file loaded up, TypeScript understands what is going on with this Google library. This first line of code right here is telling TypeScript that there's going to be a global variable called Google. On that variable, there's going to be a property called Maps. And on that property is going to be a bunch of different other properties that are listed out inside this file. To see everything that exists on this Maps property, we can hit Command-Shift-P or Control-Shift-P if you're on Windows. This is going to pull open the Visual Studio Code command palette. And then inside of here, we're going to search for Fold Level 2. I'm going to select that like so. So all that does is kind of condense some of these different sections of code. So now we can see all the different properties that this Maps object has. So the Maps object has a map property. And as you might guess, we can use this class right here to create a new map and show it on the screen. We can also see that this Maps object has many other properties like padding, map options, map type ID, gesture handling options, and you can basically just scroll down the list, and this will give you an overview of everything that's available inside this library. Here's another one that's probably going to be relevant for us, something called marker. Remember, we eventually want to show a marker on this map, so we might eventually have to take a look at this thing right here to understand how to create a marker. Now, the reason I want you to look through this is because I want you over time to get in the habit of reading these type definition files to understand how a library works. At the end of the day, sure, you can go and take a look at documentation on Stack Overflow on how to create a map. You definitely can do that, but to really grow as a developer, take a look at these type definition files. They tell you, to some degree, everything you need to know about how to work with the library. Sometimes, like in this case, there's a lot of stuff going on inside this file, and so it would be a little bit of a stretch to only use this thing to understand how to create a map and show it on the screen, but nonetheless, I want you to kind of get in the habit of reading these type definition files. Okay, so anyways, the point here is that this very first thing right here that gets exported, it means that we've got the Google Maps global object, which has a maps property, which has a map property. And that map property, capital M map, is a class. We can create an instance of this class right here to show a map on the screen. So let's expand this section right here and get a better understanding of how this class works. So whenever we create an instance of map, we're going to, remember, automatically call the constructor function. And we are told right here what arguments this constructor function requires. So I don't really know, necessarily a lot about what's going on here, but you can kind of read this. So take a look at it. It says map div, and that must be of type element. If you hover over element, you'll get a little note here. Just as a quick hint, an element is an HTML element. So by looking at just this constructor and using these hints right here, here's what you might arrive at if you had like a reasonable amount of experience with Google Maps. What this is essentially telling us is that we can create an instance of a map. When we do so, we have to pass in a reference to an HTML element. And, just based on my experience of working with maps, that HTML element is probably going to be where our Google map is going to be rendered inside of our HTML document. So I know that was like a real big stretch in thinking, and it'd be kind of hard to connect those dots. But once again, I just want you to get in the habit of trying to read these things and understand what's going on. This is like half the power of TypeScript right here, reading these different types and using some little hints inside of here to understand how these libraries work. Okay, having said that, let's give this a shot. So I'm going to go back over to my index.ts file. Back over here, I'm going to clean up all that user and company stuff and comment out the two import statements. Let's just focus on a map for right now. So like I just mentioned, Google is a reference to the global variable. If we put a dot here, we get a reminder that it has a maps property. And if we put another dot, we can see a list of all the different properties that belong to that maps object. That's that big list of all those folded things that we were just looking at. So one of the things inside there is the map class, right? We were just looking at that. So we want to create an instance of a map class. To create an instance of something, we put the new keyword in front of it, and then we call it like so. As soon as we write that out, we're going to get an error. So it tells us very directly we were expected to call this map class, or try to create an instance of it with 1 to 2 arguments. So we were expected to pass in that map div thing. Remember, we are just looking at that inside the type definition file. And like I said, this map div argument is supposed to be a reference to an HTML element of where we want to place our map. So we need to first create an HTML element to house the map and then pass a reference to it as the first argument. So I'm going to open up my index.html file. Over here, right above my script tag, I'm going to create a div to function as the essentially root or container for the map. So I'm going to make a div with an ID of map. I'm going to give it a style tag or a style property with a height of 100%. Notice how height has a colon right after it, 100%, and then semicolon. And I'm going to close that div off like so. So now we're going to get a reference to this div right here and pass it as the first argument into that constructor. So I'm going to save the HTML file. I'm going to close it. And then to get a reference to that element, I'm going to use a document selector. So I'll say document dot, oh, what is it? My mind is totally blanking here. Get element by ID. Yeah. Sorry, sometimes the basics elude me, right? Get element by ID, because we just gave that thing an ID. So the ID of that div we just created was map like so. So notice the autocomplete that we get right here for the get element by ID function. When we call that, we get back an HTML element. It's not quite the element type that that map constructor was looking for, right? It was saying I want an element, but it seems like it's close enough. We're going to learn a little bit more about how one type can function as another type in a little bit, but for right now, as soon as we add that code in, it looks like everything worked. All right, now before we actually test this out, I want to look at the map type definition file again. So here's the constructor once again. We passed in an HTML element as the first argument. Now you'll notice that there is a second argument list on here as well. Notice how the second argument has a question mark right after that. So whenever you see a question mark like that, it means that this is an optional argument. We don't have to pass it in, but if we can, if we want to. You'll notice that the type of this second argument is supposed to be map options. So let's take a look at what map options is. Notice how map options is an interface. And remember, an interface is kind of like a description of an object and the different properties it will have. So if we look at map options right here and look at the interface, it might tell us about the different options that we can pass in to customize this map when it is created. So I'm going to again hold down Command and click on map options. And I'm taken to the definition for map options right here. I'm going to expand this section. And now we can take a look at all the different properties we can pass in to customize how the map looks. Well, this is pretty awesome. So we can scroll through here and notice how this time there are nice little comments to tell us exactly how to customize the map. So all the things that you see inside of here, these are all possible properties that we could pass in as the second argument to this map constructor, like right here. We can take all these different properties we see right here and list them in right here inside this second object. So for you and I, we are concerned with two very specific options. The very first one that we want to pass in is something called zoom. So I'm going to scroll down a little bit inside this map options interface. And I'm going to look for one property inside of here called zoom right here. So notice how it says zoom in the question mark. Remember, that question mark means that this is an optional property. We don't have to include it if we don't want to. But for you and I, we do. So this says the initial map level zoom. Now, kind of misleading. It says right here that it is required, even though it was marked as optional. So that's kind of like, I don't know what's going on there. They're saying it's required, so yeah, we are going to pass it in ourselves. And then it gives us some information about what different valid values we can pass in for it. So for us, valid values are numbers between 0 and up to the maximum zoom level. So we're going to use a starting zoom level of 1, which is like pretty darn zoomed out. So back inside of index.ts, here's the second object. Remember, this is the options object. That's the interface definition we are looking at right now. And I'm going to put in zoom is 1. Notice how as soon as I started typing that, I got some autocomplete on zoom right here. We're seeing that autocomplete because TypeScript knows that the second argument to this constructor is supposed to be an object that satisfies that interface we are just looking at. So TypeScript's going to look at that interface's definition and know that it can have a property called zoom. And that's why we are seeing it on the autocomplete right there. So I'm going to add in that property and give it a value of 1 like so. Okay, one other property we're going to add in. Again, it is one of the different options we can pass in under this map options interface. So here's map options again. I'm going to scroll down just a little bit more, and we're looking for center right here. Again, notice how even though it has a question mark right here, which means that it is technically an optional property, they still say in their comment right here, required. So kind of misleading right there, but I guess they're just doing their thing. So this is saying that our map options object can have a center property, and if it does, it must satisfy the type of being latitude, longitude, or lat, longitude, literal. So in our case, we're going to go for lat, longitude, literal. I'm just going to give you that little hint. So now to figure out how to provide a center property that satisfies this interface right here, we can again do a command click on that. And it's going to tell us how we can be considered to be a latitude, longitude, literal. So to be a latitude, longitude, literal, we have to pass in an object that has a latitude, that's a number, and a longitude, that's a number. So that means that back here inside of our map options object, we can add in another property of center. Notice how as soon as I start typing that, I see the autocomplete. That's coming from the interface definition we were just looking at. And if I put on a colon, or if I just hover over center, it tells me that the center property is supposed to be an instance of latitude, longitude, or that latitude, longitude, literal thing that we were just looking at. And that's what we're going to try to provide. So that means that we're going to pass in an object here that has that lat property. We're going to use a value of 0 and a longitude of 0 as well. So that means that the center of our map is going to be at 0, 0. Okay, I know that this entire process was like really far, very much in depth, but again, my only intent here is to just start kind of forcibly exposing you to these type definition files. Because you can do that command click and look through all these different types and use them as hints to understand how to work with the library. You don't have to look at the documentation all the time when you are working with TypeScript. I apologize again for this video being so long, but I just wanted you to look through an entire example with Google Maps of how I personally would go through that process. I also know that some of the things I showed you in here was probably like, a little bit of a jump. Like we haven't quite seen this syntax before right here. So I know some of that was a little bit rough, but again, just wanted to expose you to it at least one time. Okay, having said all that, we've now got our options object put together right here. So I'm now going to save this file. I'm going to flip back over to my browser, and lo and behold, we see our map. All right, you'll notice that the map is technically centered on 0, 0. That's like right there, latitude and longitude. I know that you can kind of see North America, South America duplicated, and Asia, of course, as well, but this is going to work for our application. All right, so let's take a quick pause right here. We're going to come back in the next video. We're going to start to think about how we can show our user in our company as markers on this map. So quick pause, and I'll see you in just a minute. We can now show a Google map on the screen, which is great, but before we move on and start showing any markers, there's one last little thing I want to mention. So I want to focus on the index.ts file right now. I want to point out something inside of here. This is going to seem like a really strange thing to point out. Nonetheless, I just want to mention it. Let's just take a look at a diagram, and I think you'll start to understand what I'm going to be talking about here. Okay, so quick diagram. All right, so this is kind of a crazy diagram. Its purpose is to try to show all the different things that we can effectively do inside the index.ts file. And I know that's weird to say, but let's just kind of walk through the diagram step by step. So I'm going to zoom in a little bit here and go up to the top. So inside of our index.ts file, we've got an import statement for our company class. Now we currently have that commented out, but we could very easily uncomment it. With our company class, we have two things that we can effectively do with it. We can use it to create a new instance of a company. And then with that instance of a company, we can reference its company name, catchphrase, latitude, longitude. Likewise, we've got the user class as well. It's currently commented out, but whatever, we can easily uncomment it. With the user class, we can create a new instance of it, or then reference that instance's name, latitude, and longitude. So I'm just trying to describe like the total surface area of what we can do inside that index.ts file right now. And so that's basically what we can do with the company and the user. Now, there technically are other methods available to us, like, the name property is a string that has like a 2 uppercase method and so on. I'm just trying to write out or diagram out all the different things that we've added into our application that's specific to our application. So in other words, the surface area of the company and the user classes is quite small. Let's now start to think about that map we just created, however. I'm going to zoom back out just a little bit. So in the last video, we created that Google map, right? So we said right here, we said new Google Maps.maps.map. This creates an instance of a map right here. We could technically assign the result of that to a variable, like so. And then down here, we could write out map and try to call a bunch of different methods attached to that Google map we created. So if I put in a dot right there, I'll see all the different methods that are attached to a map. So I see add listener, bind to, change, fit bounds, get bounds, all those different things. Those are all different methods we actually saw inside the type definition file. So another way of seeing all those different methods would, once again, be to command click on map right there, and you'll see all those same functions listed out right here. These are all functions that belong to that instance of a map. And so those are what these boxes all represent inside this diagram right here. So we've got methods like set zoom, set center, set street view, and so on. So why is this relevant? Well, this is going to seem like a weird thing, but I just want to point it out. These are all methods that we have exposed inside of our index.ts file. So if another engineer started to come into our project, they could look at that map variable and say, oh, hey, look at these cool methods attached to the map. You know what? I feel like just starting to call them. So another engineer might come into our project, start calling the methods associated with that map, and very easily break our application. I know that sounds strange. I know that's weird. Like, That's the job of Google Maps, right? Google Maps is here to expose all these different methods. My only point is that you and I, as the sole developers of this application, have not vetted these methods. We haven't sat down and said, oh yeah, if you call these things, our application is going to continue to work perfectly. We didn't do that. So in theory, if someone started to call these methods, it might horribly break our application. Again, I know this sounds like a stretch, but let me just make a suggestion. Maybe if we found out a way to limit other engineers' access to these methods right here, maybe that would just slightly decrease the chances of our application breaking horribly. So here's what I'm going to suggest. Maybe we start to firm up or limit the number of things we can do inside the index.ts file. Maybe we say the only things you can do inside of this file is create a new company, reference its properties, create a new user, reference its properties. And then maybe we should create a new class called map, like our own custom map class. And this custom map class can be used to create a new instance of a Google map. So this right here, we'll create a new instance of map to be precise. And during that process, we can create a new instance of a Google map. And also on that map class, we can add a method called add marker. And we'll use that function right there to achieve our original goal of this application of showing a marker for user and company on the actual map. So again, this class right here, you and I are going to create. This is maybe a better name for it would be custom map like so. So then wrapped up inside this class, we will have some logic to create a Google map. And the important thing here is that that Google map and all of its associated dangerous functions and methods right here will not be easily exposed inside of our index.ts file. And so if another engineer came into our project, they can't just open up that index.ts file and start calling random methods on the Google map. Instead, we've hidden all those methods. We've wrapped them all up and taken them away from engineers and hidden them behind this facade of sorts, or this kind of black box of custom map. And the only thing you can do with custom map is create a new map and add a marker to it. Again, I know this sounds like a stretch, but the whole idea here is that if we have a program where these are the only things you can do, chances are it's going to be way more challenging for people to come into our app and start to break things. All right, so let's take a quick pause right here. When we come back to the next video, we're going to start to extract this logic to create a Google map right here into a new class. And once again, this logic to create a Google map is going to wrap up all of that stuff, or excuse me, our new class is going to wrap up the Google map and try to hide its existence from other engineers so they can't accidentally break our application. All right, so quick pause right here. Take care of that in the next video. In the last video, we spoke about how it would be really nice to somehow hide the existence of the Google map from other engineers. So to do so, we're going to create a class called custom map. This custom map is going to internally create a Google map for us, but it's going to hide that from other engineers. Because remember, we don't want other engineers to access the Google map directly. So by creating this custom map class, it's going to allow us to kind of isolate the Google map and only expose a bare minimum amount of functionality. So in total, at the end of the day, the only thing we can do inside of our index.ts file is create a company, reference its properties, create a user, reference its properties, create a map, and then add a marker to it. That's it. And so it's going to make our application as absolute bare bones simple as possible to work with. So let's get to it. All right, so I'm going to flip back over to my editor. And I'm going to create a new file inside my src directory called custommap.ts. I would love to call this thing just map rather than putting on the word custom, but I just want to make sure it's really clear to you that the class we are creating is separate from the Google Map instance, so I'm going to call it custom map instead. All right, so then inside of here, we're going to create a class called custom map, and we're going to export it right away so we can use it in other files inside of our project. So now this thing is going to have one single property tied to it. Our custom map is going to carry a reference to the Google map that we create. Because remember, we want the custom map to be able to work with the Google map. No problem there. The custom map can access the Google map and call different methods on it. The whole goal here is that we want to hide the existence of the Google map from other engineers. I know at the end of the day, other engineers could open up this file and start changing how this thing works with the Google map or call different methods on the Google map. I know that is a possibility. But the idea here is that we're just going to pretend that other engineers cannot open up this class definition. I know that seems like kind of an arbitrary thing to say. Nonetheless, it's how we approach this problem. We're just pretending that other engineers cannot see the contents of this class. So custom map is going to carry a reference to the Google map that we are going to create. So I'm going to define a property on here called Google Map, and we need to annotate its type. Remember that we saw that when we created a Google map, we referenced google.maps.map. So that's going to be the type of this variable right here. It's going to be an instance of the class Google Maps.map. This right here is a class. We are saying that Google Map is going to be an instance of that class. So now we can define our constructor function. And we're going to use the constructor function to initialize and create this map and show it on the screen. So I'm going to say this dot Google Map is going to be a map that we create right here. So rather than retyping all the code to create a new map, I'm just going to copy paste it from back inside of our index.ts file. So I'm going to take everything from new all the way down to the bottom. I'm going to cut that all. I'm going to delete the declaration for const map right there because we don't need that anymore. And then I'm going to paste all that stuff I just cut right there like so. I'm going to zoom out just so you can see that entire line very easily. All right, so one last thing here. Remember, anytime we define a property inside of a class, by default, it has a modifier of public. We don't have to specifically write out public. That is the default modifier. So I only write it here just to remind you about its existence. When a property has a public modifier, that means anyone outside of this class can directly access this property and try to reference different properties on it or try to call different functions attached to it. And the whole goal of what you and I are trying to do right now is limit access to the Google map. We don't want other engineers to access this thing. So we're going to put a modifier on it of private. Remember what that means. That means that we cannot reference this property from outside of this class. And so that's going to give us our original goal. Remember, we don't want anyone else to access the map we create inside of here. So we mark that property as private. That means anyone else who is using this class cannot reach into an instance and try to get a handle on the Google map. All right, so that's just about it. I'm going to save this file. And then we're going to try to create an instance of custom map back inside of our index.ts. So inside of index.ts, I'm going to import the custom map that we just created. I'll then create a new custom map like so. Before I save this, I'm going to try to assign this to a variable. I'm going to say like custom map is a new custom map. And then remember, we just marked that Google Map property is private. So if I try to reference that property, like so, I'm going to very quickly get an error message that tells me that property is private and I can't reach into it. And so this achieves our original goal. It means that right now, the only thing that we can do inside of our index.ts file is create the company, reference its properties, create the user, reference its properties, and then create a map. We don't have the add marker function yet. We're going to add that in a little bit, but it doesn't exist yet. So here is everything we can do inside of our program right now. We completely eliminated that API surface of the Google Map, which significantly decreases the complexity of our application. And it makes it way more clear to other engineers what we can do inside of our program. All right, so let's save this thing. Oh, I'm going to delete that line right there. I'm also going to delete the reference to custom map. All we want to do right now is create a map itself. I'm going to save this file and we'll do a quick test inside of our browser. So I'm going to save that, flip back over, refresh the page, and I can still see the map. Awesome. Okay, so this is a very good improvement. We now have a significantly less complex index.ts file. But before we move on, one last very quick thing. Back inside of custom map.ts, I'm going to zoom out here really quickly. Remember, right here when we create our Google map, we have to pass in a reference to a HTML element. And right now, we are always going to pass in some element that has an ID of map. In order to make this class just a little bit more reusable, I think it would be really nice if we had an argument to our constructor that described what element we wanted to render the map into. So we could either take a reference to the entire element, or to make things just a little bit easier for us, maybe we just make the ID an argument to the constructor. So rather than always saying we're going to try to put the map into an ID or an element with an ID of map, we're going to instead pass in the ID as an argument to the constructor. Again, we're just doing this so we can more easily reuse this class on future projects. So to do that, I'm going to say that the constructor function, let me zoom back in here, has to be called with some argument that we'll call, I want to just call it ID, but let's try to be a little bit more descriptive. Let's say like div ID or something like that. So like the ID of some div, and that has to be a string. So then when we call getElementById, rather than using the hard-coded map, we'll instead use that argument, div ID, like so. All right, now back inside of index.ts, back over here, we had a call to custom map. If we hover over it, we'll see that we now have an error here because we are now expected to pass in one argument, but we're not passing in any right now. So now anytime we create an instance of our map, we have to pass in the ID of the element we want to render this thing into. So all we got to do is put in map like so. Likewise, if we had other divs inside of our HTML document, we can create another instance and put in like the ID of that other div or whatever we want to do. Okay, so just that one custom map right there. I'm going to save this, flip back over one more time, refresh the page, and we're good to go. Perfect. All right, so quick pause right here. We're going to move on to the next part of this application, the next section, which is going to focus on getting some markers on the screen using our company and our user. So quick pause, and I'll see you in just a minute. Now that we've got a custom map class put together, we're going to start thinking about adding in some methods to it to add a marker to the screen. Remember, the entire original goal of this application was to take the randomly generated user and company and add them as markers. So we're going to start to focus on adding those markers. Before we write any code, I just have one quick aside here. We're going to first write out a bad implementation for adding markers onto the map. So we're going to write out bad code first. Once we write out the bad code, we'll then discuss why it is bad, and we'll start to refactor it into a much better approach by using interfaces. So I want you to see the bad code because I think that the kind of bad style that we're going to look at is something that you might decide to do on your own. I'm not saying that you write bad code, I just want to help you understand what might be a bad approach and a way to improve it. As we go through this, I'm going to be very clear in telling you where the bad code is and how we're going to fix it, so you will know what is bad and what is good. Anyways, let's get to it. So I'm going to flip on over to my code editor once more. I'm inside of my custom map file right here. So I want to add one or two methods to this class to add in a marker. I think that maybe a good way to do this, hint, this is not a good way, this is where the bad code starts, would be to add in two separate methods. Maybe one method will take in a user as an argument and add a marker to the map. And then the other one can take in maybe a company as an argument and add a marker to the map. So I'm going to make one method in here called add user marker, and a second one called add company marker. Now for both these methods, we're going to take in a user and a company. So we need to annotate those arguments on these methods. To annotate the argument as being an instance of a user and an instance of a company, we have to import those types into this file. So up at the top, I'm going to add in an import statement for user, from user, and company from company, like so. Now, one thing that we've kind of been skirting and not really discussing in great detail is exactly what we get when we create a class. Remember, user and company, we created them as classes. In TypeScript, classes kind of have like a dual nature. When we make a class, we can use it to create an instance of an object. But we can also use a class or a variable that refers to a class, which is what user and company are, to refer to that type as well. So user and company can be used to create an instance of a user or refer to the user type, one or the other. There are several other things in TypeScript that kind of have this dual nature of simultaneously being a value and a type at the same time. And we're going to have a bigger discussion on this later on. I just wanted to mention this really quickly. So now back down in those two methods, we can say that add user marker is going to receive an argument called user, and it should be of the user type. Now I don't think we're going to return anything here, so I'll put on a return type of void. And then we'll do something similar for company as well. Okay, so once again, kind of just like a side tip here or a side note, this approach right here, creating two separate methods to add the marker, this is essentially the bad code. So we would not generally want to do this, but we'll discuss why in just a little bit. So now inside of add user marker, we can start to think about how we can add a marker on the screen. Once again, I want to walk through the type definition file for Google Maps and try to understand how to add a marker by just looking at the type definition file. Again, you can go look at Stack Overflow to figure out how to do this stuff, but I just want you to get in the habit of trying to look at a type definition file to understand how to work with the library. So to pull up the type definition file for Google Maps, I can go back up to like google.maps.map right here and do a command click on map, like so. And that will pull up the Google Maps type definition file. Then in here, I'm going to do a search for marker. And I'm going to look for a class called marker under the section called overlays. So this class right here is how we create a marker and show it on the screen. We're going to create an instance of a marker. So we need to figure out how to create a marker properly and pass it some configuration options that it's going to get a marker to display in the correct position. So to figure out how to do that, we can take a look at the constructor function. So here's the constructor. It tells us that whenever we create an instance of a marker, we can optionally pass in some options. And that options object should conform to the marker options interface. So in other words, when we create a marker, we can customize it by passing in an object that has the properties specified by this interface right here. So I'm going to command click again on interface marker options. And this is going to tell us the possible options we can pass into the marker. You'll notice that these options are once again nicely commented, so we can scroll through and read all the different ways that we can somehow customize this marker. There are two properties in particular that we're going to take a look at. So I'm going to scroll down a little bit, and I'm going to find one option called map right here. When we create a marker, we can pass in that options object, and it can have a map property that will be a reference to the map that we want to show the marker on. So in a normal Google Maps application, or I should say like on any web page, you can potentially have multiple different maps. So like, maybe 5 maps tiled about the screen or something like that. If we create a marker, we have to specify which map we want to add the marker to. So the idea here is when we create the marker, we're going to pass in an options object that has a map property, and that map property is going to refer to the map that we want to add the marker to. That's it. Now the other option that we're going to take a look at is a couple more properties down right here. So the other property we care about is the position property, and this is going to specify where the marker shows up on the map itself. And you'll notice we can either pass in an instance of latitude longitude class or a latitude longitude literal, which is just a plain object that has a latitude that is a number and a longitude that is a number. So once again, we've now taken a look at a type definition file and kind of figured out how to create a marker by just looking at this stuff without having to go and look at some complicated documentation or anything like that. So let's try to now create a marker using this information. Back inside of custom map, I'm going to find add user marker. So I'm going to create a new google.maps.marker. So that's going to be the instance of the marker. This is us calling constructor function right here. And so that's where we can optionally pass in some marker options object. So I'm going to pass in an object, and I'm going to give it that map property, which is going to refer to the map that we want to show this marker on. So the map we want to show this marker on is going to be the Google map that we created and assigned as a field to our custom map class. So map is going to be this dot Google map. And then remember, the second property we care about is the position property. So I want to specify the position for this marker as well. We can hover over position right here, and it will tell us that this property has to be either a latitude longitude instance or a latitude longitude literal. And remember that literal would be an object that has the lat and long properties. So this will be an object, and we're going to get the latitude from our user because that's where our location is coming from. So we can do user.location.lat. And then we'll also do our longitude, which will be user.location.lng. And that's pretty much it. All right, so let's save this. We don't have any implementation for add company marker just yet, but I just want to make sure that we can actually get a marker to display. So I'm going to save the file. I'm going to flip back over to index.ts. I'm going to uncomment the user import statement up here so we can create an instance of a user and then add it to our map. So I'll say const user is new user. I'll then make sure that I assign the custom map to a variable. So I'll say custom map is going to be that custom map we created. And then we can do custom map dot add user marker and pass in the user. All right, so let's save this. I'm going to flip back over to my browser, and I can see a marker displayed. Now remember, we are randomly generating the latitude and longitude for the user, so every time you refresh, you're going to see the marker in a different location. Sometimes the marker might not actually be visible and kind of like off the screen. That means that we just generated a latitude or longitude that is not like in the limits of typical Google Maps. That's probably not going to happen too often. I just want to mention that if you sometimes refresh and you don't see the marker, chances are everything is working correctly. We just have a bad latitude. All right, so that looks pretty good. So let's take a quick pause right here and start to implement our add company marker method in the next video. In this video, we're going to continue by implementing our add company marker method. So I'm still inside my custom map class. I'm down here at the bottom. I'm going to expand the method definition. And we're going to create another marker inside of here. Now, as you might guess, the marker code is going to look awfully similar to what we just did. The only difference is that we're now pulling the latitude and longitude off of an instance of a company as opposed to a user. So I'm going to add in new google.maps.marker, capital M marker. We're going to give this thing an options object. It's going to have a map property that is a reference to the map that we want to add the marker to, which will be this .google map. And we'll also have that position property that's going to have a latitude coming from our company. So that would be company.location.lat, and a longitude coming from company.location.lng, like so. All right, so I'm going to save this. And right away, you're going to notice that these two methods right here look awfully darn similar, don't they? Huh, that's kind of funny. Well, before we start to obsess over that too much, let's make sure we can actually show a marker for a company. So I'm going to go back over to index.ts. I'm going to uncomment our import for company. Right underneath my user, I'll create a company. And we can use that company and add it as a marker. So custom map.add company marker. And I'll pass in my company like so. So let's save this. Flip back over to the browser again and just make sure we can see our marker. Yep, sure can. All right, so we got both our markers to display. But like I said, well, our custom map file or our class doesn't have the best format right now. So this right here, this ends the bad code we've written. Okay, so from here on out, we're going to discuss how to fix the bad code we have inside of here. First off, let's make sure it's really clear what is bad about this. So the very bad thing here is that we've got two different methods that very clearly have, a ton of duplication between them. The only difference is that in this case, we are accepting a user, and in this case, we are accepting a company. Now, it sure would be great if we could just take in like one method and say, hey, as long as you are passing in something that has like a latitude and longitude, everything is going to work out just fine. And that's exactly what we want to do. We're going to take these two methods and figure out how to condense them down to just one. So let's take a quick pause right here. We're going to come back to the next video and take a look at a couple diagrams to understand how we're going to do this by using interfaces and what the implication of it is. So quick break, and I'll see you in just a minute. In this video, we're going to try to condense down our add user marker method and add company marker into one single method instead. So we're going to first try one approach that is going to look like it's going to work out pretty well, but it's going to have a distinct downside. We'll then finally refactor into the final good approach that we're going to stick with for this application and just about all the future applications we work on as well. So to get started, I'm going to find add company marker right here, and I'm just going to comment out the entire thing. We're going to eventually delete this, but I want to just leave the code around for right now, just so we can refer back to it if we need to refer to any of the code inside there. So now I'm going to focus on add user marker instead. To make this method a little bit more generic and indicate that it will work for both a company and a user, I'm going to first change the name to be only add marker like so. So here's approach number one to solving our problem. I'm going to change the argument type right here to say that we can pass in an instance of a user or a company. Remember, that is what that little pipe operator means. And again, that is the character right above the enter key on your keyboard. You'll probably have to hit shift and then like backslash to get that thing. Now we might want to update the argument name as well really quickly. So I'm going to change the argument name to something like mappable to indicate that this is something that can be mapped or like placed on the map as a marker. And maybe that argument name doesn't make a lot of sense, but I think it'll work out for now. Okay, so let's talk about exactly what this OR operator does right here. We said previously, we took a quick glance at this and we just said this means OR. Mappable can be, or this argument can be either an instance of a user or a company. But what does that really do? So quick diagram back over here. All right, so in this diagram, we've got an instance of a company and an instance of a user. And then I listed out all the different properties that a company has and all the different properties that a user has, along with their respective types. Anytime that we use an OR operator on an argument, here's what is happening behind the scenes. On that argument that we get access to inside of this method, TypeScript is going to do a little paring down operation to limit the number of properties that we can actually reference on Mappable. So anytime we use this OR operator, TypeScript is going to take a look at the two different types. And it's going to say you can only refer to properties on that argument if they exist in both of these different types. So TypeScript is going to look at company. It's going to look at the property name, company name right here. Remember, that's one of the properties that company has. TypeScript is then going to say, okay, does user have a company name? Nope, it sure doesn't. So we are not allowed to refer to company name off of this argument right here. TypeScript is then going to look at catchphrase. Does user have a catchphrase? Nope. Okay, we are not allowed to refer to that. And finally, it's going to go on to location and say, okay, does user have a location? Yep, it does. And is its type a object that has a latitude and longitude that are both numbers? Yep, sure is. Okay, we are allowed to refer to location on that argument. TypeScript is then going to take a look at the user type and iterate through all of this thing's properties as well. It's going to say, okay, does company have a name? Nope, it doesn't. Okay, we are not allowed to refer to that property. Does company have a location? Yep, it does. Okay, we're allowed to refer to that. So the result of this OR operator right here is that TypeScript is going to limit the number of properties that we can refer to on this mappable thing. And you can actually see that in action very easily by writing out mappable. Mappable. Sorry, I got one of these MacBook Pros that is like double typing characters right now. Anyways, if you then write out mappable and then a dot, it will list out all the different properties that you are safe to refer to. And so you'll notice that the only property we can refer to here is location, because that's the only commonality between user and company. So that's why we are allowed to refer to mappable.location.lat down here, and the same thing for the longitude as well. But if we had to refer to, say, a user's name or a company's company name, we would not be allowed to. All right, so this actually kind of works out pretty well for us, right? Because the only thing we really care about is a common property between user and company. We only care about location.lat and location.longitude. So this definitely does work out for us. However, I would suggest that there is still a big downside to this approach. This code works, but it's not perfect, and here's why. Let's start to think about what would happen at some point in time in the future. Where's my diagram? Here we go. So let's think about what would happen in the future if we started to have other things that we want to map on our map or show as a marker on the map. Right now, we just have user and company. But what if we also had something like, I don't know, what would be something else we want to show on a map? How about like a customization of a company? Maybe like a car lot, a place that sells cars. And so we would make a new class called car lot. Maybe we also want to show something that's like maybe a park. So maybe we have a new thing called park.ts. We've got to have a class called park, and so on. For every one of these new things that we want to show on our map, we would have to add on an additional import statement into map.ts. So I'd have to import park, I would have to import car lot, and so on. And for every one of these additional things we might want to map, we're going to have to add in an additional OR case to our method. So add marker, mappable, can be a user or a company or a park or a car lot or whatever else. And I think you get the idea here. So every time we want to expand this repertoire of things we can map, we're going to have to do a lot of adding on here. And if there's eventually like 30 things we want to map, well, we would have a really huge method signature. So this is not really a great approach right now. Number one, because it's not super scalable. And number two, because it's introducing a very tight coupling between our map class and every other class we have in our application that we want to show on the map. So like I said, this is a solution. It is a solution. It would work, but I still don't think this is the best way of going. So let's take one more quick pause. We're going to come back in the next video and finally go to the real solution for this problem. So I'll see you in just a minute. We've now seen several different ways of putting together add marker in a bad fashion. So in this video, we're going to focus on the correct solution, or maybe not the correct solution, maybe the best solution. All right, so let's get to it. Just a quick reminder here, right now the issue with our current approach is that custom map has a direct dependency on all the different classes inside of our application that we might want to show on the map. So custom map depends upon user. It depends upon company. And if we ever had like a car lot or a park or anything else, custom map would depend upon them as well. So to fix this issue, we're going to invert this dependency, so to speak. Rather than custom map depending upon all these different classes, we're going to say, hey, class, user, if you want to work with a map, it is up to you to satisfy the map's requirements. And company, if you want to show up on the map, you have to satisfy the map's requirements. So how are we going to invert that dependency? Well, here's what we're going to do. At the top of the custom map.ts file, we're going to add in a little bit of configuration. And this configuration up there is essentially going to be some instructions on how an object can be an argument to the add marker function. So at the very top of the file, we're going to say, hey, every other class inside of our application, every other class, if you want to be shown on the map, or in other words, if you want to be an argument to add marker, here's what you have to do. So inside those directions, we're going to say to show up on the map, you have to have a location property. Remember, that's the key. You have to have a location property that is an object, and that object has to have a latitude that is a number and a longitude that is a number. Every other class, as long as you have a location with lat and long, then you are eligible to be added as an argument to add marker. So how are we going to put together those directions? Well, we're going to make use of interfaces. Remember, we spoke about interfaces a couple of videos ago, and we looked at a diagram very similar to this. We spoke about how we can use an interface to kind of behave as like a gatekeeper of sorts to a method. So we're going to create an interface that defines what it means to be mappable. We're going to define in this interface a set of instructions to all the other classes inside of our application that tell all those other classes how they can be eligible to be an argument to add marker. So then it's going to be up to all of those other classes to opt in to being mappable. And they can be so by having that location property with a latitude and a longitude that are numbers. So that's how we're going to kind of invert this dependency. Rather than saying, oh, our add marker method has to accommodate a user and a company and a park and so on. Instead, user has to choose to fulfill the interface or satisfy the interface by having the correct properties with the correct names and the correct types. If user does that, then user has qualified to be an argument to add marker. All right, so this is like one of the prime best examples I can show you of interfaces. And once again, like I've said a billion times, we're going to see this relationship right here in every application we're going to work on. So let's try putting together an implementation right now and see what it looks like. So to get started, I'm going to flip back over to my editor. And at the top of custom map, I'm going to define an interface called mappable. So this right here is going to be our instructions to every other class on how they can be an argument to add marker. So every other class can look at this interface and say, oh, I want to be mappable. I want to be an argument to add marker. And if they want to, all they have to do is satisfy the properties we list in here. So to be mappable, to be an argument to add marker, you have to have a location property that is an object, and that object has to have a latitude property that is a number, and a LNG or longitude that is a number as well. If another class or just any other object inside of our application has a location that is a latitude and a longitude, they can be an argument to add marker. So to make sure that's actually the case, the last thing we have to do is go back down to add marker, and we're going to change the type on here. We're going to say to be an argument to add marker, you have to satisfy the mappable interface that we just created, like so. Okay, so that's it. That's the idea. So now we have an add marker function that can take any argument so long as it satisfies interface. So now if we start to add in like a class for park or car lots or a grocery store or dentist or whatever it is, hospital. As long as they satisfy this interface right here, they can be an argument to add marker. One thing I want to throw out there really quickly, because we didn't super closely discuss this when we were talking about interfaces, is that a single value inside of TypeScript can have multiple different types. So even though we're talking about having like users right here in company, an instance of a user has type user, but it can also fulfill the interface mappable. And if it fulfills that interface, then user can also be of type mappable. So a single value can technically have like multiple different types. Just want to clarify that really quickly. All right, so let's take another quick pause right here. We're going to come back to the next video and fix up the rest of our code to make sure that we can pass in a user and a company to this method. So I'll see you in just a minute. In the last video, we got a good solution to our add marker issue. Now, I repeated the same thing in there like 5 or 6 times. Remember, the whole idea here is that we defined instructions on how you can be mappable. So as long as another class has a location with a latitude, longitude that are numbers, it can be an argument to add marker. So take a look at the impact on custom map now. Inside a custom map, we no longer have any direct references to user or company. So that means that these 2 import statements at the top of the file can be deleted. So we now have a standalone custom map class that we could very easily reuse on future projects as well. In fact, if you ever want to show a Google map in the future, save this file. Like really, save this file. Because as long as you have any other object on any other project you work on that satisfies this interface, this class is going to work for you. You can use this exact class right here to show a Google map and then show different markers on it. All right, so last thing I want to do inside this file, I'm going to delete that add company marker method down here. We don't need this anymore. Looks good. Now, last thing I'm going to do is flip back over to index.ts. And we need to fix up the references to the methods that we deleted. So add user marker no longer exists. It's now going to be add marker. And same thing for add company marker as well. That's also going to be add marker. So notice how TypeScript has no complaints about these 2 lines of code. Remember, here's what's going on behind the scenes. When we tried to pass in user to add marker, TypeScript is going to take a look at add marker. It's going to see that the argument must be of type mappable. To be mappable, you have to have a location with a latitude and longitude. So behind the scenes, TypeScript is automatically inspecting what type user is. And it's checking to see if user satisfies the mappable interface. So TypeScript is going to look at our definition of what a user is. It's going to see that user has a location, a latitude and a longitude that are numbers, and because it has those, it satisfies the mappable interface. So TypeScript has no issue with us whatsoever passing a user into this method because user correctly implements that interface. Remember that that comparison of looking at user and making sure it has all the correct properties is invisible and it occurs behind the scenes. So we did not have to add in any code whatsoever to say, hey, TypeScript, make sure that user is mappable. We didn't do anything like that. We never said anything inside of our user class to say specifically, hey, this thing is supposed to be mappable. Never did it. TypeScript is doing that comparison for us automatically. We refer to this as an implicit check. TypeScript is implicitly, or kind of behind the scenes, automatically making sure that user has the correct properties with the correct types inside of it to be an argument to add marker. All right, so last thing here, I'm going to save index.ts. I'm going to flip back over to my browser, refresh, and everything still works as expected. Perfect. Okay, so this looks pretty good. So we've now seen something really awesome around interfaces. But we're not done yet. Let's take a quick pause. When we come back to the next video, we're going to add in one more feature to this application. So quick break, and I'll see you in just a minute. In this video, I want to start to add in one last feature to our application. I'm at the Google Maps documentation right here. Don't worry about pulling this up on your own screen. I just want to show you something really quickly. Notice how there's a marker right here, just like the marker we have placed. If I click on that marker, I get a little pop-up right here that has some information that's relevant to that marker. So that's exactly what I want to make inside of our application. I want to make sure that anytime that we click on one of our markers, we show some information relevant to the company or the user that this marker represents. So let's figure out first how to just open up a window like this. To do so, we could either read our type definition file again, Or in this case, we could just read the official documentation. In this case, we're going to take a look at the official documentation because showing this info window is a little bit more complicated than adding the marker or showing the map. Okay, so really quickly, let's take a look at the documentation. So there's a code snippet right here for the map we were just looking at. So the first thing they do is create a string that contains some amount of HTML that will be shown inside of that pop-up window. Then immediately after that, they create an instance of something called an info window. The info window is the pop-up. So this is going to be an instance of a class or an object that represents the pop-up window. When they create the info window, they pass in the content that the window will display as an option. They then go on to create a marker, and then finally they add an event listener to the marker itself. So anytime the marker gets clicked, they find the info window, they call the open method on it, and they pass in the map that they want to show the window on, and the marker that they want to show the window above. And that's pretty much it. So we could look at our type definition file again to understand how to do all this stuff, but like I said, in this case, creating an info window is a little bit more complicated, so I just want to take a look at the official documentation really quickly. Now, having said that, let's take a look at the type definition file anyways, and just try to find where the info window is defined inside the type definition, and where we can find like all the possible options we can pass in to customize the info window as well. So back inside my editor, I'm at custom map. I'm going to do another command click on google.maps.map. That's going to pull open the type definition file for Google Maps. And inside of here, I'm going to do a search for info window. And we're looking for class info window. There it is right there. So to get a good idea of how to use this info window, we could either read that official documentation or read the type definition file. You'll notice that there's actually comments inside of here to help you understand how to use it. So here's the constructor. Remember, this thing gets called anytime we create an instance of a class. So in other words, anytime we have like this right here, new info window, that is us calling the constructor. So this object right here that gets passed in is going to be an argument to the constructor. So that means that options object is going to be this argument right here, and that object has to satisfy this type. So we can look at the definition of this type and understand what different options we can pass into the info window. So I'm going to again command click on info window options right here. And like I said, this will tell us about all the different properties we can pass into the info window when we create it. So you'll notice one of the first options right here is content. So like we just saw, content is going to be the HTML or the plain string that will be displayed inside the info window. So we could also take a look at some of the other properties we can pass into the info window when we create it. None of these other ones are super relevant for us, but just wanted to remind you that we can take a look at the different options by referencing the type index file, as opposed to trying to find the different options inside the official documentation. All right, so I think that's enough of the type definition file. Again, I just wanted to remind you that we can figure out how to use an info window by looking at this stuff instead. All right, so I'm going to go back over to my custom map class. Now to get started, we're just going to try to show a plain info window with some generic content inside of it. I'm not going to worry about showing some information about a specific user or company. Let's just get like some hi there or like hello world text inside of an info window. So to do so, I'm going to go down to my add marker method. So anytime we create a marker, I'm going to assign that marker to a temporary variable, like so. Then I'm going to add an event listener to the marker. So anytime we click on this marker, we're going to run a function, and inside that function is where we are going to create our info window. So I'll say marker.add listener. Anytime that thing gets clicked, let's run this function right here. So then inside of here, we can create our info window. So I'll say const info window is new google.maps.info window. We're going to pass in the options object. Remember that options object can have a content property. So I'm going to say that anytime we show this info window, just show some content inside of it that says hi there, like so. And then finally, we'll do an info window.open, and I'm going to pass in a reference to the map that I want to show this window on, and a reference to the marker that we're going to show this above. So the map we're going to show this on is going to be this.Google map, because remember we stored a reference to our Google map as a property of our custom map class. And then the second argument will be the marker that we want to show this above, which is the marker we just created 2 seconds ago. Now, one thing I want to mention really quickly, I know back over here in the code snippet, they first create the info window, and then later on, once the marker gets clicked, they only call info window.open. So we're doing things just a little bit differently. We are saying we're not going to create the info window until the marker gets clicked. Honestly, there's no difference. You could just as easily move the creation of the info window outside of the event handler. It's totally up to you. No difference whatsoever. But I'm just going to put it inside because I think the code makes just a little bit more sense this way. All right, so let's save this and we'll do a quick test back inside of our browser. So back inside my browser, here we go. I'll do a quick refresh. And now if I click on a marker, I should see a pop-up appear that says, "Hi there." Perfect. All right, so this looks pretty good. Obviously, the only downside here is that we don't have any customization of these pop-ups for a company or a user. So I don't even know if this marker represents a user or a company. So let's take another quick pause right here, and we'll figure out how to fix that up in the next video. We are now able to show a little pop-up window anytime a user clicks on a marker. So this is definitely a good advancement, but now we probably want to customize the content inside of that window. So let's flip back over to our code editor and figure out how we can do this. I'm still looking at add marker right here. Remember, the content that gets shown in the window is going to be assigned to this content property when we create the info window. So the real question here is, how are we going to customize this content? We probably want to customize that content depending upon whether we passed in a user or a company as an argument to add marker. Or put another way, put it more precisely, we probably want to make this content right here a responsibility of this argument. In other words, we want this argument, this object, to have some property or some method attached to it, and anytime we reference that property or call it, it should return some string that will be displayed inside of the info window. So in other words, what we're doing here is adding in a new requirement for this argument. We're saying that now, in order to be considered to be mappable or to be an argument to add marker, you have to have a method. Anytime we call that method, it should return a string, and that string will be some HTML to show inside the info window. So in order to update the definition of this argument, we're going to add a new requirement to this interface. So remember, we defined mappable at the top of the file. I'm going to go back up here. So we're going to say that now, in order to be considered to be mappable, to be an argument to the add marker function, you also have to have a property called, how about marker content? This has to be a function, and anytime we call this thing, you have to return a string. So we've now added in a new requirement to our interface. If we save this and then flip back over to index.ts, you'll notice that we now have an error around add marker and add marker right here. If we hover over the arguments, you'll notice that it says property marker content is missing from user, but it's required by our interface. So we just updated the interface. We added in a new requirement to be an argument to add marker, but user and company do not yet have that property. So we now have to go back to our user definition, our user class, and our company class and make sure they satisfy this new requirement. They both have to have a method called marker content, and they have to return a string. So let's try doing that right now. Back inside of user.ts, I'm going to go down to the bottom of the class underneath the constructor. Usually our constructor method is going to be at the very top, right after any properties we want to list. And then right here, we're going to add in marker content. This is going to be a function. Anytime we call it, we have to return a string. So then inside of here, we will return, how about just like user name is, and actually, you know what, let's use a template string here. So I'm going to use backticks instead, just to kind of inject the username. So I'm going to place the backticks, and we'll do this dot name like so. Okay, so now user has a marker content method that returns a string. And that means that now user satisfies our mappable interface. It has all the different properties that mappable is required to have. So if we now go back over to index.ts, you'll notice that the error is gone. So now we can repeat the same process for company as well. I'm going to go back over to my company. Here's class company right here. And again, at the bottom of the class, I'm going to add in a new method called marker content. It has to be called marker content because that's what our interface right here is requiring. We cannot just arbitrarily name the method something different inside of company. The interface is going to look specifically for a method called marker content. So back inside of company, here's marker content. We're going to annotate it as a return type of string. And then inside of here, we can once again return something like company name. And we'll print out this .company name. And you know what, just for fun, let's also show the company catchphrase as well. So inside the string, I'm going to turn it into a multi-line string like so. And then we'll do catchphrase is this .catchphrase. Remember that these strings can actually be HTML. We just saw that inside of the type documentation file or the type definition file. So if we wanted to, we could also wrap the company name with an H1 tag. And maybe the catchphrase gets like an H3. And then let's just wrap all this with a div. Like so. All right, so that looks pretty good. Now, one thing I want to mention here about this interface stuff, you'll notice that marker content right here is just saying we have to return string. That's all it's saying. This interface is not going to somehow make sure that we are returning like the correct string from marker content. So inside of company.ts, if we put some like completely gibberish string inside of here with some nonsense HTML, TypeScript's not going to complain at all. The only thing TypeScript is doing is making sure that we have this method that returns the correct type. If we goof the implementation of the method, that's still on us. TypeScript can only do so much. Okay, so now we got the new definition of marker content in both our company and our user. They are both now satisfying the updated interface. So they can continue to be arguments to add marker. You'll notice that both those errors have now gone away. So now the last thing we have to do is go back over to custom map. Down inside of the add marker function, we still have a hard-coded string here of hi there. So now we're going to say, rather than using that hard-coded string, take a look at that mappable argument, the argument that we passed into add marker. Mappable now has a new function tied to it called marker content. So now anytime that we click on the info window, rather than showing simply hi there, we want to show the content that comes from that marker content function of the argument. So we'll do mappable dot marker content, like so. All right, so that's pretty much it. Let's save this thing. I'm going to flip back over to my browser, do a refresh, and then I'll click on one of these, and I see username Enik, or Enik, I suppose, pop up. And if I click on the other one, I'll see an H1 and an H3 for the company name and catchphrase. So that's it. All right, so this has been a lot of fun here. Let's take a quick pause and we'll do a wrap up in the next section to make sure, once again, that we understand what's going on with this interface. And you know what, actually, now that I think about it, there's one last little bit of code I want to add in this project just to show you something very quickly. So quick pause and I'll see you in just a minute. Our application is now feature complete, but I want to mention one last thing around interfaces. Just a second ago, we added in a new requirement to our interface. We said that in order to be considered to be mappable, an object had to have a marker content method that returned a string. When we added in that additional requirement right there, we saw errors pop up inside of our index.ts file, specifically where we were passing in user and company to add marker. I want to try adding in a new property to interface mappable back inside of custom map and just see errors pop up again. So inside of custom map, I'm going to say that anything that wants to be considered to be mappable has to also have, how about a color property that is a string, like so. Now, as soon as I add that in, I'll see my index.ts file light up. If I open that, once again, I will see errors around user and company. So the discussion I want to have here is around where we see error messages. Remember, the entire goal of TypeScript is to help us find errors in our code. And so part of that process is making sure that TypeScript can point us in the right direction and help us find like the root source of an error. So in this case, we added in a new requirement to an interface, and we're seeing an error appear where we actually try to pass in some value to this function. Now, I'm going to suggest that maybe this is not the best place to see this error message. Think about what we would have to do to fix this error at the end of the day. If we want to make this error go away, we have to open up our definition for a user, like the user class, and the company class, and modify those classes. In both those classes, we would have to add in a new property of color to both of them. So because we would have to open up those class definitions, seeing the error here is not super useful. It is useful to see an error, absolutely, but it's not really pointing us to the exact location of where we should go to fix this problem. So I want to tell you how we can add in a little bit more code to help TypeScript point us in the correct direction. Here's what we're going to do. Inside of custom map, I'm going to add in an export statement for the interface that we just added. So we now have export interface mappable. So this is going to make the interface, we can import this into other files and refer to this as a separate type. So now I'm going to go back over to user.ts, and at the top, I'm going to import that interface. So I'm going to import mappable from custom map. And then inside of here, I'm going to add in right after my class definition, I'm going to say implements mappable. So what this does right here is it tells TypeScript we want to make sure that an instance of class user, like a user that we create, satisfies all the properties required by the mappable interface. This sets up a very direct dependency between our user class and the custom map class, or technically the custom map file, I suppose. So we've now declared our intention to TypeScript. We are saying we want every user we create to satisfy that interface because we eventually want users to be an argument to that add marker function. So by adding in implements mappable right here, we are telling TypeScript, help us make sure user is implemented correctly. Help us make sure that user has all the properties specified by mappable. If we now hover over user, you'll see that it says, okay, property color is missing on class user, but it's required by that interface. So now we have an additional error message inside of here that can help us pinpoint the source of the error in our application right now. We have something that says very specifically, hey, your class user is not implemented correctly. So we're still seeing an error message, just like we were seeing before inside of index.ts, but now the difference is that TypeScript is helping us point out the true source of the error. It's helping us understand that if we want this error to go away, we have to update our user class definition. So as you might guess, we could fix this up by adding in a color property that is a string, and I'll initialize it as like, red or something like that right there as well. And as soon as I add that in, error goes away, and the number of errors inside of index.ts goes down to 1. So again, the entire idea behind this implements clause right here is we are telling TypeScript, help us satisfy this interface. We want to make sure that user can be considered to be mappable. And so TypeScript is going to do some additional checking of our class and make sure we have all the correct properties. You do not have to do this. This is not required at all. The reason we would decide to add in this implements clause right here to a class is so that if we fail to properly implement an interface, TypeScript can point us to the true source of the error, our definition of the class, as opposed to when we try to pass a value or an instance of that class into a given function. So if we wanted to, we could go through the same process with the company as well. Inside of company.ts, we could add in an import statement for mappable from custom map. And then I'll say implements mappable. And now once again, we get an error on company, and it tells us we have to have color that is a string, but we did not provide it. So if we add in color, that is a string, and I'll just say red like so right there on the same line, error goes away, and we're back to being perfect. All right, so again, 100% optional, totally up to you. You will see some projects that use this implements clause extensively to make sure that it's really clear to TypeScript and even other engineers that we are trying to make sure that class company satisfies that interface. If you don't put it in, no problem. The only thing it's going to do is help TypeScript help you and help other engineers understand what you are trying to do. Okay, so quick pause right here, and we'll wrap up this application for real this time in the next video. All right, my friends, we've now finished up our first application. In this video, I want to do a quick review of the very important concepts we learned. So the first important thing that we covered was that we wanted to restrict the amount of API surface area exposed inside of index.ts. So in other words, if another engineer opened up our project and only had access to this file right here, we wanted to limit the number of things that they could do. they could only do things that you and I had specifically allowed inside of our application. So for example, another engineer could only create an instance of a user and read its name property and its location. Another engineer could only create a company and then reference its company name, catchphrase, and location. And with a custom map, another engineer could only create an instance of a custom map and then call that addMarker method. And as far as our code is concerned, that's the only thing that other engineers can do inside of here. The most important aspect of this was that we wanted to restrict access to that Google map that we created. Because remember, the Google map had a ton of different properties associated with it. So to make sure that other engineers could not mess with this thing, we added on that private modifier. The private modifier means that we can only reference this property from methods inside of the custom map. So for example, back inside of index.ts, if we tried to refer to custom map.googlemap, we got that error message that said, this is a private property and you cannot access it unless you are inside of the class custom map. Now, I know 100%, I know what you're thinking, but Steven, other engineers can just open up this file and start calling this or accessing this property directly from inside this class. Yes, I agree with you. Another engineer could open up this file. But the idea here was simply that if we viewed custom map as being like a black box or kind of like a mystery thing of sorts, we limited the damage that other engineers can do. So we just exposed the bare minimum amount of functionality to allow our application to work and nothing more. So another engineer absolutely can open up that file, but if you just kind of view this variable right here by itself, there's only two things we can do with it: create an instance and add a marker. That's it, nothing else. The next big thing we spoke about was our interface inside of custom map. So we ran into many issues around this addMarker function. We initially saw that we had two different addMarker functions, one for business, or one for companies and one for users. And when we had that duplicate definition, well, we had a lot of duplicate code. So as an initial approach, we tried to say that addMarker could take many different types. So we had addMarker, and we said that you could pass in a user or a company. And then if we had additional types inside of our application in the future, you could pass those in as well. And so the bad thing about this approach is that it set up a dependency between custom map and all the different things that we would want to map inside of our application. So as soon as we started to add in more things that could be represented on the map as a marker, well, we had to go back and update custom map, which would have been a very easy time for us to accidentally introduce bugs into our application. So to fix this problem, we inverted the dependency here. We said, instead of custom map trying to accommodate all these different classes, we instead say, hey, other classes, you have to accommodate custom map. So inside of custom map at the very top, we put some instructions on how another class or instance of the class could be an argument to addMarker. We did that by defining an interface. So that was equivalent to custom map kind of standing up for itself. Custom map got up on a podium and it said to all the other classes inside our application, hey, other classes, if you want to be an argument to addMarker, here's what you have to do. You have to define a location property that has a latitude that is a number, longitude that's a number, marker content that returns a string, and color that is a string as well. Remember that we did not specifically have to update those classes and tell TypeScript, hey, I want my user to be an instance of mappable. We added this on only way later inside the application. So we did not have to specifically say, hey, TypeScript, we want user to be an argument to addMarker. Instead, as long as we had the correct properties, TypeScript did the appropriate checking for us invisibly behind the scenes. As soon as we tried to pass in user or company to addMarker, TypeScript automatically took a look at user and made sure it had the correct properties. As long as it did, awesome, thumbs up. You can be an argument to addMarker. So again, the whole idea here was that we wanted our custom map to tell other classes what they had to do to be an argument. Now the pattern you see right here is going to be a pattern that we repeat so many times, again and again and again and again. Remember, I've told you many times that, or at least once, I should say, that in TypeScript, the big thing we want to learn, and like the big killer feature of TypeScript, is the interplay between classes and interfaces. And that's exactly what you are seeing right here. This right here, this is the killer feature of TypeScript. And this is how we're going to write awesome code. So just about every project that you and I work on is going to have an identical structure. Every TypeScript file we work on is going to be something like this. At the very top, we're going to have a number of interface definitions. Maybe it's 1, 2, 3, 4, however many. And those definitions are going to describe what you have to do to work with the class. So our class definition will have a couple of methods, and if a given method has to receive some other object to work correctly, rather than specifying that other object type, we're going to instead specify an interface. So other objects inside our application can choose to implement that interface so they can work with this class definition. And that's how we're going to get this awesome amount of code reuse and very low coupling between different classes inside of our application. I can't say it enough. We're going to see this pattern again and again. This is the whole point of this course, is to help you understand this pattern. Well, a couple other things as well, but you understand. Okay, one last big thing here. Last thing I want to mention is that if we wanted to, we could help TypeScript give us help. So when we start working with this interface stuff, we want to make sure that we start to see errors in the correct location. So to help TypeScript show us errors in our interface definitions in the correct spot, we can optionally choose to implement an interface. So inside of user TS, we imported the mappable interface, and we told TypeScript very directly in this case, hey, TypeScript, we want our class user or an instance of user to be compatible with the mappable interface. So to do so, we optionally add on implements mappable right here. And that tells TypeScript we are trying to make a user satisfy the mappable interface. By adding that in, TypeScript is going to take a look at our user definition and make sure that we are implementing the correct properties. Again, 100% optional. The only reason we do this is so that we can kind of help other engineers understand what we're doing with this class right here. So if another engineer saw this statement, they would understand, oh, okay, I get it. We want a user to be mappable. The other reason we add this in is so that TypeScript can take a look at the different properties here and help us make sure that we add in all the correct properties. Okay, so that's it. That's the 3 big important things here. Once again, inside of index.ts, we wanted to restrict API surface area. Second off, we wanted to use interfaces to set up a type of dependency between the different classes inside of our application. And then finally, we can help TypeScript put errors in the correct location by using this implements clause on classes. So with all this in mind, let's take a pause right here. We're going to go in the next video and start working on our next application.